All right, so we've got a pretty full schedule today. And before we start, I'm just gonna see if I'm missing anyone. Oops, got the wrong camera out.
Check one, check.
Yep, that's working. I have an Eric Boaz here. Who are you? Which company are you with?
City of Martinsville.
What was that again?
City of Martinsville, Virginia.
Martinsville. Okay.
The City of Martinsville, Virginia.
Yeah, I've got that.
That or not.
He's with me at the City of Martinsville.
Almost done. Okay, so I have everyone listed here. Let's see if I'm missing anyone. All right. So I'm still missing a few here. So what we'll do is I'll introduce myself. My name is Darren Iwaniuk. I'm the technical support manager for Harding. I'm also in charge of scheduling training sessions. Normally, actually, I wouldn't be training today. My assistant, Peter Nunes, does the first 2 days of training, and I normally do the third day of training. However, Peter is still out with the flu or something, so he's not available today. So I will be doing the training today and tomorrow, as well as the host training on Thursday. So I'm worked with Harding for 26 years now. So I started with the development on our original DXI system, and that carried through to our DXL system. So originally with our DXI system, we had engineers doing development work, but we didn't really have many people assisting customers other than the engineers doing the development. So at one point in time, we just had too much activity, so I was dedicated to doing the technical support. So I've kind of been doing that for about 23 or 24 years. And I know our system. I've been to a few jail sites. We don't normally do any installs, but I do occasionally go over to a site if there's any problems. Sometimes we get hired to do commissioning, but like I said, we don't do any installation. That's your responsibility as your integrators, the end users, whoever does the installation is not us. So we don't want to compete with our customers, who are the people doing the install. So we don't do any direct install. We don't do any assistance like that because we don't want to compete with our customers. So anyways, I've been working with Harding for 25 years, 26 years, and I was originally a programmer on the DXI system, kind of carried through to technical support. So I know our system. I know how it's used. I know, I've been in jails. I know how it works. Our system is used pretty much 100% in jails. It's designed for jails. So that's what its sole purpose is for. I'll get into later what other reasons that our system is installed for, but it's primarily for jails. That's what it's designed for. That's what it's built for. So that's me. I've basically been with Harding for a while. I know our system. I'm your go-to guy if you have any questions about your specific project. If you have any unique features that you want, we can probably do it. I can talk you through how to do it. I'm also your go-to guy if you want to know how to integrate our system with your control system. The intercom system is normally a small part of your overall jail system. You have your locks, you have your cameras, you have your control of power and water, you have your duress systems. This is going to be a part of your system, and we want to make it to be easy to integrate with the rest of your system so that you don't have to do a large amount of coding in order to work with our system. It's designed to work as part of your overall jail control system. Peter Nunes, who is my assistant, who is not able to attend today, he's also in technical support, so he's also available to answer questions. He is more expertise on phone integration. I know a little bit about it, but he's had a more broader experience with telephone systems, and as well as with our intercom system. He's been working with us for, I don't even remember, about 10 years now. So that's what. See if I've got any more people that's in the lobby. No, we're good. Okay, so maybe we'll have you guys introduce yourselves. You don't need to be a full introduction, but what I would like to hear from you is what you are interested in, what you want to take away from this session, so I can make sure I can tailor the session to make sure that I've got all of you covered. So starting with Ahmed.
Yes, good morning, everyone. I am actually from Delco, and I am taking this session in order to actually start how does the system works and how actually we configure it on site, and what are the key takeaways that how can actually we get it the best out of the system.
All right, thank you. Amandeep?
Morning, this is Amandeep from Delco Automation, Saskatoon, and I'm very new for this system, so I want to learn from the basics up to the programming of all the system. Thank you.
All right, thank you. Next is Babak. How do you pronounce your name?
Bobak is my name. Good morning. I am also from Delco Automation, and I'm interested to know more about the details of your products and implementation in the site, and also advanced features of your product for many other applications like PA or public addressing. Yeah.
All right, Blue Thompson?
Yes, good morning. Can you hear me?
Yep, I can hear you. We can hear
Great. I'm with BI Construction. Very much interested in learning the basics, how it works and how it integrates with Genetec and PLC integration.
All right, so for the PLC integration, that's an optional third day, so that will be Thursday morning. So if you are interested in that, I'm just kind of noting you down as to the people who may be interested in that. So that will be a session on Thursday morning for that.
Cool.
All right, next on the list is Kurt Carlisle.
Morning, I'm looking more for we've already got it in place and trying to help with troubleshooting and understanding the system better.
All right. Chris.
Good morning. Hi, I'm from Lethbridge. We recently won a tender. We'll be installing one of your systems at the Lethbridge jail.
All right. Clayton.
Good morning. I'm with Delco. Currently installing one in the Nanaimo Corrections in Vancouver Island, and just here to learn more. I've done field devices in past. Now I'm more into the head end and programming side of things.
Okay. David Olchowski.
Hi, sorry, I'm just got some mic issues here. You might need to mute the mic. Yeah. Oh, sorry, 1 second here.
Okay, you just mentioned he's got sorting out some mic issues right now. I'll continue on. I'll come back to David a little later, once at the end here. Next one is Ebson.
Hi everyone, I'm with Delco Security. I'm looking to get more understanding on the servicing and troubleshooting side. Thank you.
All right. Eric Boaz.
Hey, I'm Eric from Martinsville, Virginia. Was kind of volunteered to take this class. Our system at the jail was installed by someone that's no longer in business, so I'm hoping to learn how to fix this thing, I guess.
Okay. Andrew Escobedo.
Test.
There you go. Oh, who was testing?
Oh, that's me, David.
Okay.
I can go ahead if you'd like.
Okay, go ahead.
I work with Carlin Cada. This is actually my second time through the training. I took it a couple of years ago, and I'm just getting some updates here, just so we can make it a little easier for our installs and going through with servicing. So take a little bit off of your tech support, guys.
All right. Going back to Andrew. Andrew, were you able to talk out?
Hi, this is Andrew Escobedo. I'm also speaking on behalf of Brian Henniger. We're kind of sharing a mic right now, but we're here for troubleshooting and trying to get a better understanding of the hardening systems.
All right. Garrett Aspen, or yeah.
Hi there. So my name is Garrett Aspen. I've been with Delco Automation for about 4 years now. This is also my second time taking this training, and just excited to know some more advanced features of the programming, and particularly the phone integration and the soft phone integration as well.
Okay, good to know. We'll make sure I cover those. We've already got Brian Henniger covered. Jacob Chavez. Is Jacob or anyone else from CML here online?
Yes, he's here. He's having mic problems.
I think you should repeat that all again.
Go ahead and repeat that, Jacob. Darren, are you still waiting for Jacob?
Yeah, just or just you know, what if you guys let me know what you all are interested in. Oh, still don't hear anything.
No. Can you hear him now? Yeah, can you hear me now? Yeah, you're gonna have to talk.
Yeah, we're having some feedback issues. Yeah, Jacob was just saying he wanted to learn more about hardening and troubleshooting. Yeah, we're all in one conference room.
Okay. And Jacob Connor from Linux.
Yes, sir. So we're interested in integrating Harding. We take care of most of the prison systems in Missouri, and they're all Duquesne systems. So we're doing a lot of upgrades to Harding DXL and trying to figure out how to integrate all the PLCs.
Okay, so as I mentioned, we'll have a third half day, which will cover all the integration with PLCs.
Yes.
So that will be on Thursday morning. Okay, next is Jared Pruitt.
Hey, my name's Jared. I'm also with the city of Martinsville. Just trying to get a system that got water damage back up and going after the company that installed it went out of business. So we're just trying to figure out how to do it on our own. We can.
Okay. Almost done. Jeff Rodriguez. Oh, that's another one you guys from CML. Okay, yeah. Jimmy Israel.
Jimmy may not have a microphone.
Okay. Anyone else from Navajo Nations or online here, or is it or Hadobe?
Yes, we're here.
Okay. Okay. Who's speaking?
This would be Ted. Ted speaking for Sheridan, Lamoni, Tim, Jimmy, Derek, and Morrison.
Okay.
What we're interested in is where we have 2 individuals who want to learn the system from the ground up. We have 3 maintenance representatives from 3 different facilities who are looking to continue to maintain their system that they currently have installed, a 4th brand new system being installed from the ground up. And then from Hadobe, we have 2 individuals that are here to learn about the PLC integration and 2 that are interested in learning from the ground up.
All right. Make sure I got everyone else covered here. I have Joel Foreman. I didn't write down what company you're with, so if you're online, just just give me a brief outline of what you're looking for and what company you're with.
Hi, so I'm with Douglas County, Colorado, along with Mark Eckert, Hart, and Patrick Haas. We're looking for, I guess, kind of basic architecture of the system so that we can troubleshoot and further how to integrate it with our other systems.
All right. And I think I already got John Crosby for CML. All right, so I think that's all of our attendees we have for now. I'm just gonna check to make sure there weren't any more waiting in the lobby. It doesn't look like it. All right, so with all that started, we'll get into the training program. So I'm gonna go and show you the outline. Those of you, I'll let you know what parts of the day cover which topics. So some of you might have, particularly if you're only interested in the maintenance topics, that's going to be tomorrow. But the next slide is just going to go over what we're covering. So module 1 is going to be this morning. So that's what we're going to cover this morning. So it's going to cover basically an overview of Harding and the MicroComm product line. And then we're going to get into the DXL system, the basics of it, the naming of our product, the going over what each of the devices does, and kind of just the overall layout of our system. So this is kind of just a really basic knowledge about what the components of our system are. So that's going to be this morning. This afternoon is going to be more along the design of the system. So it's going to be what kind of wiring networks do you need? How are things connected together? And just an overview of what you need to do to plan for a system. So that will be covered this afternoon. The interesting parts for many people is going to be what's happening tomorrow. So module 3 is tomorrow morning, and that's going to go over the DXL Administrator software and using the DXL Administrator software to create your project configuration. There will be a little bit of the original install as to how you load that software onto the system, how you load the configuration onto your system. Now, those of you who are doing this, we recommend that before we start the day tomorrow, so at the end of the day today, you go onto our download site and download the DXL Administrator software and at least install it on your system if you want to go through and follow through with your own system tomorrow or follow through with your own configuration tomorrow. So we'll kind of cover a little bit of that at the end of the first day. But if you don't attend that part of the first day, if you can, it'll save you time to just make sure you have the software installed tomorrow morning. And I'll go over the links to our download site that you can, if you don't have it, the meeting schedule, the meeting invite should have a link to our download site, but I will mention it as well shortly that you can, if you don't have that link, you can download it. Actually, I'll go put it in the chat notes right now.
Quick question about that administrator software, Darren. If we're running an older version instead of the newest version, is that still going to be okay, or would you prefer everybody to be up to the latest version?
No, you can use an older version. If you're using a really old version, some of the options I'm going to show that might not be on your screen, but all of this stuff I'm going to discuss is basically going to be stuff that's been on the software for years. So you just might see it a little bit different, a couple extra options on my screen than you have, but I'm not going to really cover those extra options. So you can certainly use an older version software if you want. All right, so our download site is at harding-tech.com/downloads.html. I put a link in the chat. Make sure the link works. Yeah, the link works. So that's where you would get our training materials that we're covering today are also on that site. So there's a training directory on there that's going to have the PowerPoint presentation. It's going to have all the documents that I'm going to be going over the next couple of days. So tomorrow morning is going to be covering the DXL Administrator, how to basically use the software to plan your system, to configure your system for your specific project. Tomorrow afternoon is going to be of interest to the technicians and maintenance. So it's going to be using the DXL, again, part of it's going to be using the DXL Administrator, which is going to be the installation and troubleshooting portions of it that you can use to show you the logging system. We'll show you the diagnostic features. And then we'll go over the installation process, what you need to do to install the system, to load the software on, to prepare your systems for adding all of your components to your system, and also regular preventative maintenance. So what we have on this middle screen here is a DXL system. And so Much of the maintenance will be done through the screen, which you can actually go physically to the unit to see the screen, or you can use the DXL administrator software, which will also give you a local version of the screen. So you don't have to physically go to that equipment room. You can have a maintenance computer in your maintenance shop, or if you're an integrator, you might have just a computer in your office, and you can, if you have remote access to the facility, you can do a remote access to the units in the actual facility. So if the facility reports a problem to you, you can use your remote connection, dial up to the system, or not necessarily, you don't necessarily have to. We do have a modem access, but in most cases, people are going to use an internet access. So you get internet access to probably a workstation on your facility that you've got secured access to that has the DXL administrator software running, and you can take a look with the administrator software, take a look with the remote front panel, and find out what's wrong with the system without having to actually send someone to the site to fix it. So you can find out what's wrong, and if you do need to fix something, your maintenance guys will know what parts they need to bring, what they need to do to bring the system operational without having to send someone blind to site, find out what's wrong, and then go back and get the parts needed. You can find from the system what you need. So that's the fourth module, which is tomorrow afternoon. And then the optional session, if you're not a programmer, but the optional session, which is going to be Thursday morning, is going to be the integration with a PLC or a touchscreen system. So that's controlling the intercom system from your computers, workstations, touchscreens, PLCs, whatever. So that's going to be the optional fifth session, which is going to be Thursday morning. So anyone interested in programming and really only programming, this is the session you'll need to go to. I recommend at least the first half day to know what the components are, but that's optional for you. So now that you know the different modules we're doing, you can then decide which sessions you need to attend or you want to attend, and then you can go from there. So every half day, I'm going to try to end things at a fixed time, so we're always going to start the session at the same time. So today we're going to start the afternoon session at 1 p.m. Mountain Time, and the same thing's going to happen for tomorrow as well. So our sessions, the morning sessions, get started at 8 a.m. So if you're interested in that module, make sure you're there by 8 a.m. The afternoon sessions will start at 1 p.m. So it gives people who only need to attend certain sessions, you have a definite time that we're going to start discussing that session. And then we'll end, if we end today early, or this morning early, we may end at say 11:30. That means you have an hour and a half break until the 1 o'clock p.m. Session for that. So it depends upon when we stop. At the end of the session or on our breaks, I'll give you a question and answer time. So if you have any specific questions about your facility, that's the time to answer them. Because we have a fairly full session today, I'll try to answer any questions you have, but if it takes a long time, I'll probably recommend that you bring that up again at the break or at the end of the day session. Do I have any questions right now? You can use the raise hand option on Teams if you do have any questions, and I'll be able to see that you have any questions, or you can break in with the microphone. So we'll go and get started now. So just a brief introduction to Harding. So Harding is located in Edmonton, Alberta, Canada. We were started in 1969 as an offshoot. Our namesake founder is Patrick Harding. He was a professor at the University of Alberta. Computers, microprocessors were a very new thing at the time. And so basically he was a up-and-coming instructor for microprocessors. And he spun off Harding Instruments as basically a commercial way to harness the power of the up-and-coming microprocessors. Of course, computers are in everything we make nowadays, including our microwave ovens, and even clock radios now have computers in them. So computers obviously have really exploded since then. In 1974, we started manufacturing devices using microprocessors. We have a lot of experience in telephone products, microprocessor products. Being in Alberta, it's a really big oil country. We started in a lot of oil and gas devices. We've diversified since then. Oil and gas is really only a very small portion of what we do now. It used to be a really large portion. We manufacture all of our products here in Edmonton, Alberta. We don't contract out to China. Stuff is made here, we design it here, we make it here, we maintain it here, we can repair, we do our service here. We don't just take a car and throw it out, we fix it. We're registered to ISO 9001, which basically means that everything that we do is tracked. All of our manufacturing design processes, manufacturing processes, they all have a definite plan. They're tracked throughout the way. Every one of our products has a unique serial number. We can identify what processes that device has gone through, who had tested it, all of the information about that product by looking at the serial number. And our thought process, our motto is design and manufacturing excellence. We both design and we manufacture our own equipment, and we do the best we can. So you see some of our processes here. So this is our pick and place machine that does the assembly of components onto the printed circuit boards. We have techs that do the installing or install any other parts that aren't installed by the machine. We have our repair techs, and we have a laser engraver that you can custom engrave intercom faceplates. Let's see if I've got one here. I have one up here, but you probably can't see the engraving on it, so I'll go over that a little later. For our intercom products, so as we started as kind of a microprocessor specialist, one of our jobs at the time was basically we were able to do custom design of systems using microprocessors. So our first intercom system was a product of that. Is we had a recent a local jail. For those of you at Delco, you might know, or same the Lethbridge guys, the Fort Saskatchewan jail in Fort Saskatchewan, Alberta. It's just about a 20-mile trip from our office here. Is they needed an intercom system that wasn't really available at the time. They wanted features on an intercom system that just no manufacturer made. So they came to us for a custom electronics design for an intercom system for the Fort Saskatchewan jail. So that's what resulted in our first intercom product. We realized that, hey, this might be a really good market to go into. So we did a lot more research. So this first system was called the HI 1000, Harding Instruments 1000. So we did a little bit of research, and in the meantime, as we were doing research, we figured we'll take the existing Fort Saskatchewan system and we would market it to other up-and-coming jails. So the minor upgrade was what we call HI 4000. It was still a really controlled system that was it was computer controlled. After the results of our research, we contacted architects and facilities. We came up with a design for a completely new system, what we call our DXI system, which is the predecessor to DXL. So DXI system was designed specifically for jails. It was designed specifically for modern jails that allows for flexibility as to where the intercoms are located and where they call into. They don't call into a specific master station. They call into the system. They're connected to the system. It's all networked together, and you can call any intercom from any master through the digital network, through the digital switch. So that was our first real digital intercom system, was our DXI system. That was introduced in '96. I started in '97, so I was just at the very start of the DXI system. And we still have a lot of facilities using it now. We don't sell it for new systems anymore, but we still do sell spare parts for it. The DXL system came up next. So DXL was about 1993-ish that we started development. We didn't reinstall the system until about 95 and 96. And so the DXL system was an improvement, not really an improvement, but initially was a different scale of system. So the DXI system was a system designed for large facilities with centralized equipment rooms. So you had a minimum component for a DXI system was what we call a card cage, which can have up to 256 intercoms on it. A lot of facilities, there are smaller facilities or more distributed facilities that have a whole bunch of smaller living pods, possibly in different buildings, that may have only 30 or 40 or 50 intercoms. So having a building block component that has 200 intercoms on it is overkill for it. And also, it's less centralized, so you don't have to have all your equipment in one or two or three or five main equipment rooms. You can have them in a local equipment room. So the DXL was a more distributed version of the DXI system. But because it was introduced a little later, it has a little bit more modern components. And ultimately, the DXL equipment now has basically has the most modern components on it. So that's pretty much the only system we sell now because it has all the modernized components. It may be different in scale than the DXI, but it can do everything that DXI can do. We still are doing product development, so expect in a few years, it's not necessarily right away, but we will have a revised DXI system, again, more centralized and large scale alongside our DXL system. But currently, we only sell DXL, and our DXI has been deprecated with all new installs being DXL. The DXI and DXL systems, this slide is a little bit out of date. So we're looking at about 2,500 systems that we have our equipment installed, mostly in North America. We have a few in other locations, but where our primary support is in North America because that's where we are. We're not able to send someone to Australia or Egypt or so we do have a few facilities in Europe and in the Middle East and in Latin America, but that's not our primary focus. But if you have a project that needs to go in those areas, as long as you have someone that's able to handle support during North American support hours or through email, we can still handle that. It just we're mostly our support is geared towards North America. Our system is designed specifically for the corrections market. Jails, prisons, courthouses, public safety buildings. So our system is designed to handle anything that needs audio. So you have intercoms, you have paging, you have monitoring of speakers, including what we call audio level alarm, or some people call threshold alarms or scream alarms. Public address or paging. We can do music distribution. So I'll go and get this one right now. So I have here a 2-button intercom. Here's with our engraving on it. And so you can have intercoms that have, our intercoms only need one wire pair to them, but they can do multiple functions with them. So this intercom has a speaker. This has a call-on button, which is typical of most intercoms. It has what we call a program button or a music button. So the system can have music distribution with a bunch of music sources at the head end. Looks down so you can see me. So you have a bunch of music sources at the head end, and the music button or program button can be used. This could be in an inmate cell, and the inmate can listen to music in their cell by pressing this program button, which will cycle through the list of available music sources that they're allowed to listen to. So you can have part of the configuration is whether they're allowed to listen to music and what music sources they're allowed to listen to. So for example, some facilities may just have a weather and a news channel that they're allowed to listen to. But some of the better inmates may be allowed to listen to music channels. And the staff at their staff stations may be allowed to listen to all of the music sources. So you can assign permissions and they can cycle through what they're allowed to listen to with this program button. No additional wiring is needed. No additional music sources need to be bring into this. That this doesn't do the actual switching. It's the head end equipment. The DXL system over here is what does the actual switching and puts the music source onto the individual speaker. Each speaker in our system is an individually addressable device. So this could be listening to music, while the second one, another one in another adjacent cell, could be either talking to an officer, or they could be listening to their own music source, independent of the cell next to them. So every intercom in our system is an independent addressable device that can have audio independent of everything else in the system. So we can handle all of the audio portions that you would have typically expect in a correctional facility. Because our system is designed for correctional facilities, it's robust, vandal resistant, it's highly reliable, and easily maintainable if there is something that goes wrong. Those do carry through to other industries as well. So some cases our equipment is used in other types of applications. Again, we're primarily designed for security. The feature set's designed for that, but the reliability, robustness of it does apply to other industries. Typically, we see this maybe in parking garages or parkades as their emergency intercoms for contacting the surveillance office. They may have these in, say, stairwells as a scream alarm, so if someone's getting assaulted in a stairwell outside the range of a camera, this can detect a loud screaming and notify the security to come and investigate that. Industrial plants that need a emergency intercom system have been used for this. So there are other applications, but we're primarily geared to security facilities, to correctional facilities. So part of our design constraints is that this is going to be in a jail. So it's going to be operating 24 hours a day. You're going to have, it's going to take abuse. And you want to make sure it's reliable, because if your intercoms are down, your door circulation intercoms are down, no one's able to go through a facility without having an escort that's going to have to manually open all the doors. So you don't want that happening, so we want our system to be reliable. Modern systems, you want to have older jails. You have the old security office with a big ring of keys walking around and escorting people around. Well, that's not what happens nowadays. You have someone sitting in a control room and they're monitoring cameras, they're monitoring door intercom buttons, and they're able to control the facility from within that control room. So you have someone walking around through a hallway, always secured at both ends. You get to the end of the hallway with the door, you press the intercom call button, the staff will see that on their screen, they can look at their cameras, they can answer the intercom, talk to the person going through, open the door and let them through into the next part of the building. So that doesn't need to have someone walking around, escorting people around with a ring of keys. So that's the main purpose, is to have all the control in a central location, and then that saves on staff. So that central station will handle things like door control, the intercoms, cameras, the PA systems may handle things like duress systems or inmate power or inmate water. We're designed to handle all of the audio components of a correctional facility. So most common things you see are circulation intercoms, call buttons and speakers at the doors to initiate the door access. You have intercoms in the inmate cells for them to request attention. You can monitor any speaker in our facility, can be monitored with what we call audio level alarms, or ALA, I'm going to refer to in the future. Other people call them scream alarms or threshold alarms. So again, our system has every speaker is individually addressable, and all of our processing of our audio, all of our switching of our audio is done at the head-end equipment, in this case the DCCs and DCEs. So you don't need anything special in the actual speaker itself to do the threshold monitoring. The threshold monitoring is done at the head end. So if you need to convert something.
Hello.
Hey,
Yes.
Mayor, do you want to talk to Tristan, who was asking to talk to you?
I'm in a training right now for the next few hours, so it'll probably be it probably.
All right. So the audio level alarms can use any speaker as a monitoring device. You can manually monitor them too, but they can be automatically monitored and generate an alarm if a sound trigger is detected on that. I'll skip one point here. Let's go to paging speakers. So any speaker in our system can be part of a page zone. So most cases, you're going to have, this is a little bit strange example, but in most cases, you're going to have a paging speaker or a horn or some kind of paging device, not necessarily an intercom device, but it could be an intercom connected to our system for the page announcements in the hallways, in the rec yards. So those can be interfaced to our system, as well as you may have some locations that don't have a specific paging speaker, such as, for example, intercom cells. An intercom cell might not have, you might not have a paging speaker in your cell, but you have an intercom speaker in your cell. So when you're doing a unit page, rather than just paging to the overhead speakers in the unit, you could, in your programming, include the cell intercoms or any intercom that isn't in an area where you have a speaker. So if you've got a hallway that has no speakers on it, no paging speakers on it, but it does have the circulation intercoms, your page announcements can include those circulation intercoms in areas that you don't have a dedicated paging speaker. So all of our audio devices are all in our system, and they're all treated the same way. Is that if you want to have them in a paging zone, you can put an intercom in a paging zone. You can actually put a master speaker in a paging zone. So this is an example of a master station. This is a TMM. This is a TMM 440 master station. So you can include this speaker here as part of a page zone if you don't have a speaker inside your master controller. So anything that has a speaker can be included as part of a page zone. Administrative intercoms. Oops. That's a fancy name for a telephone. So our master stations, such as this IMS 641 master station here, it looks like a telephone. It's actually a master station on our system. So you can use this to answer intercom calls, but as well, you can use the keypad on this to dial up other master stations. So, for example, in a warden's office, you might not need a touchscreen and a control panel but you can have a telephone in the warden's office, and they can use this to dial up to the intercom in the staff break room or the master station and central control. So they can use a telephone-like device to call up other telephone-like devices, or even intercoms on the wall, or paging. So you might have a master station or administrative telephone in booking, and they can talk to the booking cell, and they can talk to central control. Or instead of having a dedicated intercom telephone, if the facility has their own telephone system, you can integrate the intercom system with the facility system. So now they can do anything that you would do on the intercom system, you can do from a facility telephone. You would have to have programming on the telephone system to create a outside line which ties to the intercom system. But once you tie to the intercom system outside line, you can do anything the intercom system can do. Most common thing is to make a page announcement to the intercom paging speakers. So you can do that from a telephone system tied into the intercom system. But you can also do things like call up an intercom. So a telephone connected to the telephone system in booking can make a connection to the intercom system to call up the intercom inside the booking cell or inside a holding cell. Or they can use it to call the master station in central control. So that can be tied as part of either as a separate intercom telephone on the Harding system or through the facility telephone system. And then backing up to the CCTV part. So we do have an option to integrate to specific CCTV systems. Most of them serial based. There's only a couple Ethernet based, the digital switches. But part of a smaller system, and say for example a small police station, you might not have a full control system with touchscreens and other integration in PLCs. But you have like a small police station that has a master station or two, some holding cells, and cameras. And rather than taking your complete control system and having your own control computer and your own CCTV system and your DXL system, we can handle a limited amount of camera switching internally within our system. So whenever you associate a camera with for every camera you've got, you associate it with an intercom that is pointing at. And then you associate a monitor with the master station control room. And then whenever that station calls in, it's going to put up that camera on that control room monitor. Or you can have it either do that when it calls in, or you can have it do that only when you make an intercom connection to it. You can define when to switch to the monitor, but the intercom system can send the commands to the camera system to do the control. So you don't need to have your own control system for limited systems like that.
Question.
Go ahead.
Are you guys thinking about adding a camera into those intercoms since the cameras are getting so small?
Yes. We don't have we have been looking into it. Yes. It's not coming immediately, but it is on our plans. And kind of what it's not really a difficulty, but we communicate through our internal communication is digital telephone communication. So we use SIP, session initiation protocol, and video cameras more use a different protocol called ONVIF. And so it's kind of either we'd have to do a video SIP call, or we'd have to start doing multiple protocols for our video intercom. So we're looking into that, but we don't have an immediate solution for that.
That's good. I think it'd be good for smaller jails anyway.
All right, thank you for that question. There are other things that are part of the facility that we don't normally integrate with, although we do have some limited I/O that can do, again, for smaller facilities, that, like, for example, police stations and courthouses are two examples. That we don't normally control locks, but we do have inputs and outputs that can control locks. So, for example, in a jail reception area or like a police station reception area, they might have a locked door that has a door lock, a solenoid on it, and you might have a receptionist master station, such as one of these IMS 640, 641 master stations, and they want to be able to, they get the intercom at the door, we'll call into this master station, and they want to be able to open the door and not have a touchscreen computer or PLC there. So we do have the ability, we can have a output on our system that can go and drive the solenoid, and they can have one of these dial buttons on the side program to open that door, or to open whatever door that associated with the intercom that's calling you. So you can have limited door control with the master station buttons. You can have limited alarm sources. So you might have, for example, a vehicle loop detector that can detect whether there's the weight of a vehicle in the vehicle sally port beside the intercom. So the loop detector might generate an output, and that can go to an input on our system that will generate the same thing a call request will generate. So it can have an input that will generate a call request. You might have these 2-button intercoms that you have one button that's a call in and one button that you want your control system to do something with. For example, lighting on your equipment, or lighting in the cell, or probably more commonly is in areas where they're allowed to roam the day room during the daytime, rather than having the inmate specifically request, hey, can you open my door so I can go into the day room and have lunch? You can have a second button that will go into the control system, so it doesn't act as an intercom system. Just the intercom system tells your control system, hey, that button was pressed. You can determine what to do with it. So you can do, if it's the time of day that they're allowed to go and roam the day room, you can use that as a door open button during that part of the day. So that's part of your program. You can have physical buttons either on our system or as an input to our system to do intercom related things. You might have a biometric scanner at a staff entryway. So the biometric scanner may have, if it identifies a verified staff member, you can have that connected to our intercom system to either generate an intercom call request or go to your system to process. So extra inputs, extra outputs can be possible, but they're not normally part of an intercom system, but we can take these inputs and outputs and either do intercom related things to them, or we can send it to your control system to handle. Part of the feature set that makes the DXL system designed for jails is that we're designed to handle flexible call forwarding or takeover. So unlike a relay-based system, where a relay-based system would typically have all your intercoms will call into the local master. So pod intercoms would call into the pod master. And the only place that you are able to talk to or listen to them is from the speaker at that pod master. If you needed to take over that unit, so that unit was unstaffed and things go to central control, the only way to do that with a relay-based system is to take the output that would normally go to that master. So you disable that master, you can't use it anymore because you're taking the output that would have went to the master speaker, and that's an input to the central control relay switch bank. So now, in order for central control to talk to an intercom, they have to disable, they have to take over that master. And you have to have specific relay connections. You have to have, that has to be connected to central control. If you want to have another central control master take that as well, you have to have another set of wires, another set of relays to connect that central control master to the station. Our intercom system, because our switching is done digitally and our data or our audio is transmitted through the network, there's no specific location where a intercom where that needs to call this intercom station. An intercom station can be called from any audio device in the facility with the correct permissions and the correct setup. So this intercom, even if a unit hasn't been taken over, if a central control master wants to talk to an intercom in a unit, it can talk to the intercom in the unit. It can connect directly. The local master can still do its own local things as long as it doesn't call the same station that's currently in the call. So that's the only thing. You obviously can't have two devices call the same end device at the same time. But this flexible takeover, because of the digital switch, allows you to forward things flexibly throughout the system. So a very common occurrence is having living units that would call into their own local master station. And during the daytime, that's what happens. Maybe during less busy times, you might have maybe two adjacent units. You might have only one unit staffed. So that unit gets its own calls, and it will also get the calls from the adjacent unit. And at nighttime, you might not have no unit staffed. So instead, you might have central control. So the forwarding in that case will have the intercoms go directly to central control instead of the local unit master, which has no staff located on it. So that's a common takeover method that is easily doable with our system because it is digitally switched. Another possibility might be you might have multiple master stations, multiple control positions in a central control room. So say, for example, you have a building with 4 floors on it. You might have 4 master stations located in the central control unit. During the busy times of the day, you might have a control master might be designated to a specific function. So maybe a specific floor. So master 1 will be floor 1, master 2 will get floor 2 calls, master 3 will get floor 3 calls, or maybe on a wing basis, or whatever you decide to do. Maybe west wing, north wing on west wing on one master, north wing on another master, east wing on another master, south wing on another master. So you can flexibly divide the building up, and also you can have so during busy times, you might have dedicated masters. And then quieter times, you might have, during the lunchtime, you might have one control master handling north and west, another one south and east. And during nighttime, you might have only one staff member available handling all the facility. That type of control of granularity is possible with our system because of the digital switch. But the other option you might have is you might have a group of 4 master stations, and you might have all of them handling the entire facility. So as a call comes in, the first available staff member will pick it up. It'll clear it off of the other ones. So you can have it that way as well. So you can have it, or any combination of them. So they can all be centrally grouped. They could be individually tasked to a particular workstation. Whatever your programmers, whatever the facility administrators want to set up, we can do that. Any questions? All right, we'll continue on. Audio level alarms, I mentioned already. So you can have intercoms that are constantly monitored by the intercom system. It's not a very sophisticated algorithm. It's basically based on how loud a scream is and how long, so how loud a noise is and how long that noise is. So you can do differentiation based on those 2 parameters, the loudness of the noise and the length of the noise, to determine whether you're going to trigger an alarm or not. So, for example, most facilities, they want to have, when they have audio level alarms, they want to have basically as a scream detection. So scream detection is a really loud noise for a short period of time, because you can't scream your guts out for 10 seconds at a time. It would be a short, loud scream. So you can set the threshold so it's got to be this loud to trigger it, and it's going to be this long to trigger it. And those two differentiation factors allows you to mostly exclude noises that you don't want to trigger the alarms on. For a jail cell, for example, there's two types of noises that you don't want to trigger the alarm on that this can differentiate between. So for example, if you have a door slam is a metal door in sometimes it's a metal cell, sometimes it's concrete, but a door slam is a very loud sound, but it doesn't last very long. So you can have the audio level alarm set so that it has to last longer than the door slam in order to trigger the alarm. The second type of thing you have in a cell that would typically trip an alarm would be a toilet flushing. Toilet flushing is a moderately loud sound. It's a long time, but you can set the threshold so that the sound of the flush isn't loud enough to trigger it, but the sound of a scream is. So that's the kind of things that an audio level alarm can do. So you can have, most commonly for alerts in a cell, if they think you got multiple occupants of a cell, someone's getting assaulted, they'll scream for help, the system will trigger an alarm, the staff member can listen into it and send someone down there.
Is that a pod adjustment on the card itself?
No,
adjusts?
so that is all of our adjustments is through software. So it's a configuration setting in the DXL administrator software. And while you can adjust them individually, we do have a entity called a template, which basically means is you can have, instead of configuring everything individually, which you can do, but instead of configuring everything individually, you go, well, okay, all the cells are, they're basically all mirrored. They're all concrete. They all have the same bed slabs. It's all, the rooms are all the same sizes. Rather than having, like, if you make adjustments for one of those cells, you can probably be pretty confident that it'll work in every other cell with the same layout. So you can have one set of alarm settings, to tweak it for one cell, and then you can basically use the template to have all the cells of that same type use the same settings. So it is a setting in software for the adjustments. So it is a little bit, now there is a tool we have that can actually show you a graph of the sound level as in real time, so you can actually see what settings you want to use. I might get into that on the second day if we have time, but there is so unlike so it's not real time. So what I think I know what you're getting at is, it's not a potentiometer that you adjust on the intercom that you go, okay, you scream, you adjust a little bit, you scream and adjust a little bit. It's not quite as easy as that. It's a software setting, but it is easy in such that once you can have the template. So once you find the settings for one, you can apply it to everything without having to go to each individual cell and adjust a pot to put it to, oh, I need this at 9.5.
That's great.
Settings and you apply it to everything. Does that answer your questions?
Yes, that's a good setup you have.
All right. So audio level alarms. So some cases, most cases, it's going to be used in cells. Some cases you may have a rec yard or a hallway that should have nobody in it. So they want to just detect if there's any noise in the room at all. So someone has escaped and there's noise in a hallway that shouldn't have a noise that can generate an alarm on that. So that's an auxiliary reason for having scream alarms. Most cases it's for the cells. Now, where scream alarms don't work very well is outdoors. So you get screeching tires and you got police sirens happening. That could trigger, for example, if you have a vehicle sally port. An audio level alarm can detect, if you don't have a vehicle loop detector, an audio level alarm can detect, say, a vehicle idling at the port that you can then basically trigger a call in if they forget to put a call in. But that can also be triggered on things like if there's someone speeding nearby and you hear a motorcycle going by, that can also trigger the alarm. So it's not, outdoors is not as good because the sound isn't controlled. Integration. So I already mentioned very common integration is to take a facility phone system and use it to make page announcements into the intercom system paging, or a phone on a booking desk can call into the booking cell to tell the inmate to stand back. This guy come forward. We're gonna book you in now. So you can have the phone system integrated with the intercom system to do any of the audio. A phone in a warden's office can make a page announcement, or if you call up to the break room or whatever. And video visitation is another thing that our system does well, because we can individually connect any input to any other output. A lot of modern facilities have a video visitation system where they have a bank of cameras and mostly telephones, a bank of cameras and telephones in a less secure area of the facility near the entry where the visitors would come in. And rather than having them come in, visitors and the inmates come into the same room with maybe a window between them, the visitors would come into a completely different room, so there's no possibility to exchange contraband. So the visitors come into a room in a less secure part of the facility, the inmates come into a bank of video screens in a more secure part of the facility. It may be a single booth within the unit itself, or maybe a visitation section somewhere in the facility that still in a secure area, that doesn't have visitor access, but they can be basically brought in, and the intercom system can connect the telephone in the inmate area to the specific telephone in the specific bank in the visitor area. And typically this also include a camera system, so it would also tell the camera in the inmate system to, or tell the monitor in the inmate booth to connect to the camera in the visiting booth, and vice versa, connect the monitor in the visiting booth to the camera in the inmate booth. So that can be done remotely, not having a physical contact between them. It can be done anywhere within our scope of the system. So typically this would be within the same facility. You have a bank of visiting booths in the less secure part, entry of the facility, and the inmate booth somewhere else. In large counties that have an IT network between the different buildings, this has been done between buildings as well, as long as you're on the same intranet. That you have to have the ability to have network audio from where the visitors are to where the inmates are.
Does one of the phones have to be a master station?
No, both of the phones will be what we call our FD. Well, most commonly, I don't have one here. I can bring one in during the break. So we have a device called an FDH 440, which is basically a telephone handset with on a 2-gang handset. Actually, I'll go grab one right now. Just give me one moment. This is an example of an FDH, what we call an FDH full duplex handset 420. So this is basically a telephone handset with a secured armored cable. And so these would typically be in the visitation and inmate booths. And so they would have basically a telephone that both sides would pick up the telephone and they talk on the telephone, just like you would on a telephone. And the control of the duration of the session and which handsets are connected are part of the control information passed to the intercom system from your control system. So you have typically do your own control system, and then you have like your touchscreen or whatever would have a selection of which inmate visitation to connect to, and then you would pick which visitor handset to connect to, and it would send the appropriate commands to the intercom system to do the connection between the different telephone handsets. source system, that's when we did our first DXL system and went through the DXL system. Our system is designed with input from facilities, architects, end users, integrators as to what they wanted on an intercom system for jails. And it's designed for jails. So you have our audio is ultimately all of our audio is handled digitally. We have some of our devices. So speakers are by their nature, they're analog devices. You have to have something to convert it to digital. So in our head-end system, all of our audio is digital at one point. That's how we switch it. That's how we transfer it between equipment rooms. Internally, it's digital. At some point in the operation, there's going to be an analog signal. Now, for our IP devices, the signal gets converted from analog to digital right on the circuit board. So right on the intercom station, it converts from the analog at the speaker to an Ethernet connection. As soon as I bring it over here, we've got an Ethernet connection over here. That goes to an Ethernet connection to the rest of the system. But you might have a analog intercom. Actually, I don't even know if I have one here. I'll show you that a little later. So, but we also have standard speaker transformer intercoms that have just a speaker on them. And the wiring for that goes to the head end, to a station card. And the station card converts the analog signal from the wiring to digital and converts it to the rest system. So no matter where it is, ultimately it's converted to digital. And once it's digital, we can use digital signal processing to manipulate, filter, change the volume of whatever, well, the speaker and the microphone. So internally in our system, it's digital and can be manipulated digitally. So it's every intercom has its own separate amplifier. So more applicable to paging. So paging might be you have, if you're paging 50 intercoms or 100 intercoms, doesn't matter. It's the same to us because each intercom has a separate amplifier on it. We're designed to be part of an overall system. So we have what we call host ports, which are the control of our system through an external PLC, touchscreen, sometimes camera systems, or building control systems. So we make it easy for us to control, for you to control the intercom system, because we know that we're part of it. Most facilities, we're a part of a larger system. So we want to make it easy to control the intercom portion of it. Rugged and reliable, because it's going to be in a jail. Our original DXI system had the capability for what we call hot swappable. So because it was large and centralized, if something happened, it would bring a large portion of the system down. So we had in many cases, we had one computer system controlling everything on the system. So if something happened with that computer, your whole system is down. So we have the ability to have redundant computers. We had a card cage that had up to 256 intercoms on it. If something happened with that card cage, those 256 intercoms are down. So we had the ability to have redundant control cards in that card cage. However, that does introduce a lot of overhead and a lot of extra, in most cases, cost. And so when we did our DXL system has smaller building blocks. And I'll get into that in a couple of slides from now. It has smaller building blocks, so we don't have the redundancy on the DXL system. So if something happens, whatever's on that device is no longer accessible, but it's a smaller building block. So a DCC, for example, has 32 intercoms on it. So if something happens with it, those 32 intercoms are down until you put a spare in place. It's easy to put a spare in place, but to satisfy the cost, unfortunately, we made that compromise that DXL does not have hot swappable components. You can have a DCC ready to go, and you just put it into place, give it an IP address, and then it's good to go. So it could be like a 15-minute swap out, but it's not automatically redundant, unlike the VXI system.
But 32 intercoms at a time?
Correct. Each of these building blocks has 32 intercoms. There's 32 intercoms on here, and there's 32 intercoms on here. And if you add more, there'd be an additional 32 each, up to 32. It could be there's 2 card slots that can have 16 each. So it could be 16 or 32, 16 and 32, etc. Our system is designed for reduced wiring. So it is not relay switched, it's a digital communication network. So first of all, of our end devices, I'm just going to get one of our standard intercoms. I'll be right back again. Sorry for the wait, everyone.
We got a question getting ready to come up in the chat here.
Okay. Go ahead. Correct. The DCC is to control for that portion of the facility. So whatever the DCC and whatever DCEs are on that same cooling room, if the DCC goes down, that's the control for the DCEs. And in this case, this is a TVE in that system. So yes, this single point of failure on this would result in up to 32 times 5, so it's about 100 and, great, my math is. So yes, it could result, or a DCC going down would result in up to 32 times 1, 2, 3, 4, 5, 168 intercoms going down. So yes. So that is an important thing is if you do want to have reliability, you want to have a standby DCC ready in case you have to. No, these are generally pretty reliable, so they don't fail often. But yes, that is the case. All right, so going to I'll show you on the little camera here. So this is one of our typical analog intercom stations, and it has a connector on it. I'm not sure if you can see it very well on there. So that connector on it has 2 wires going to it. So the intercom only needs, if you're using one of our intercoms, now I'll be getting to this in a few slides. If you're using one of our intercoms, you only need 1 pair of wires going to it that can have up to 2 buttons on it. If you show me the wrong way, can have up to 2 buttons on it, and as well as an LED on it with 1 pair of wires. A traditional 25-volt intercom would need 2 pairs of wires to it, one for the speaker and one for the single push button. You couldn't normally have two push buttons. So you have one push button that will go to one pair of wires, and speaker transformer will go to another pair of wires. So we would save, using our intercoms, you'd save on having to bring in two pairs of wire and do the actual termination for two pairs. You just need to bring one pair in and terminate one pair. So you save costs on that. Now, if you do have an existing retrofit, we do have station cards that will interface to standard intercoms and have a transformer on them and a push button pair on them. So you can do it that way, but you lose some of the advantages. And I'll get into that in a few slides from now. So that's
can you get two intercoms off one pair of wires? Since it's addressable, like an in and out, something close.
Yes and no. So yes, you can do, if you do it that way, then they will be the same speaker. So if you do it that way, you can have one pair brought into what we call a primary station, and then you have a pair of wires, or actually two pairs of wires going to a secondary station. And it basically, all it basically does is parallels the speaker. So the speaker is the same. When you do it that way, when you talk to the speaker, you're talking to both. When you listen to the speaker, you're listening to both. You can configure it if you have two separate ports with two separate wire pairs, one for the in and one for the out. You can group them in software, so you can talk to them, so you can address them either a single one, the other side, or you can address them as both. So if you do that as individual wiring to each one, you have that flexibility. But if you do a primary secondary pair, they are the same. The speaker is the same. Because we can have two buttons on the same pair, you can have differentiation of buttons. So you can know whether you press the inside button or the outside button. But when you answer the speaker with one of these primary secondaries, you talk to the same speaker on both.
Gotcha. Thanks.
So you can use our intercoms, which save you on wiring. There's some additional benefits. Or you can use a standard intercom, which needs two pairs of wires. Or sometimes they're wired as 3 wires and a shield, which will also work. 2 wires for the audio, 1 wire for the switch, and then the shield will be the switch ground. So that'll work as well.
Because it's a digital intercom, can you do like a 4-conductor and take care of one pair of speakers and another pair of speakers without getting interference?
No, because depends upon what kind of intercom it is. So this intercom I was just showing you here, what we call, this is an example of what we call our 400 series intercom. It's a bit of an older one, but so this wiring coming from the intercom to the head end is still analog. This one gets digitized at the head end. So if there is interference, then it can get interfered between the two intercoms. Now, I'll go over kind of the advantages of our intercom, but if the wiring is shielded, if you have, like, say, for example, 2 pairs of individually shielded wires going in the same overall cable, that will actually work because I'll go over the advantages of the 400 series shortly as to why that would actually work, although that's not really a common occurrence. You may have a lot of intercoms in the same conduit, and that's another benefit of our 400 series intercoms, particularly with music distributions. I'll get into that really shortly.
Okay.
The other reduced wiring is between equipment rooms. So we don't have any relay banks. You don't have to bring equipment into a specific, you don't have to bring intercoms to a specific master amplifier and then have wiring to bring that master amplifier to another master amplifier for wherever it gets routed. You bring intercoms to the nearest equipment room. It doesn't really matter where who's going to answer them. You bring them to the nearest equipment room, that brings it into our digitally switched switch. And then from there, it's a simple network from this equipment room to the equipment room for master control or the equipment room for the adjacent unit. They're all networked together with some sort of network, and the data flows between those networks. You don't need to have any, other than the data network wiring, which in most modern facilities is going to be Ethernet. So if you have Ethernet in each equipment room, you don't need any additional wiring. You don't need to know which intercoms a particular master amplifier needs to talk to. Bring it to the local equipment room, the network will handle it. Wherever it's going to go across the network. Which is also brings to this point for distribution of equipment. Everything's networked. Put the equipment in the nearest equipment room, bring in the devices that is convenient to wire to that room. It doesn't matter where logically they're going to be connected. It doesn't matter which master station that an intercom mostly calls. Instead of wiring to where the master is, wire it close to where the station is, and the network will handle it. So you can locate the equipment wherever you need to. You don't need to bring everything to a central room. You bring it to a local room where all the wiring would naturally go. And as I mentioned, everything's networked. We have the audio and data trunk. So most modern systems, they're one and the same. It's going to be through Ethernet, both for control and for transfer of the audio between systems. And our system is designed to handle all jail-related functions. We use digital signal processing power, or DSPs, to handle the audio, to do a lot of the features of our system. For example, the scream alarms are handled by a digital signal processor, monitoring, processing the volume of audio coming from intercom. It can do some filtering on it. It does that detection of how loud it is, detection of how long it is. That's all handled by a digital signal processor. Generally in the head-end equipment, in this case, this is a DCC or DCE, will have a digital signal processor or DSP in it. Part of the head-end equipment is their digital switch. It can take any input from anywhere in the facility or any particular, on a DCC, it can take any input from any station in this chain, and either it can forward it to a master on the same location, it can forward it across Ethernet to a Ethernet master, or it can forward it across the network between exchanges to the port on another system. So it can take any digital input or any microphone input, any microphone speaker input, anywhere in the facility, and it will find a way to how to get to where you want to listen to it from. So it could be on the same exchange, it could be on a different exchange. It will do all of the necessary calculation to figure out where it is, where it's going to go to, and how to get there. You just need to know the station number of what you're going to call and the master number of what's calling it. And the system will do the rest.
Is it IP addressed? Those things have an IP.
We have multiple different types of devices. So our IP devices are IP addressed, yes. So this is, for example, this is an IP intercom that has an Ethernet on it. So this can be, this is an Ethernet device with an IP address, but our analog intercoms are not. So they're standard, just a pair of wires going to the head end. Now, the head end equipment is IP. So ultimately there will be some Ethernet involved, but the end devices can be, but don't necessarily have to be Ethernet. For example, our master stations, these are Ethernet devices. Same thing with, well, there's different various options, but it's not within camera view, but I have this is an analog master. And this is an Ethernet master. They look the same, they do the same thing, but how you connect to them is different. But internally within our system, they're all treated the same. So this has got Ethernet jacks on it. This one does not. But they're treated the same way. They're from our system, they can do exactly the same things. It's how you connect them is the only difference. So yeah, so you can IP them, but you can get analog wiring ones too. Everything's through digital switch, so you don't have to have stations wired to a specific master amplifier. You just bring them into a equipment room, and through software or through your commands on your touchscreen control system, you can determine what this master is allowed to call. On a telephone style master, part of the configuration that you put on the system is what, if you're going to use the dial pad on this, you can restrict what it's allowed to call to. So you may have a unit master only allowed to call unit stations. So if there's a takeover, say for example, it's a riot, the inmates get access to the control room, they will only have access to the intercoms within that facility. And they wouldn't have, if you restricted to permissions, they're not able to call a warden's office, they're not able to call outside intercoms, they're only allowed to call what is permitted to. We have full control through our host interface, so that allows you to have a PLC or building control system or touchscreen system to handle your call-ins and have the call-ins show up on your screen. Our system has comprehensive fault detection, particularly if you're using R-style intercom. So what we have over here, this one pair of wires, in addition to having the speaker and the buttons, also has a what we call supervision. So if the inmate takes the intercom off the wall and disconnects the wires, you can be informed about that. The system will know that the wire has been disconnected. Or likewise, if there's a fault, there's an intercom that has water, an outside intercom has water in it that's shorting things out, it will report a fault on, it can be reported to a master station, it can be reported to touchscreen, or it may just be on the front panel. But it will report a fault. So all types of faults on our system, whether it's a network fault, a wiring fault, can be reported and be detected. So if you have a monitoring system in your maintenance shop, or if you're an integrator and you're maintaining a system in a facility far away, if you have a remote access to it, you can use the diagnostic tools to find out what's wrong, where it is, and what components you need to fix it. So it'll tell you there's an intercom that stopped working, or it'll tell you a DCC stopped working, or a DCE stopped working. So you'll know what happens with the system without having to have boots on the ground. So as an integrator, it's an excellent tool. Before, if a site calls you and say, hey, my system's down, and they don't tell you really what's wrong with it, well, you can go look at the diagnostics and find out what's wrong with it, and know what it is that's wrong. And if you think you need to bring in equipment, you'll know what equipment you need to bring with you when the maintenance technician comes in. And the same thing goes for the maintenance facility on site. Is you would have a staff member call you up and say, hey, my intercom's not working. You go look at either you can use the diagnostics tools from your maintenance computer, or go to the control room for that, equipment room for that unit, look at the faults list on the DCC, find out what's wrong, even if they don't give you a very good description. And as I mentioned previously, every one of our intercom devices has its own separate amplifier, whether it's our analog intercoms, which have a separate amplifier port at end, or whether it's our IP intercoms that are in themselves the amplifier and switch. So every device, with a few exceptions, mostly with regards to paging, if you're using a centralized paging amplifier, we do have a relay switch for that. But most of our devices are individual devices, individually addressable, individual amplifiers. So the volume of each intercom is specified specifically. It's not a volume for the amplifier, it's a volume for that device. So addressable individually, volume is individually. And you can call one device in a unit from one master, call another device in a unit from another master. There's not a relay bank that's between all the systems. Everyone is individual, so you can have individual calls to individual devices. Everything can be talking to or listening to something different. So that's the non-blocking. Is if you have a living unit talking to an intercom in the living unit. You can still have central control talk to an intercom in that unit, as long as it's not the same intercom. Every device is a separate output, so when you make a page announcement, if you can include, if you wanted to, every intercom in a facility, and it won't overload the system, because every intercom already has its own independent amplifier. It's already independently spec'd in the DCCs, in the DCDs. So you can, if you wanted to, call every device on the system once, and the volume isn't changed because each one has their own dedicated amplifier. If you have, and the DXL administrator allows you to name every device, so you can give it a location or a more descriptive name, so maybe like, a door 10H, or it might be Sallyport North Hallway. So you can give it a descriptive name for every device, and that will show up if you're using a keypad display on a master station to access it. It'll show it up on the troubleshooting logs. So you can name it, so that it makes it helpful for either dialing that device or doing troubleshooting. If you're using our master stations, they do have a programmable menu system. You don't see the menu system on here now, but the display will have a programmable menu system that these 4 buttons will affect. So we typically, for example, the standard menu is one of the buttons will be labeled call. So call, and then the menu is changed to master intercom page zone. You press that, and then the display changes to allowing you to enter the number or select the number with the up and down arrow keys. So it's a menu system on devices with a menu on them. On a touchscreen system, your touchscreen system will be the menu. And as I mentioned, we use a digital switch. So a digital switch, the way that works is basically you take any input to any or more outputs. So for example, a call from a master to an intercom, we can take any master speaker and microphone and connect it to any station, microphone, and speaker. As a page announcement, you can take a master microphone, excuse me, you can take a master microphone to one or more or all speakers on the system. So you take one input to many outputs. Well, what it can't do is as a digital switch, you can't take multiple inputs to one output. So you can't take 2 microphones and put them on one speaker. That's not how a digital thing works. But through a digital signal processor, what we can do is we can take those 2 individual numeric streams. They're digital audio streams. And so you can't connect them together directly. Well, what you can do is you can use a digital signal processor that basically takes each of the 2 audio streams and in real time adds them together numerically with actual addition operations to get a third output, which is now a mix of the digital signals from both of the stations. So you can digitally mix them together to get multiple inputs to one output, but it does require processing power to do so. It needs to have a specific command to do so. So unlike a relay system where if you turn 2 relays on, well, it basically parallels them together and they show up on your amplifier. You can't do that with our system. You have to specifically say, I want to mix channel 1 and channel 3, or intercom 1 and intercom 3. And that has to be done with a digital signal processor, so you need to have a special command to do that, and you need to have enough processing power to do so. So there is a limit as to how many you can add together in one ad. So our limit is 7 plus the output, so 7 stations to 1 master. So you can only add 7 at once, and they have to be all in the same location in order to be able to be available to add them. So they have to be all within the same equivalent room. So you can't have 1 speaker in another equivalent room and 6 in this equivalent room. It doesn't work that way.
So there's a limit as to how many you can add together. It is a separate command. And thirdly, there is a limit of how many of these additions you can do simultaneously. So you can't have 100 mixed intercoms, 100 different separate outputs. Normally, that's not a problem. Normally, you might have one per master, which wouldn't be a problem. But there is a limit as to 7 total and how many you can have within a total room based on how many of these DSP operations you can do at once. But the one input to one output or one input to many outputs handles most of the cases, and that is non-blocking, means you can have any intercom anywhere being connected to any master anywhere. And that also applies to video visitation. You can take any inmate handset and connect it to any visitor handset. Or you can break in and you can have a, if the visit is coming close to an end, you can have the control room break in and say, hey, your visit's going to end in 5 minutes. We can also have that on an automatic timer. So you can set up a visit and say, this visit is for 20 minutes, and the intercom system will automatically do the disconnections after 20 minutes. But that's kind of an example. So the digital signal processor allows you to do a few other things. It does the voice operated switching. It allows you to do this one input to, or many inputs to one output. Conference calls here. We call it internally as a compound station. You can use it to do audio level alarm. You can have it. We have another feature that allows you to adjust the volume level of the speaker based on the volume level of noise in the room. So if the room is very noisy, you can improve the speaker volume in that room to overcome that noise in the room. So we call it automatic noise compensation, or ANC. So that's another thing that's possible with the digital signal processors. So you can do basically anything that any audio components you need. Intercoms, paging, listening to intercoms and monitoring, automated monitoring to audio level alarm. We could have master groups, which are intercoms will call into more than one control station. Being able to transfer, take over, video visitation, music distribution. We can have a lot of facilities that have a juvenile detention facility. So you may have a school. So you can have the speakers in the school generate a school period tone. You might have a wake up tone played, or wake up music played in cells at a certain time of day, and a lights out message played. You might have a automated code blue, so you might have a button on the wall, or maybe something generated by your central touchscreen that can generate an automated alarm over specified. It could be a voice announcement, it could be a music source or a tone played over whichever speakers you want. So we have that tone signaling and pre-recorded announcements allow you to do that on a trigger basis or on a timed basis. We have the ability to have permissions and priority levels. So permissions is on a master station that has a telephone keypad like this, is you can determine which intercoms, which page zones it's allowed to call it to. So you can restrict what it's allowed to call it to with this one. A central control one can have no restrictions, so we can call everything. As a priority levels, you might have, there's different types of priority levels in our system too. So for example, a call priority level, you might have a circulation intercom. You might have certain hallways that are really busy and you want to have them prioritized. So our system has a queuing system if you want, particularly if you use your R masters, but it can also be interpreted, sent to your host interface as well. Is you can have a queued system. So the queuing system normally works if there are things on the same priority. The first call button pressed is at the top of the list. The second call button pressed, and then the second on the list. When you answer the first one, everything pops up. Now the second one is on top. You can determine, you can set in the DXL administrator configuration a priority for the call button on the station. So stations in a primary circulation hallway, you can assign them having a higher priority than a station in a lower priority hallway or maybe even a cell intercom. So it's that if, say, the lower priority station called in first, it's the top of the list. Someone goes to one of these high priority circulation intercoms, they press it. If it's a higher priority, it'll pop to the top of the list, even though it was pressed second, because it has a higher priority, it comes up to the top. So it's a numeric priority system that, higher the priority, it'll override anything lower than that. That also applies to when you're calling. There's a call priority as well. Common, say for example, in paging. So say for example, you have a paging speaker in a reception area, and the reception microphone might have a normal priority. So reception microphone talks to the paging zone, including the reception speaker. So the conversation's happening. You have central control, you have an emergency situation, you have a code announcement. You can set central control having a higher priority than reception. So even if reception is currently talking to that speaker, central control wants to make this priority announcement, they will, if it is a higher priority than the reception master, they will override that reception speaker and have the priority announcement go over that speaker as well. Even though that speaker was currently in use, if what's talking to it is lower priority, you can override it. So that's the kind of priority system that we have, or systems that we have. And as I mentioned previously, you might have multiple button stations that normally you have a call button. You may have another button action for this one, so it may call into a separate second master. It may be a music button, but you can have, without having to wire anything else, because we've only got one pair of wires to our system that handles up to 2 buttons. So you can have the second button go as a command to your control system, and then you can determine what to do with it. So things people have done with it is things like door control for day rooms in daytime, as a guard tour. So guard goes to an intercom, they press the button as they pass by, and then the control room will know where the guard currently is. So we'll send a message to the control room computer, and it basically just says button 2 was pressed. You determine what to do with that button. And we have the ability, it says on DXI, but you can kind of include it on DXL too. So we have, particularly in facilities in British Columbia, was the common case where they have two-way radios that the local police use. So they're bringing in someone to book in. They go on their CB radio and they make an announcement, hey, facility booking, we've got a male coming in for booking, and so we can have the intercom system hooked up to the two-way radio, so it'll be like a line level interface between the radio speaker and the radio microphone input, and a contact for the key to mic. So they can, part of our monitoring system, so when the master is not doing anything else, they could be monitoring something. So they can monitor the radio. So when the master's not doing anything, they'll hear whatever radio traffic on that master. They don't need any specific radio. They need to have one facility radio, but they don't need to have a radio in every control room. They need to have basically the radio hooked into the system and the master station for that area monitoring, having a command or the key sequence to monitor that radio. So now that speaker, whenever it's not doing anything else, it's listening to the radio, and they can make a call connection. So they, for example, on a DXL system, you include the radio output as a unique page zone. You page that page zone, and you're basically making an announcement. You're going to key the switch. You're going to make the announcement to the radio, so you can talk to and listen to people with portable radios, or in this case, it's the RCMP. They have a radio system for the internal staff on their handheld radios, and they have another radio system for the police staff that anyone at a master station can listen to the radio traffic and talk to the radio traffic without having a specific radio in that facility, in each of the buildings in that facility, each of the control rooms. So that's kind of the things that you can do. There are, you know, if you've got an idea or the facility's got an idea, what if, can I do this? If the question involves audio, then it's possible. You might be able to, you know, talk to me. I'm the application specialist. If you've got a unique application that, you know, involves something dealing with talking to an intercom device from something else or hooking up to some kind of audio device from the intercom system, you can probably do it. Yeah, if you want to do something outside the intercom system, so if you want to have you know, like a proximity alarm trigger lights, well, that's neither device is hooked into our system. It doesn't work that way. But if something, if one of the parts of what you're trying to do is an intercom part, then it's possible, possibly. All right, what time is it? All right, it is 10 o'clock, so you've been here 2 hours. So what I'm going to do is I'm going to take a 15-minute break and allow you to grab a smoke, grab whatever you need, and I'll just switch to that screen here. Let's see what I want to do. I want to do this.
You got a question in the chat?
Station program, and it is disconnected. It will fault. Can I eliminate this by changing the station unsupervised? No. So defaults are there for a reason. If you have a station and it's not connected, it should show you a fault. Now, it will only do that for stations that you have programmed into the system. So if you have some unused ports on the system, don't configure them. Because if you configure them and don't connect anything to them, they'll show up as a fault, rightfully so. It's something you told the system that there should be there, and it isn't there. If you have spare intercom ports that you aren't using, don't configure them. Then it won't report as a fault. Changing one of our intercoms, so our intercoms, so our intercoms have basically the fault protection on them, and the supervision and the fault, the supervision, the fault detection, and the two buttons are handled with the same logic, with the same devices. If you set the intercom to unsupervised, you also disable the buttons. The buttons won't work. So setting it to unsupervised is not the solution you want. You just want to if you're not using an intercom, don't configure it. Now, you may want to go, well, in the future, you know, in case the facility wants to add more stations, well, if I configure them now, then I won't have to change the programming later. But you're still going to have to change the programming later. You're going to have to give it a number, a name, and you're going to have to tell it what master it calls into. So you're going to do that sooner or later. So do that when you know about the station rather than pre-configuring it as a spare and then doing something with that number later, even though if you don't have a name for it. So whoever's troubleshooting won't know what it means. You might have given it a number, but it might not be a logical number. You have the next number in a sequence as the spare, but having it unconfigured and then setting it up when you need it is a better solution.
I'll get into the exchanges later, but an exchange is the main control unit and all of the local devices hooked up to it. So in that case, all the expanders. So an exchange is a digital communications controller and the devices that are part of it. Normally, all the devices in the same equipment room. There could be a lot of devices in the equipment room, which may need multiple exchanges in order. If you have a lot of intercoms, then you may need more than just what one DCC and its associated components can handle. So exchange is whatever is controlled by a DCC. Okay, John, just an answer to your question about faults on unterminated devices.
Now, like I said, the recommended solution is just don't configure them. But our supervision is done, get into this tomorrow, but our supervision is done by basically the voltage on the lines determines whether the buttons are pressed and whether the intercom is connected or faulted. So you could, if you do have some spare ports, but you do want to configure them, but you don't want them to show up as a fault. You can, through you need a resistor or a diode across the lines of a certain particular value, and I can get into kind of later, but you can basically put a termination on the station. So it might be like on the quick connect board or the terminal block across the pair of wires that will basically put the right voltage across so it will not show up as a fault. So that is a possibility, but it doesn't need you need to wire something across the port in order to not put up the fault. Not configuring it is a better solution, but if you need to, there is a possibility.
Can't you just put like a spare speaker across it?
Yeah, you can do that. Yeah.
That way you got something there to switch to.
But you basically need to simulate the same signal that a station that's connected and not having any buttons pressed generates in order for it not to generate fault. All right. Should be enough time. So now we're going to go over just the basics of the system and all of the components on the system. So I'll kind of start with historical. This is kind of the way our DXI system worked and our initial DXL systems work. Now, you can still have systems like this, you can still buy systems like this, but we have two main ways to transmit audio between different parts of the building. And one way is using basically digital telephone signal, the same thing that, well, not nowadays, pretty much everything now uses some sort of Ethernet-based communication. But initially, digital telephone systems used digital telephone trunk lines. In North America, we'll call them a T1 trunk line. In Europe, they call them an E1 trunk line. So I'm going to start with history, and then I'm going to go to what most people use. So actually, no, this is the new stuff. Okay. I'm starting with the new stuff and I'm going to historical afterwards. Yeah. All right. So I'm starting with new stuff. Good. Might change this a little while back, but it's been a while. All right. So with our modern VXL system, like I said, at one point, the audio in your system is going to be analog. The speaker is an analog device. Somewhere down the line, it's going to be converted to digital, and it's going to get to our system, and it's going to be switched within our system as a digital signal. So, but somewhere it's going to get converted from digital to analog, or analog to digital. So this is an example of a IP-based master station on top, connecting to a analog intercom station on the bottom. So the analog intercom station is going to be connected to a specific port on a station card on our system. So there would be an individual wire pair going to the head-end equipment to a specific port on it. And it's connected to a specific DCC or DCE on the system on a specific station port. Our master station in this case is going to be a IP-based analog based master station, so it's connecting through Ethernet. And so the communication path on a modern system is your Ethernet device is going to connect through your network switch. It's going to have a network port, cable goes to your network switch, and ultimately the network switch will have a port that goes to the DCC. So that's the dark green line on the top and the light green line on the top. This Ethernet connection It's already digital, it's converted to digital at the master station. It gets sent to the DCC, which is acting as the digital switch. The DCC then takes the incoming digital audio and it determines, okay, where is the intercom station that I want to connect to? If the intercom station that you want to connect to is within the same DCC, then it's easy. It just needs to go to take the digital audio to the appropriate station card port, and the station card port converts it to analog audio, goes to the wiring, goes to the station. So on a different DCC, different exchange, or somewhere it's controlled by a different DCC, it has to get the audio there somehow. So that's this bottom green and light green and dark green connections, the station talk path and master talk path. So that goes again through Ethernet, going to wherever the equipment room where the station is located. Goes to the DCC on that equipment room. The DCC now has direct access to the stations within that equipment room, and it will take that incoming audio from the master in the control room to the station or the station port in the equipment room. It goes to that station port. That's this blue audio path right here. The station port converts that digital signal to analog. It amplifies it and it puts it across the pair of wires going to the station. So in this case, the analog to the audio to the station is analog, but once it hits the DCC or DCE station port, it gets converted to digital, gets switched. So when the master is listening to the intercom, the reverse happens. The intercom microphone comes in, gets digitized at the DCC. The DCC switches it, puts it on Ethernet, goes to where the master is located, and then that gets routed to the master station, and the master station converts it analog, and you hear it. So that's kind of the overall operation, is that the Ethernet devices communicate through Ethernet to its local DCC. The analog devices connect to a station port in its local unit, and then the network will take wherever the audio from wherever the master is to wherever the station is through, in this case, Ethernet.
So they're DC on both ends of that, or they digital switches?
Yeah, Darren, quick question on that map that you have there, where it says analog at the bottom. Is that also like kind of universal for the 400 and 300 series intercom?
Correct. 400
okay.
Series will be universal. With a 400, that's one pair of wires. With a 300, well, for the audio, it's still only one pair of wires. But the 300 will have two pairs of wires, one for the switch, one for the speaker and microphone. But from the point of view of the intercom system, it's an analog signal. It goes to the station port. The station port converts to the appropriate signal levels for that particular type of speaker, and it sends it to that speaker. Just kind of going over what I just said. It's a modern system. You can still use a combination of. You can have a system that has all Ethernet devices. You might have all Ethernet masters and all Ethernet stations, but you can have a system that has some. For example, a common thing will be you have an IP master station and all of your stations are analog, or you might even have analog master stations and analog intercom stations, and the only Ethernet is just the communication between exchanges. So you can have any combination of analog devices, IP devices within our system. It's not analog only or IP only. You can have any mix you want within the system. So IP masters and stations will obviously, they'll use Ethernet, and the protocol they use is the generic term is voice over IP or VoIP. And specifically, we use a protocol called, it's the standard digital telephone communication protocol called SIP, Session Initiation Protocol, with the data stream being RTP, real-time protocol. So it's standard protocols. So you can use third-party, in particular for masters, you can use third-party SIP applications on a tablet or a soft phone or on a PC to do communication. The
intercoms, you'll still need to use our intercoms just because of the buttons, how we transmit. IP speakers don't normally have a call button, so you can't really hook up a third-party IP speaker to our system and have the call buttons work. So, but you can use a third-party tablet or phone app in order to act as a master station in our system. So you can use a phone app to call up intercoms. You can use a IP connection from your phone system to the intercom system as the tie-in between systems. So it is a standardized SIP protocol. So you can use third-party stuff to an extent.
Hey, Darren, can I interject here?
Go ahead.
You may have already covered this. So the system that is currently installed at this site is a Duquesne, and it's all analog. And so the master stations that we're connecting is going to a relay station, and that's what is connecting the master microphone to that to the station. Is there going to be any kind of impedance matching that we have to do going to the DXL for those stations to work?
That's a complicated question, and that's a complicated operation. Now, normally, when we have a system replacement like that, the system replacement is replacing the Duquesne head-end equipment with the Harding head-end equipment with our standard speaker amplifiers, and then you would use our head-end equipment. You can still use the existing speakers, but now our head-end equipment talks to those speakers. So from the point of view, it's a device on our system. If you have a system that has some new speakers hooked up to the intercom system, but you have portions of your facility that are controlled by the Duquesne system and Duquesne relay switches, that's complicated. You can do it.
Oh, so the Duquesne's
But
coming
it's a lot of
completely
work.
out. We're not going to keep the relay station. The DXL is going to be the only system there, but it's going to have the old stations at the doors.
If you have the old stations, so typical stations, and I think Duquesne is one of them, use what's called a 25-volt intercom. So it's an intercom that has a speaker and a transformer and a button. If you are using those, then yes, you get our station cards, and it's going to be about a couple slides from now. You get our station cards with what we call a 300 series station port, and that will connect directly to the Duquesne analog intercoms. So you have two pairs of wires, one that goes to the speaker transformer, and the other one that goes to the switch. So yes, that is directly compatible. You just basically order the correct equipment with the 300 series station cards, and you take out the old Duquesne headed equipment, but you still keep the wiring, you still keep the speakers, and you hook the speakers up to our equipment.
Okay. Thank you.
Now, can you mix your cards like an analog card and a digital card, like an analog card to take care of his retrofit? But if he adds new speakers, then a Harding.
So a digital intercom doesn't need a card. It's through Ethernet, so you just have to have an Ethernet port available on your Ethernet switch. But between our Harding 2-wire intercoms, we call our 400 series, and the standard 4-wire intercoms, what we call a 300 series, they do need special ports, but they don't all have to be the same type. So you can have even within the same unit. So every DCC or DCE has 2 card slots in it. Now the card slot can only be one type of card, so it'll only be a 400 card for Harding intercoms or a 300 card for Duquesne intercoms, for example. But you still have to have, if you have some Harding intercoms and some Duquesne intercoms, you have to have one Harding card and one Duquesne card. They could be either at Harding, one system has a Harding card in the first slot and a Duquesne and a 300 series card in the second slot, or you might have the DCC having all the 400 intercoms and the DCE having all the 300 intercoms. But you can mix and match them. The same system can have regular Harding intercoms as well as 25-volt 4-wire intercoms. but they do need their own specific card for them. But it can be a mix and match even within the same DCC or DCE.
That's good to know.
And of course, you can also add in a mixed IP intercom. So we do have some facilities that have an existing portion, so they're retrofit using, say, a Duquesne intercom, that they're reusing the existing intercoms and wiring, that's fine. And they have a new part of the facility that has our analog intercoms or 400 series intercoms. And they may have a few maybe outbuildings that they don't have enough space to put a full rack in, but they have an Ethernet connection too. So they may have IP intercoms in a gatehouse or guard towers or some sort of admin building. So you can have any combination of 300 series retrofit intercoms, hardy intercoms, and IP intercoms all in the same facility. It doesn't. You can mix and match, no problem. So when you're using our modern VoIP systems, which is pretty much anything that Albert's going to quote, Albert can get a quote you, is generally the most cost-effective way, and the way most people do it is most people, they're going to use some kind of IP master, either this what we call an IMS master, or for control rooms, control with touchscreens, you normally would have something like this TMM 641, which has an Ethernet port on the back. So you typically have most cases you have an IP master, and the analog stations are still cost effective. They're only a few bucks a piece, 30 or 40 bucks a piece, compared to, just because of the complexity. If you look at the small picture on the bottom, the complexity of our IP intercoms is very complicated. There's like 2 circuit boards full of components, and there's processors on it. So these are expensive, on the order of a few $100s a piece. So yes, there's modern, but it is more expensive, and you do need to have a Cat5 cable. So it does need to be a 4-pair cable going to that equipment room, as opposed to a simple 1-pair cable going to an analog intercom. So a lot of cases, it's still cost effective to have our analog intercoms, either the Harding intercoms, which do have some feature benefits, or the 25 volt Duquesne or Quam, or we also sell those type of intercoms. This is an example of them. So our regular analog intercoms, probably can't see very well on this picture, but there's some components on there. There's a small microprocessor on there. But a standard 25 volt intercom just has a speaker and a transformer. We make those too. This one here, again, you probably can't see it very well. It looks the same as the other one, but this one is actually a 25 volt intercom. It has a switch on it. It has a transformer on it. It has a speaker on it. There's nothing else actually on the circuit board, just a transformer mounted on the circuit board. Right there. So we sell those and manufacture those too if you want. If you want to make it compatible with an existing system, but you want to add some new intercoms, or in case you want to make it future-proof and you think that you might not be using Harding in the future, we can give you a system that has the 25 volt intercoms that you can take to another system later on. So anyways, so you can take any combination of IP masters, IP stations, analog masters, and analog stations within our system. Between the equipment rooms is going to be voice over IP, so it's going to be using Ethernet with the SIP and RTP protocols between equipment rooms over your Ethernet network. Same thing goes if you have an IP station or an IP master, it's going to get that same protocol between the DCC and your IP station or IP master. Any analog stations will actually have analog audio across the wire pair to it. And as I mentioned, the IP devices will connect through your switch to the DCC. So this digital switch is actually the DCC. If the destination is on another DCC, it uses Ethernet, sends the audio to the destination device. where it gets converted to analog and then sent on that pair of wires to the station. If your station is Ethernet, then the connection is made directly through Ethernet to the station. So the master station gets connected to the DCC through Ethernet. And when the DCC determines that the intercom station that you're calling is an IP station, it directly uses the IP address of that station and it directly sends the audio to that station through your Ethernet network. This is where the history comes into play, is for our older systems. You can still order a system like this now, but it's really not common. So for our older systems, instead of using Ethernet for this connection between systems, instead of this green path over here, the green and blue path here, instead of using Ethernet for communication of the audio path, we had an option, we still have it, that you can use a digital audio trunk or basically a T1 telephone, digital telephone network. Now, if you have a system using that style of networking, then you cannot have IP, so that system was before we had Ethernet masters and Ethernet stations. So you can't have Ethernet masters and Ethernet stations with the old style analog or the digital audio trunk. You can convert those, but when you convert those, it makes everything into Ethernet. So you can take an older system and you can make it use Ethernet, but you can't take an older system and put Ethernet masters on that without converting everything to Ethernet. So with those style of audio trunk systems, rather than using Ethernet communications between systems where it's simply an IP address to wherever exchange you're going to, instead the audio goes through still a digital signal, but in this case the digital signal now crosses through every DCC on the system, each digital switch on the system. So if you're talking from a master station connected to, say, exchange DCC number 2 on the system, and you want to connect to an intercom on DCC number 4 on the system, what would happen is it gets digitized wherever it gets digitized. In this case, this is an analog master. It gets digitized at the DCC. It gets sent. It gets converted to digital. It gets sent across this wire pair, and this wire pair operates in a loop between all of the DCCs on the system. So that's unlike the Ethernet network where it connects to an Ethernet switch, and your Ethernet switch connects everything together with their IP addresses. This is connected in a loop. So the loop could be a fiber optic link, or it could be a wired link. We have both options. So, but it has to be looped between all the card cages or all the DCCs or exchanges on the system. So it goes to in a loop, the loop transmitter on the loop goes to the next DCC on the loop. If that's not where the station is, it gets passed straight through, gets transmitted again, goes to the next one in the loop until it gets to where the intercom is. It again gets converted from digital to analog, gets sent across the wiring pair, and the station hears it. When you're listening to it, the microphone goes analog to the head end, gets digitized, system knows master is not located here, so it then transmits across the audio trunk to the next one in line. If that's not where the master is, it goes straight through, goes to the next one in line until it is where the master is. Gets converted, sent to the master port, gets converted to analog, and goes to the master. So if you have an older system using an digital audio trunk, this is how the audio gets transmitted. Now, you'll still have Ethernet in that system for communication between exchanges, the data communications, that's the call setup, but the audio transmits through this audio trunk, which is either a single fiber. Each of these wires represents a single fiber or one pair of wired cable. So you have one fiber or one wired cable between exchange 2 and exchange 3, one fiber or wired pair between exchange 3 and exchange 4, all the way through. You can convert these to Ethernet. So if you got an existing system like this and they want to add IP masters or they want to add additional exchanges, then you can convert them. The VoIP component is an additional card installed in the DCC that converts the audio from our internal format to the voice over IP format used by IP devices. So you can convert them by adding this additional card. But that makes it from this type of system with the separate analog trunk, it makes it to use the Ethernet trunk at the same time. So if you convert an older system, you can abandon all of these existing wired or fiber links and exclusively use the Ethernet link. So it is possible to upgrade. Even our oldest systems can do that. But you do need to have the cards to do that installed. So it's kind of just the very basics. I'm going to get into more later. Now, I've been tossing some acronyms out already. I've been mentioning DCCs and DCEs and IMSs. And what does that all mean? So all of our components are designated by a 3-letter acronym. And we generally take the, what the word is that it represents and kind of compress it to 3 letters. So an intercom station, such as this guy right here, actually this one right here, is called, it has a part number, ICM. Actually, that's not it, that's not. Yeah, so it's given a part number ICM, and you can spell intercom, okay? So that's what that is. A master station like this is called an IMS, Intercom Master Station. So a DCC is Digital Communications Controller, DCC. So that's so all of our parts will have the basic designation of what it is, what it does, kind of a compressed 3-letter acronym of it, and then followed by some kind of numbering scheme. So the first letter of our numbering scheme is the type of intercoms, the series of intercoms what kind of port it hooks up to. So our current Harding 2-wire intercoms are what we call our 400 series. That's going to be in a couple of slides. So our Harding intercoms will have a 4 as the first part number. A Duquesne style intercom port will have a 300 series, so it's using a 25-volt intercom port. So it will have a 3 in that digit. And if it is an IP device, an Ethernet device, it will have a 6 in that digit. So that types of what type of device is it? And then the rest of the digits on that are specific to that type of intercom. So in case of intercoms, that second digit tells me that it is a standard, a 20 in there, a 420 is a standard 2-gang intercom. It fits in a 2-gang back box like this. A 430 will be a 3-gang back box like this. And then the other options are, you will look at the data sheet for that particular device. So an intercom might have 1 or 2 buttons, it may have engraving on it or not engraving on it. So all the additional digits on that explain all the additional options required for it, whether it's a weather resistant station or whether it's an indoor station, whether it has an LED on it or no LED on it. So all the other additional characters on that will be basically the options for that specific intercom, master, whatever device you have. A DXL head-end equipment has a lot of options on it, so it's going to have a big long number on it. And what kind of master card does it have? What kind of station card does it have on the first slot? What kind of station card does it have on the second slot? Does it have additional digital signal processors on it for audio level alarms? Does it have a digital audio trunk? Does it have an IP card installed on it? So all of those are options as part of the DCC ordering information. So you refer to the data sheet for that particular device to find out what all the numbering options mean and what you need to order. Now, normally when you give Ken or Albert a request for quote and you give them a plan for your system, I need this, I have this equipment, equipment rooms in these buildings, and I have this many intercoms and this many masters. They'll normally come up with a list for you, and they'll have the DCCs as part of their list. Will show you what cards that you need for that particular equipment, or what DCC, what is in the DCCs in that equipment room will need. So Albert and Ken will normally help you out with that. But if you want to do your own coding, you can look at our data sheets, and after this afternoon, you'll know exactly what you need to do, how you need to specify things up. So now I'm going into what's a 400 series and what's a 300 series and what's a 600 series. I kind of outlined it for you already, but our 400 series devices mostly encompass our intercoms and analog masters. So 400 series devices are Harding intercoms. They have the circuit board on the bottom of the intercom, and that does a few things, which is going to be what's on the slide. So they have our intercom. The advantages of it is it needs only one pair of wires, and you can have 2 switches, up to 2 switches, and you can have an LED all controlled by that same pair of wires. Part of what the circuit board on the back does is, I guess I'll go to the standard stations. Is the standard stations would normally use just a speaker and a transformer. Now, the speaker would be used as a microphone, but the problem with the speaker used as a microphone is when you use a speaker as a speaker, you're putting a high voltage signal on it in order to make the speaker move. So you put a high voltage signal on it, the speaker moves a lot, and it pushes air and you get sound. So it needs roughly a 25 volt RMS signal in order to make the speaker move enough for you to hear a loud sound. When you're using a speaker as a microphone, well, you're not talking like a jet engine. You're talking at normal sound volume level, and that doesn't move the speaker very much. And as such, it doesn't make a very loud, very large voltage on there, and on the order of millivolts as opposed to 25 volts. So the speaker used as a microphone is a very, very small signal. And if that is going across a pair of wires, then that means that the signal going across that pair of wires is a very small signal. When you have other wires nearby, so you have other intercoms in the same conduit, you're running your AC voltage, those other voltages on those other wires is a lot larger than the microphone signal from someone talking at that speaker. So it's a very loud, small signal, and there's a very large signal comparatively in the wires next to it. And what that can do, and what that will do if you have lots of wire pairs in the same conduit, is first of all, you can pick up noise from the nearby wires. So a common example is if you have music distribution, so you have one cell listening to music, and you have another cell not listening to music right next to it, and the wires are running in the same conduit. Well, what would happen is if a master station tries to call and listen to a station that's not listening to music, but his neighbor is, the signal coming in from the wires, the music is way louder than the microphone signal coming back. So what's going to happen is a little bit of that music is going to bleed through, and whoever the master station, when they're listening to that station that doesn't have music on it, but his neighbor does, they're going to have music in the background, not coming from the speaker, but coming from the wires. So that's one disadvantage. So what our Harding intercoms, the next thing that happens is it's a very, very small signal. So even if it's running a conduit all by itself, at the other end, to make it loud enough, you have to amplify it a lot,
in order to get a loud enough signal to hear on your speaker. So in amplifying that very small signal to a very large signal, you're going to also amplify any amount of noise, electrical and analog otherwise. So you're going to amplify the noise. So it's going to be a loud signal now, but you're going to have a little bit of hissing in the background. Not a lot, but just because of all of the noise picked up from the long run of wire between the master station, between the intercom station and the head end. So that's a disadvantage of using a traditional speaker as a microphone. It's going to pick up more noise from the wiring, including adjacent wiring. And that's one advantage of our 400 series. Is one feature of the circuit board on the bottom is it takes the very small microphone signal from the speaker and it amplifies it to about the same level as if you were using a speaker. So now it's a loud signal. So it's a large signal that's going back to the head end equipment. So it's already amplified here, so it doesn't pick up any noise from the wiring. And because the wiring noise is now as loud as nearby stations, it's not going to, it'll still pick up, it may still pick up a little bit of signal from the adjacent wiring, but now it's not getting amplified a lot. It's a very small signal compared to the large signal that the microphone actually is. So the amplified microphone provided by the 400 series station board provides a much cleaner audio with less noise, and it allows you to have nearby wiring that has intercom level audio without having to bleed through. So when using music distribution, it makes a big difference, because now the other adjacent stations could be having music, but the signal that comes in is very small compared to the actual amplified microphone signal coming back from the station you're listening to. So the amplified microphone greatly reduces noise and crosstalk, which is the wiring, the noise introduced by adjacent wiring. Also part of the circuit board is it takes the multiple buttons and the LED and the speaker, and it puts them all on the same wire pair. So it reduces the wiring requirements. You don't need to have a wire pair for the speaker and a wire pair for the button. Now you can have one wire pair that has a speaker, 2 buttons, and an LED on it. So that's what we call supervision. So the other advantage is to provide supervision. It knows, because the same logic used by the buttons is also used to determine whether the station wiring is connected or not. So you can also detect whether the wiring is disconnected, an open fault, or whether it's shorted together, a short fault. So it can detect a problem with the wiring to your intercom as well, all in the same one wire pair. So what's the advantages of our 400 series? Is one pair of wires, supervision, multiple buttons, preamplified microphone. There's a lot of advantages to it. Now, why is it called 400 series? Is our original DXI system, our original hardening stations, same feature set, was called a 100 series intercom. And it had a circuit board on the back too. It had the preamplified, it had the 2 switches, it had the LED. But the difference is that our 100 series had a separate microphone, but a separate microphone and a separate speaker. And the problem with that is the microphone added cost. The microphone also added complexity in manufacturing and in shipping. Is if the microphone was slightly moved around or slightly shifted, it made a big difference in sound. It muffled the sound a lot, even if it just moved just a tiny little bit. So to save costs and to save the precise alignment needed for the microphone, our 400 series is the same techniques, but now using the speaker as a microphone with additional digital signal processing on the DCCs and DCEs. To a separate microphone is a little bit cleaner, but with our digital signal processing, we can use the speaker as a microphone and have it just as clean as having a separate microphone, but reduce a lot of the cost and reduce a lot of the complexity. So that's why we may see none of you will probably see a 100 series system. There are a few still in existence, but that was generally our first DXI systems had the 100 series. So you're not really going to see that, and you're going to see the Harding systems being 400 series. So that's basically what our 400 series is. And the same thing applies to our master stations. Is our 400 series master stations are also analog, and they have the same amplifier circuitry as the same basic circuitry as the intercom stations. They have, instead of one pair of wires, there's two pairs of wires, and one for the speaker and one for the microphone. They generally work the same way. It's the same pre-amplified microphone. It's the same, it has the switches as part of the wire pair. In this case, that's the push to talk switch. It's part of the wire pair on that same wire pair. So it's the same general principles as our 400 series intercom. So that's what we call our analog masters or 400 series masters, because they have the same type of circuitry with a circuit board on them. There's a pre-amplified microphone, and the switches go on the same wire pairs as the audio does. And sometimes we may refer to 401 series station card or a station, and that's simply an intercom with an LED on it. The circuitry is generally the same other than the addition for handling the LED on it. But the principles are generally the same. But we call it a 401 card because it is a card that I can also have, in addition to regular intercoms without the LED, it'll also handle intercoms with an LED. So you do need to order, you have LEDs, you do need to order a card that has the LED, 401 card. So that's our Harding intercoms, our 400 series, and one pair has all the stuff on it, has the advantages of preamplified microphone and the multiple switches and supervision. So now we're going back to the 300 series. So the 300 series is when you're using a traditional 25 volt intercom. You're doing a retrofit from a Duquesne or a Quam, some A-phones, that sort of thing. So, or you can have it with our intercoms as well. So you can get standard 25 volt intercoms from Harding or Quam or Duquesne or whatever. So you can, if you're using intercoms that have a speaker and a transformer on them, then you use a 300 series card to hook up to that speaker and transformer. You do need to have a separate pair of wires going for the speaker and a separate pair of wires going to the switch. So you need either two pairs of wires, or you need at least a 3-conductor with a shield. We recommend separate pairs. That gives you the best audio signal, but a lot of retrofits, if they've got a 3-wire cable with a shield, then you can use that. The advantage of a shield is it provides noise protection from outside, from adjacent wires. So a shield is really helpful. If you've got 2 pairs of wires and they're not shielded, you can use them and it'll work. But if they're replacing the system because the audio sounds bad, because they have adjacent hiss, they're hearing nearby speakers, the shield is what helps a lot for that. So if you're using unshielded wiring hooking up to a 300 series card, you might not get an improvement because that's coming in through the wires. You might get an improvement if you go to a 400 series. If you're using the same pair of wires and you go to 400 series, you'll get an improvement because of the amplified microphone. But like for like, if you're changing out an existing 25 volt system with a 300 series card, if the system sounds okay as it is, you can use the wiring as it is. But if you're replacing it because the audio quality is a problem, then it might not fix it if it's coming in from the wiring. So that's one disadvantage of the 300 series or 25 volt intercom, is that the wiring it's a low level microphone signal, so it can pick up noise. And it has to use a separate button, a separate wire pair for the button. And you can't do supervision on it. You can't, with our intercom systems,
you can detect whether or not the wiring is disconnected or not. With the standard 25 volt intercom, you can't. So you lose some features, but it allows you to retrofit an existing system without changing the existing intercoms.
Darren, I got a quick question since we're
All right.
talking. Is there distance limitations on size of gauge for those 400 or 300 series?
Yes,
with
there
your
is.
system?
That's what we're going to go over this afternoon. So the our recommendations are a 22 gauge wire. So anything thicker than that, like a 16 gauge, no problem. But like a 22 gauges are recommended, and that gets you. Oh, I'll have to go forward here. Just one moment. Not on top of my mind right now. Couple more slides here. $2,500 feet. If you're using 22 gauge wiring, you go up to 2,500 feet with that. If you're using if it's like I say a 24 gauge wire, then you have about half that distance, so you go 1,200 feet. And if you get like a 16 gauge, you go even further than 2,500 if you want. But the typical intercom wiring is like 22 gauge-ish. Where we were here. All right. So that applies, that 2,500 feet applies to both Harding 400 series as well as third-party 300 series. So 2,500 feet for each of those if you're using a 22 gauge cable. And then lastly is what we call our 600 series, which is our Ethernet voice over IP devices. So instead of using analog audio, it's directly Ethernet. So you get an Ethernet port. When you have a system using VoIP, you're not going to be using it. It's gonna use Ethernet for everything. So it's going to use Ethernet for for any VoIP end devices. You can still have analog devices on the system, and it'll use Ethernet for the audio between exchanges. You can have any combination. You have Ethernet masters, Ethernet stations, analog masters, analog stations, with one exception. Some really old systems, and I have one example right here. So one exception to that is simply because of the I/O card needed to handle the voice over IP. So in the middle screen here is what we call our IMS 440 master. So it's a master station that's very industrial looking, and it has a keypad on the display and a speaker in a telephone handset. Now, normally an analog master isn't the problem with our system. So we can have an analog touchscreen master module like this guy right here. Not a problem. We can use that with both our digital, along with 600 series intercoms and masters. But what this does is this has the same two wire pairs needed for speaker pair and microphone pair for the audio, but it also has some kind of control for the keypad and display. And that's through another network called the LonWorks network. And due to the DXL design, there's one option card installed on the DXL system in the BCC. And that card can either be a LonWorks card to control this style of master, or it could be a VoIP card to handle the voice over IP audio conversion. There's no two card slots. So if you have a VoIP card to handle IP devices, you can't put a LonWorks card to handle this specific device because of the keypad display being controlled with LonWorks. So this is the one exception where you can't combine this in a VoIP system. In that case, if you do have a system, an existing DXL system that you want to upgrade, and you have that style master, then you have to replace those masters with the TMM 640 masters, which have the same functionality, but now these are Ethernet connected and they don't need the alarmer. So you can upgrade a system with one of those masters to use voice or IP, but the master will have to be converted to this style. We also have what's called a paging talkback adapter. So if you need to have paging speakers, we have a device that's an amplifier with an Ethernet port. To handle paging speakers with Ethernet, or you can use analog paging speakers. So 600 series is anything that uses an Ethernet port for its communication to the system. Our 600 series devices use standard protocols, SIP, Session Initiation Protocol, for the data, and RTP, or real-time protocol, for the audio stream. So you can use a tablet or a PC or a phone as a master station, for example, or you can interface to a digital telephone system for paging. In most cases, the port on the IP device, you can power it with a power adapter and Ethernet, or if you have power Ethernet, or sometimes called PoE. If you have a power Ethernet network switch, then you only need the Ethernet cable. But most don't have an option, particularly for master stations. You do have an option if PoE network switch is more expensive. So if you want to use a regular network switch and just plug in a local wall mount power adapter, you can use that with master stations. With our IP intercoms, it's a little inconvenient to locate an electrical outlet near every IP intercom station. So by default, our IP intercom stations are all power or Ethernet PoE, because it's not logical to have wire up a wall outlet near every intercom. So those you would typically use a PoE network switch to power, both provide the Ethernet and the power. There is an option on these that you can order an option, an enhanced option, which will provide an additional power input, but it's not really practical, but you can do it. Any IP devices aren't available on our DXI system. So our DXI had our 300 series, 400 series intercoms, just like in Masters, just like I mentioned. They're compatible, so you can take a DXL, an existing DXI system, and upgrade a DXL just by changing the head and keep the end devices. But a DXI system did not have IP masters, IP stations. So you can't add an IP master or IP station to a DXI system. At least not the current generation. Our new ones will be IP enabled, but that's a few years down the road. And lastly, as I mentioned, you can convert an older system to use voice over IP. And as I mentioned, there is an option card installed in the DCC that allows you to have the voice over IP. It translates the internal digital signals to voice over IPs, RTP signals that go across your Ethernet network. On a new system, every DCC will have one of those cards installed and allow it to do that conversion. If you're upgrading an existing system, you can do it by adding that card into every DCC on the system. So it has to be every DCC has to have that card, not just one of them. So if you're adding one master, IP master, you have to upgrade all of the DCCs with that card, because it also uses that network for communication between exchanges between DCCs. That's the series. Harding is 400, 25-volt intercoms are 300, which also includes paging speakers, such as these. We have our talkback expander, which is a 300 series device, TBE 310, which basically communicates to or provides amplifiers and wiring pairs to 300 series or standard 25 volt or 70 volt intercoms or speakers. So you have options for 70 volts as well, but we treat them the same family. So 300 series will be for 25 volt and 70 volt standard intercom and paging speakers. So this is a real mix match, but this basically shows you that you can mix and match all of the device types within our system. So you can take, you might have on the right hand side, you have a system with a controller and a bunch of expanders on it to handle all these 400 series intercoms, maybe handset stations. You might have an existing portion of the facility, or as it might be an existing portion, you might have a new portion of the facility that has only IP intercoms. You might have IP intercoms and IP master stations. You can mix and match all the components in the system. Analog, digital, doesn't matter. They can all be part of the same system. It can be 300 series, some 300 series intercoms, some 400 series intercoms, some 600 series intercoms, analog masters, digital masters. Not a problem. You can combine them all. With the modern system, with the VoIP pipe, voice over IP, everything is to go through Ethernet, both the control data as well as the audio data. For a very large system, normally most of your network traffic, most of your audio is going to go locally. So you're going to have a master in a living unit talking to stations in a living unit. It's not really going to use your facility network. It's going to go all within the same network switch at the very least. So it's not going to need any backbone traffic on your network. So in those cases, you don't really need to worry about your network. And if you have a central control master talking to stations in another unit, that's where we'll use your backbone network. But it's not a lot of traffic. Voice over IP uses about 170 kilobits a second on your network. So if you have a master station in another equivalent room to a intercom in another equivalent room, then at most it'll use that much per communication path open. So local master to the DCC will be local within the switch. It doesn't use your network at all. But anything going between equivalent rooms will use a little bit of network traffic, but it's not an awful lot. 170 kilobits a second when you're talking about a gigabit or a 10 gigabit network backbone is a very small amount of data. However, if you have a lot of activity, maybe you've got some workstations or you got, IP cameras and a lot of workstations that are maybe doing a file update or something. And you do have a lot of inter-equipment room connections. What can help you out is what's called a quality of service, QoS, on your network switches. And what that can do is that can prioritize certain network traffic. So if you have a really big network and you're going to have a lot of data across it at certain times, and you want to make sure the intercom traffic isn't broken up, then you can set up quality of service on your network. Almost no case, it's just very, very few cases do you actually need to do anything with this because it's a very low amount of traffic, and usually you don't spec out your network that you're maxing out your network all the time. So whoever's doing the network is gonna, you're gonna size your network and you have your network backbone, so you're not gonna probably experience these conditions. But if you ever do, setting up quality of service or QoS on your network basically tells you can tell the DXL system that, hey, the audio packets are higher priority than most. So if your network is bogged down, send the intercom packets first before sending anything else. So for example, if you're doing a file transfer, you're updating the Windows on one of your workstations and you're getting a lot of network traffic across that. What will happen is if the intercom system audio packets are given a higher priority, then whenever the network is full, it'll send the intercom packet and then it'll send the Windows Update packet. So your Windows Update maybe take a few seconds later, more than usual, but it doesn't interrupt the intercom audio. So that's what quality of service does. Almost all cases it's optional, but if you want it and you set it up, you'll get that extra added benefit. All of our Ethernet devices are RJ45, so we don't have any
fiber optic connected Ethernet devices. They're all RJ45. If you want fiber, then you got to get your own fiber converters. Our devices are generally 100 megabit. We don't need an awful lot of traffic, so we don't put gigabit ports on our system. So we have 100 megabit. You can put them on a gigabit switch, but we'll only go at the 100 speed. You can also put us at. You can also use a 10 megabit switch. So we don't use the full 100 megabit. So you can put us on a 10 megabit port as well. It's not using that amount of data. So, but at maximum we only go 100 megabit. And another limitation is well, I'll get into the DCC, but we have a limitation of 39 simultaneous VoIP connections in and outside a single DCC, which is also a limitation of 13 masters. But I'll get into that in a couple of slides. So you can basically mix and match anything you want in our systems. So I'll start with, okay. So this is kind of a mix of old and new systems. So an exchange is a DCC and the devices that it directly controls. So in this case, this left part, this is exchange 1 on the left column, exchange 2 on the center column, and exchange 3 on the right column. So exchange 1 is this DCC and whatever devices it controls. Exchange 2 is the second DCC and whatever it controls. And exchange 3 is this third DCC and whatever it controls. So that's what we call exchanges, as a DCC, digital communications controller, and all the devices hooked up to it. Between the exchanges, we're going to have an Ethernet network, this blue line that goes to your Ethernet switch. So now your Ethernet network is we don't provide the Ethernet network itself. We assume you've got your network expertise, so you set up your Ethernet. It may be just a simple Ethernet switch in one equipment room. You may have an Ethernet network with multiple switches with a backbone network between them. But from the point of view of our system, we just need to have an Ethernet connection from each DCC to each other DCC and IP masters and IP station. So that's this blue network. So you have to have an Ethernet network. In the case of a modern system, both the data, so if, for example, a call button was pressed on a station in this left exchange, and the central control master was a master on this central exchange, pressing the call button will send the data packet through the Ethernet network to the central exchange to say, hey, this station pressed this call button. But when you have a voice over IP system, when you actually make the connection, the voice communication will also go through Ethernet as a VoIP data packet. So a modern system would only need this blue Ethernet network connecting everything together, as well as this red network connecting the local devices within an exchange. An older system will need an audio trunk. Like I mentioned, it was like a T1 network or a digital telephone network. So an older system, in addition to having the Ethernet for just the data, so the control connections and the button presses, the audio, instead of going through VoIP on the Ethernet network, would go through this digital audio trunk, which need to connect all of the exchanges together in a loop. So that's what this green link is. And I mentioned if you have an IMS 440 master station, that the keypad display is controlled by a LonWorks network. So that's this purple link, and that's a one-wire pair that goes directly to a card installed in the DCC. So that's this purple link. You very rarely will see any modern system with that nowadays. So the modern system would only have Ethernet connecting the two. And then this red network is a local network on a DXL system. It's composed of just a USB cable. And I'll get into that in a couple slides. So that's the basics of the network. You have your exchanges, which is the DCC and the equipment it controls, your network, your Ethernet network that connects them together. your USB network that connects devices within the system, and if you have an older analog system, then you have this digital audio trunk in a loop between the systems. So I mentioned an exchange. So an exchange is the equipment controlled by a DCC, or digital communications controller. In addition to, so the exchange will consist of the controller along with up to 4 digital communication expanders, or DCEs. That's the second one here. So the top one with the screen is a DCC. The bottom one with no screen is a DCE, digital communication expander. It has the same input and output capability as a controller, minus the main processor, which is part of the DCC. So you have one DCC can drive up to 4 DCEs on the system. The DCE, so part of this will have analog master stations, analog intercom stations, both handled by DCC, and the DCE can have some analog masters and some analog intercoms. If you need paging speakers, we have something called a talkback expander, which is what we have here on top, which can have 8 high-power paging speaker outputs. So that's treated like a communications expander. So you can have a maximum of 4 combination of talkback expanders and DCE expanders, maximum 4 in the system, 4 per DCC. And then we have a relay switcher box for paging called a page zone expander, PZE, which can add additional relay switched outputs that can use to control a paging speakers in a traditional sense, of relay switch sense. So that's the only place you'll see relays in our system, is with a page zone expander. The limitation on DCEs and TVEs is due to the amount of audio that you can put on a single USB connection. So that's why there's a limit of 4, is because of the limit of how much audio you can put across the USB ports connecting them together. A page zone expander is a bank of relays. There's not a lot of data needed for it, so you can have 12 page zone expanders on that same USB bus. So an exchange is a building block component part of the system, DCC and the equipment that controls. In most cases, a DCC, you'll have an exchange per equipment room. If you have a lot of devices in an equipment room, you might have multiple DCCs just to handle the amount of devices, but typically you would have 1 DCC per equipment room at least. We can have a maximum, and this maximum keeps increasing as the processing power of our DCCs increase, but you have a maximum of, on this slide, 54 DCCs on a system. It's actually increased to 64 now, if I recall correctly. So there's a limit based just on the processing power and on the networking capability of how many systems can be, how many DCEs, how many exchanges can be on a system. So this slide shows you 54. Now, on the next slide, I'll show you the quantity, but how we get these. But each DCC and DCE can handle 32 intercoms. So a DCC and 4 DCEs works out to 100 and let's show here. No, so 5 times 32 is 160 intercoms. So you have 160 intercoms within one exchange, and then you multiply that by 54 exchanges, so that gets you to 8,600 intercom stations that you can have. You have 2 masters per DC, 2 analog masters per DCC or DCE times 5 on DCCs and DCEs, so you can have up to 10 analog masters on an exchange times 54 exchanges is 540 analog master stations. You have 13 IP master stations on an exchange, so multiply it by 54, you have 702 IP master stations. So that's how you come up with all these numbers. So you can have a large system composed of up to 54 of these exchanges. So in the exchange, every exchange has to have a DCC. That's the control portion of that exchange. It has a processor on it, it has a digital switch on it, it has a couple USB ports on it, and it has an Ethernet port on it, and it has the keypad display. In addition to those, it has what's standard between it and the DCEs. It has up to 2 station cards. They each have 16 intercoms on a station card. And it can have a master card, which can have a bunch of I/O on that. I'll get into that on the cards shortly. So each exchange has to have minimum has to have 1 DCC. Optionally, you can add up to 4 DCEs on it, which add additional stations, add additional masters. If you need high power paging, you can have a talkback expander or TBD, which provides 8 paging outputs, 8 separate circuits of paging outputs on each TBD. A page zone expander provides up to 18 relays to switch an external amplifier between multiple speakers. Then we have a couple options. Our most common option is RT10. Which provides up to, again, it's expandable, but it provides multiple switch inputs and multiple open collector or open drain outputs to control devices such as relays and solenoids and lights. So if you need additional lights or relays or something connected to the system, we have an input output module or extra switches connected to call buttons or loop detectors or something like that. An RT10 can provide those inputs. We can expand them. As shown in this corner here, you can expand modules by adding additional modules next to it to add additional I/O capability to it. The RT10 has a Ethernet port on it, so it's Ethernet connected. So it's kind of the building blocks of DCC is the minimum for each exchange, and then you can add additional expanders, BC expanders, TB expanders, PZE expanders, RT10s. And then the individual building blocks, the DCC, digital communications controller, has the main processor, has the keypad display. The main board on it has the digital switch, has some digital signal processors or DSPs on it. It has your Ethernet port on it. If you have an audio trunk system, it has your audio trunk port on it. So that's the main board, what we call it, the PCC process control card is the main board in the bottom slot of the DCC. If you have any analog masters or line level inputs or line level outputs, and there's some relay outputs, 4 relay outputs and 4 extra switch inputs, then you may have a master card installed in the top slot. Not many systems do, because most systems now use an IP master. So you don't see a master card installed very often unless you need, typically unless you need the I/O on it. So an MCC is a master card if you have it installed in the upper slot. And then you have 2 station cards on the lower part and upper part on the other side. Station card 1 handles 16 stations. Station card 2 handles 16 more stations. So they can be either 300 series card for 25 volt intercoms, it could be a 400 series card for Harding intercoms, so or a 401 series card for Harding intercoms with LEDs on them, with or without LEDs on. So you can order a system that has, say for example, if you have some Duquesne intercoms and some Harding intercoms, you can order a system that has a 300 card in the first slot and a 400 card in the top slot, or vice versa. So you can order, specify what kind of card is in each of the slots. So that's where you add additional stations on the station card slots, or SCC, station control cards. You'll hear that a lot. Station control cards are the most common part of the system, so you're going to see that acronym a lot, SCC card. And it has the ports for the intercom speakers, and for the intercom call buttons if it's a 300 series card. So there'll be 2 connectors on the card. And then lastly, on a DCC only, you're going to have a card, an option card that's going to, in most cases, it's going to have the voice over IP card, what we call the IPA, the IP accelerator card, will be in one of the slots, pre-installed in one of the slots. Older systems that have the old style IMS 440 masters, in that slot instead will be a long-range card with a little orange connector on the back. So there's only one option slot, so either a VoIP card or a long-range card or no card. So only a DCC has that kind of card slot. If you need more than 32 intercoms or more than 2 masters, analog masters, then that's where you would add a DCE, digital communications expander. It doesn't have the main processor on it, doesn't have the Ethernet on it, but it does have all the additional I/O. So if you need additional masters, you can have a master card, the same master card that a DCC has. Cards are interchangeable. So if you need additional masters, you can order a DCC with a master card with MCC in it. If you need additional stations, which is the most common need for a DCE, you would have SCC cards, the same SCC cards interchangeable with ones that were in a DCC. So it's the same I/O capability to have master cards for 2 masters, 2 line level inputs, 2 line level outputs, 4 relay outputs, and 4 switch inputs, as well as 2 masters on it. But so the DCE can add the master card and the station cards, same thing as the DCC. The only thing is it doesn't have the Ethernet port, and it doesn't have it doesn't have the audio trunks, and it doesn't have the keypad display. So that's what the DCE is. It's just basically the same thing, the same loadout. The main board on it is called a PCE card, and it's very similar to what's on a DCC, but it has no processor, has no main processor on it, has no Ethernet port on it, has no Ethernet on it. So it's a cut down version of the DCC without the main processor on it. The other cards are exactly the same, and that's what you need if you're adding additional stations or masters to a system. You add additional DCE expanders. A talkback expander or TBE expander is when you need to have high power paging speakers. So a talkback expander provides 8 high power paging speakers to the system. It includes the amplifier, so you just need to hook up the speakers to the system. So it provides up to 5 watts of power per channel. Each channel is independent, so you might have one master talking to a page zone consisting of one of them, another master can talk to a page zone consisting of one or more of the rest. So they're all independent and can operate all at once, either as a single call at once or individual calls to each of the speakers. So there are 8 independent amplifiers connected to the intercom system. We have a version for 25 volt speakers and a version for 70 volt speakers. So you need to order the correct model for what kind of speakers you're driving. There is no combination model. You can't get a model that has 25 volt and 70 volt speaker outputs. You either have all 8 or 70 or all 8 or 25 volt. If you need more than 5 watts of power, we have what's called a bridging mode. So you can take 2 consecutive channels. So you can take, say, 1 and 2 or 3 and 5, 3, 4 and 5, 2 or more consecutive channels and combine their power. You parallel them together, going to one pair of wires going to your speakers chained up. So you can parallel them together to provide 2 channels. It could provide you a 10 watt output. 3 channels, you can provide a 15 watt output, etc. You could chain all 8 of them together to get a 40 watt output if you wanted to. Although it's probably cheaper in that case to get a separate 50 watt amplifier or whatever and use an output, another kind of output to get to that. But you have 8 independent 5 watt outputs, and you can combine them together to get higher power. One thing I didn't mention, and I'll kind of mention a little later, is the process control board, either on a DCC or on a DCE, has the digital signal processors on it. If you're going to do more advanced features like audio level alarm, where it has to constantly monitor each speaker, that requires an additional digital signal processor on the card. And when you order a DCC, one of the options is going to be whether it has an enhanced processor card or not. An enhanced processor card has the additional digital signal processor to handle just the audio level alarm. So if you need an audio level alarm, you need to order it handles whatever stations are on the station cards in that unit. So the process card, the DSP on that, the DCC can monitor any of the stations on that DCC. The processor card on the DCE can monitor any stations on the DCE. So if you have any audio level stations that need to be monitored for audio level alarm, the DCC or DCE that the stations are connected to need to have that enhanced option. They need to have that additional digital signal processor. So if the end user says, well, I want to be able to monitor any speaker, but I don't know which one I need to monitor now, then you need to order every DCC and every DCE with an audio level alarm with the enhanced processor on. If they tell you beforehand, I need these speakers monitored, if you stack them all on the same DCC or DCE, or try to limit them and put them all, try to consecutively put them all on the same one, then only the DCCs or DCEs that have the stations to be monitored need that enhanced processor card, the additional processor DSP on it. So if you know where they are, if you can stack them all up, you can save some cost by having to only equip the ones that you need with the processor card, with the additional DSP on it. Now, the TalkBack expander, rather than handling 32 intercoms, only handles 8 intercoms, but ultimately the same digital signal processor on it. So there's enough excess power on the single processor on that to handle the audio level alarms, the screen alarms, the threshold alarm. So TBE always has the ALA capability. The DCCs and DCEs, you have to order it with that second digital signal processor to handle that. The other type of head-end equipment you might see is what we call a page zone expander, or PZE. Looks almost exactly like the TBE. The difference, rather than having 8 amplifiers with preamplified outputs, it's basically a bank of switches. There's actually 3 banks of switches, to be exact. 3 banks with 6 switches per bank. And all it does is it turns relays on and off. So the point of this is that you have in this case, you want to have a paging zone that has multiple speakers in your facility. You don't need to independently address them. So just basically you need to select one or more speakers in the paging. What you would do in this case, instead of buying a TBE and multiple TBEs, you would buy one page zone expander, which can switch up to 18 relays. And you would buy a high power amplifier. We don't sell amplifiers, so you can buy like a Bogan or a Duquesne amplifier. So you buy a third-party amplifier with however much power you need. So if you're gonna have to drive 100 watts of speakers, our TBEs can't drive 100 watts of speakers. So you would then get an external amplifier of however many wattage you want. You have some sort of line level output in our system. There are multiple ways to get a line level output from our system. The MasterCard is one of them. There's a few other cards, a station port adapter. I'll get into that a little later. So you need some sort of line level output. That line level output goes to your amplifier. Your amplifier now provides an output that would normally drive, say, 100 watts of speakers on it. It could, if you're just driving one set of speakers, so you got a one circulation hallway or one circulation circuit in your system, and you only need one set of speakers, then that's all you need. But if you want to take that 100 watts and select which speakers you want to come out of, so if you want to have, you have this one amplifier driving all your circulation, but you have a west hallway, an east hallway, a north hallway, and a south hallway, and you want to divide that into 4 zones, and an all page may have all of them, but a west page will only involve the west one. In that case, the PZE is what the device that you need. The PZE takes that 100 watt output from your amplifier, and it can go to one or more of your speakers or your speaker circuits through this bank of relays. So there's 3 independent banks of relays, each with 6 relays. So you might have 3 amplifiers with up to 6 selection relays on it, which your relays will hook up to your individual outputs. Or if you need more than 6, you can chain them together by taking the same amplifier output and paralleling it across the same input on 2 of the banks. So now your same amplifier drives up to 12 relays. Or you can chain it across all 3 banks to get up to 18 relays. Or you can chain multiple PZEs together to get more than 18 outputs, or more than 18 banks if you want. So it needs an external amplifier, it needs a line level output, and then this provides the switching to determine which speakers to go to.
Darren, I got a quick question.
Okay.
What is that purpose of the key on that circuit?
Okay, so the key on that circuit is an additional relay that you can do whatever you want with. So the engineering intent for that key switch is, say for example, you've got an amplifier that has an input to turn on the amplifier. So that you don't, for example, an amplifier that's connected to a bank of speakers that has no signal on it, you might have a very low level hum on that speaker output. So you get a kind of low level hum or a low level hiss. An amplifier with a switched input is, if that switch is turned off, that amplifier has no signal going to the speakers. So the speakers will be dead quiet. The key output can be used so that you can program that to go on only when a page zone is being called. So the key output can turn on the amplifier, so it only turns the amplifier on whenever there is a page active. So that's the intent. Another common, it's very similar purpose for that is sometimes some facilities, they have a fire alarm paging system already pre-existing. And they want to reuse the fire alarm paging system, and it's got a line level, it's got some kind of input, and it's got a key switch to activate it. So the key switch would be, basically you would tie that into the fire alarm paging system, say, I want to page into the system now, turn on the outputs for that amplifier now. So that's kind of what that key switch, but in actuality, it's just a controllable relay from our system, so it can be used independently of a page zone. So if you need to, say for example, you have some speakers in a medical unit, and you have the need that you have some paging speakers, so you've got a TBE, you got a PZE in this area, but you might have a need to turn on a strobe light above a patient door to indicate when their call button was pressed, so that the nurse can look down the hallway, oh yeah, this guy needs attention. You can get a separate output from our system. There's a bunch of ways to get an output from our system, but you can actually use this key relay to do that. It's just another output on our system that you can program whatever you want. But the intent our engineers had to include it on here is a output to turn the amplifier on to indicate that they want you want that page is active. So that's kind of the intent for it, but it's just a separate output that can be used for anything in particular.
Okay.
And in addition to that common, feature set, there's also an additional set of switch inputs. There's a connector that have additional 16 switch inputs, and then they can be used for anything. So it could be call switches. It could be, I think the intent for this is more for, it could be like you could have some switches on a receptionist desk, and a switch will select which. If they hold the switch down, it makes a page announcement to zone 1 or zone 2 or zone 3, depending on what switch you press. So there's an additional 16 switches that can be used for anything our intercom system can do. They can be as a page initiation switch if you want. This switch inputs is something our engineers added. I have heard of one customer in my time here of actually one customer using those switches. So it's not a very common use, but if you need it, it saves you having to add some kind of additional input, some additional card to do the switches. You can do anything that a switch can do in our system with one of those switches. So that's a page zone spanner, PZE. So it's a bank of relays that you use to control paging. The traditional relay switch way. So this is really the only time you'll see our system using relays to control something, is this page zone expander. So that describes the head-end devices. And then the rest of the devices are the end devices that you would see on the system. Other than IP devices, our DXI system and DXL system use the same devices. So if you're upgrading from a DXI to DXL, you just need to upgrade the head-end equipment. The rest of the stuff will be covered, directly hookable. So I'll start with some DXI devices that you're not going to see on DXL anymore. So initially, if you needed some additional relay outputs or switch inputs, I need a drink here. If you need some additional inputs, we would normally get what we call a DIO card. You'll notice the obsolete in the corner because it's really only for DXI anymore. So it adds up to 48 input switches, 48 either digital outputs, what we call source, which is a 24-volt output when on, a sink, which basically closes a open collector or open drain when on, or a relay. So you have 48 inputs, 48 outputs. It's used for inputs and outputs for extra doors, for door switches or additional call buttons or lighting control, like strobe lights for medical units. So if you need that kind of thing, on a DXI system, you would have gotten a DIO, a discrete IO board. It communicates back to the system with LonWorks. These other cards that I mentioned, the expanders, communicate back to the DCC through USB. So there's a standard USB port. You use a USB cable to connect them up. I'll get into that in the wiring part this afternoon. Our DIO basically uses that LonWorks network I mentioned to communicate back to the main control unit, which is why you don't see those on modern DXL systems, because DXL doesn't have that card slot. The card slot's used for the VoIP card. So you can't hook up a DIO card to the LonWorks because there is no LonWorks, and you can't put a LonWorks card in because the slot's occupied. But on an existing DXI system and some of the older DXL systems, you may have used these for additional switch inputs or additional relay outputs for lighting or whatever. We do have, I did mention already that this RT10, it provides the same functionality by using Ethernet and can be hooked up to a modern DXL system. So this is the equivalent that if you had a DXI system that had a DIO or maybe a DXL system that you're going to convert to VoIP that had a DIO card, then you could replace the DIO card with one of these. I mentioned LonWorks. So there was a way to extend the LonWorks network. There's a limitation. There's a limitation on the LonWorks network used by LonWorks devices. If you need to make a longer network or a lot more devices, we have a repeater for the LonWorks network called a free topology repeater. FTR, free topology repeater. It's based on the LonWorks network is actually technically called a free topology network, which means you can wire it however you want. It could be in a chain, it could be in a hub and spoke. So that's where FTR comes in. That'll come into play when I talk about the LonWorks network tomorrow, this afternoon. Devices that are common, the DXI and DXL, there are touchscreen master modules, or our TMMs. So that's the standard type of master station that you would see at a control room that has a touchscreen or a graphic panel on it. So a touchscreen master module, or TMM, has a speaker and a microphone. There's a few variations of it. The one that's shown, it has a, the same as what I have up here. So it has a speaker on the base and a microphone on the gooseneck extension. We do have models of that has a speaker, has a microphone located at the base of the unit too. So it has a speaker and a microphone and a push-to-talk button and a volume control on it. The analog version of this, TMM441, the 4 means it's a hardening interface, has a needs 2 pairs of wires back to the head end, hooks up to a MCC or a MasterCard port on the DXL system. The speaker and microphone are within hearing distance of each other, so it operates in what we call a half duplex mode. So that means you can talk when you hold push to talk down, you can listen when you release the push to talk, but you can't talk and listen at once because otherwise you'll pick it up. You'll pick up the speaker and the microphone and vice versa. There is a jack on the back that allows you, that's the wrong one. That's the one right here, which is connected. There's a jack on the back. You probably can't see it very well, but there is a jack on the back that allows you to hook up a telephone handset to it. That if you wanted to have a full duplex operation, talk and listen at once, you can pick up the telephone handset, you can talk on the handset without having to use a push to talk. So that is available, but that is a jack on the back for that. It includes a line level output that is typically, so it has a built-in speaker on it. But a lot of facilities, they have all of their control room sounds coming through a PC speaker. So if you wanted to, you could take a standard line level or standard 3.5 millimeter jack, 1/8 inch jack, and you plug one end into the TMM, you plug the other into the line input on your PC, and now the speaker output goes onto your PC speakers. So we have that option if you want. Once you plug that in the back of the TMM, the TMM speaker is muted, all the speaker audio goes to your computer. So you can now use your computer's volume control to control the volume of the speaker. Just needs the 2 pairs of wires going to it. It handles all the audio, handles the amplifier, it powers it through those 2 pairs of wires. There's also an additional microphone input on the front. Headset input on the front. So if you want to use a headset with it, you plug the headset in the front. Uses a cell phone style. We don't have a Bluetooth version available. It's just a wired version available. So you get a standard cell phone style headset connector. Plug it in there, and you can use a headset as a speaker and microphone. And there's also a not very often used jack on the back that takes the microphone signal, passes it out, and you can process it, put it back into the system. So that's typically used for a feedback suppressor. And that's kind of a topic maybe we can do as an optional topic, but I won't discuss it directly right now. So that's what that connector is for. It's basically for a feedback suppressor. So that's what a TMM 441, that's our current TMM one. So there's on the jack on the back, on our current one, has a 9-pin connector on it for that audio connection. We had an earlier version of that called the TMM 440. And this is kind of more of a historical thing. So if you're maintaining an existing slightly older system, not a really old system, you might have what's called a TMM 440. So the only difference, does the same thing. The only difference is the jack on the back. And the reason being is, that's not the one. This is the one here. So the TMM 440 has that jack on the bottom. What does that look like? That looks like an Ethernet port, doesn't it? That's not Ethernet. This is actually 2 pairs of audio onto that same jack. So it's an analog master. It needs 2 pairs of audio, just like the TMM 441 does. But our engineers, one of the complaints we had when we did our DXI system is that we use DB connectors a lot, the D sub connectors, which our engineers love because you can provide lots of connections on the same connector. But the installers don't love because you have to. There are a couple ways of doing it, but the most common way of connecting something to a DB connector is soldering wires onto it. And when you're in the field, maybe you're on a facility that doesn't have power yet, soldering wires in the field is a pain. Now you can get gas-powered, butane soldering iron, so you can do that.
But it's a pain. So we had a lot of complaints from our customers. Well, you know, our previous master stations used a DB connector, and our customers complain, well, you know, it's so hard to solder something onto the DB connector. Can't you use something with the crimp on? Now, the DB connectors do have crimp on style, so that's kind of why we went back to that. But so our engineers said, well, you know, hey, you probably have a crimping tool to use for Ethernet jacks. So let's use this connector on our master stations. Even though it's not Ethernet, you have tools for that. But the same reason why our engineers specified it is the reason why it's not very, it didn't work as well as we expected, because people look at that connector and they go, well, it's an Ethernet jack. I'm going to just hook up my Ethernet cable the way I normally, that's not an Ethernet cable. That's not an Ethernet port. So it's confusing. And the other thing too is we don't recommend, I'll get into the wiring for this afternoon, but Ethernet cable normally isn't shielded, but we recommend shielded cabling for this. So it's hard to get the right kind of cable hooked up to this kind of connector. So that's why our TMM 440 uses connector for those reasons, but it's bad for those reasons. So we discontinued the TMM 440 for the 441, which is the same thing other than it has the additional mic input connector, and it changed the connector from a RJ45 to a DB connector. So if you have an existing system that might have these, if you want to order if something goes down, you want to order a replacement, you can order a TMM 440. We're going to discontinue them, but we do have an adapter cable that has a DB9 on one side and an RJ45 on the other side. So you can take a TMM 441 with the adapter cable, which the adapter cable provides this RJ45 jack. So now you can take a TMM 441 in place of a TMM 440 in an older facility. So it is replaceable. It's the same signals, different connector. So it's kind of a historical thing. If you've got the 440s, you're not out of luck. You can get a 441 with the adapter and use the same cable, not have to wire things up again. But just as a note, that's the only real difference is the connector on this. In some cases, you don't want to have a desktop, something on your desk like a TMM. You might want to have a speaker mounted in your console. So we have a solution for that. So this is an all-in-one unit. It has the amplifier, has the speaker, has the microphone. Everything's in one unit. You just need a cable to the master card. A MAI is a master audio interface. And so it's a two-piece unit. It's the amplifier in the black box, and it's the speaker in the console. So it's basically the guts of a TMM in the black box, and the speaker and microphone of the TMM in the speaker, as well as a push-to-talk button. So it has connections for the telephone handset on it, it has connections for your speaker on it, and it has connections for your head-end equipment on this DB connector on the back. So that just basically is a couple ways of getting the two-piece unit. So you get a console-mounted speaker. It includes a handset and a headset option, so there's additional connectors on there for that. And it requires, unlike the TMM, it does need a separate source of power. So it needs two pairs of wires, one pair for the speaker, amplified speaker, one pair for the amplified microphone, and then a third pair of wires for power, because this one needs additional power, so it needs a 24-volt power source. Oh, we're at 12 o'clock. Okay, I'm almost done this. All right. And so that's the MAI 425, which is basically just a speaker and microphone. And there's a bunch of different speakers. So if you wanted to, an older system before we came up with TMMs may have used this MAI and a separate microphone. So this separate microphone only, there's no electronics in it. It's called a DSM, desktop speaker microphone. You may see really old systems with that, and we can still sell them. But if you're doing a new system, we recommend getting the all-in-one TMM 441 instead. And then we have the IMS master station. I showed you that before, so it has a LonWorks connection. It's a way to have it. You can use it for part of a touchscreen system. You can use it independently. So this could be in a shop office, or it could be in a warden's office. It could be in a control room, and you don't necessarily need to use a touchscreen with it. So you can use it independently. You can use the keypad and dial out, answer calls. You'll see calls will come in on the display. So that's what an IMS 440 is. It's just basically it's a desktop master that can independently place and receive calls, or you can do it from your touchscreen. It has a display on it, has a built-in speaker and mic, has a handset on it already. It has a headset option on the side, and it needs 4 pairs of wires for it. 2 pairs for the audio, 1 pair for the LonWorks, the control for the keypad display, and 1 pair for the power. You can't use these on a modern VoIP system because it needs a LonWorks card, and a VoIP system has a VoIP card instead. So on a modern system, you'd use an IMS 641, which is an Ethernet version of this. If you needed this as a console mounted, we can do that too. There's 2 pieces to it, or actually 3 pieces to it. There's a keypad and display, we call it IMS 130. There's the master audio interface, which we call the MEI 420, which is the same as the 425, but it has a ribbon cable that goes to the display. And then you have whatever speaker and microphone you need. It needs the same wiring that a IMS master does. It needs 4 pairs, 2 for audio, 1 for LonWorks for the control, and 1 for power. Just as a note, if you're using any of our MEI separate master audio interfaces and you're not using our speakers, our devices are designed to use what's called an electret or a condenser microphone. So if you have to use a third-party microphone, you'll need to make sure that the third-party microphone is a condenser or electret microphone, not a dynamic microphone. The technology, how the microphone is driven is a little different, and the circuitry needed to drive those is a little different. So a dynamic microphone won't work well with our system. And in fact, it could burn out the microphone or the amplifier if it's used for an extended period of time, just because of different circuitry required. So just keep in mind, if you are using a third-party panel microphone that has a panel built into it, make sure that the panel microphone is an electret microphone or a condenser microphone, not a dynamic microphone. Our intercom stations are called, our new intercom stations are called ICE, Intercom Economy, or the older intercoms called ICMs. And the main difference, they do the same thing. They're all the same thing. They're all 400 series. Really, the only difference is cost and the button. So our ICM intercoms, so this one right here, that's on the bottom display, is an ICM intercom. So it has, if you were to look at the circuit board, and this is the same thing. If you look at the buttons are sticking out of the faceplate. If you were to look at the circuit board, which you're probably not going to see very well in this picture at all, the circuit board itself has the button as part of the circuit board. So there's a plunger that pushes down on the button on the circuit board. So the button is actually part of the circuit board. It just pokes through the metalwork. So our ICM intercoms have the button on the circuit board, and they have a little bit, this one's all scratched up. This is a demo that's been used for a while. It has a beveled edge, and it has fairly shiny finishing on the intercom. You might not notice it very much on this. So this is an ICE intercom. Actually, I'll do this one here. So this one has a button that is separately mounted on the faceplate. So it's not part of the circuit board. So it's a button that's a separate button on the faceplate. And the outside edge isn't quite as, it's still polished, but it's not beveled like it is on the ICM. And it has a different circuit board on it, which is a little more generic, a little more common
that all of the ICE intercoms have the same circuit board with different programming on them. So it's cost reduced in that it's a little bit less finishing on the faceplate, and it's a probably even a better circuit board, but it's a more common circuit board that's basically, we keep the same stock of it. There's no special stock for this type of intercom or that type of intercom. It's all the same circuit board with different programming. So it's cheaper than our ICM. But they do the exact same thing. So you can order either one and they'll work just as well in any of our systems, whether it's an older system, a newer system, a DXI system, a DXL system. They do the same thing, but the ICE is a little cheaper. So you get them in, these are 2 gang, this is a 3 gang. You can get them in custom sizes. We even have them in 1 gang size with a teeny tiny little speaker. So it's a 410 with 1 gang. You get them with a either a piezoelectric button, you can get them with a big panic button for ADA requirements. So there's a lot of different options for them. So you look at the data sheet for the type of intercom, the ICM or the ICE, to find out what part number you need. And they have interior and exterior versions, and versions with LEDs, versions without LEDs, versions with engraving on them. So they're interchangeable. They don't, you know, if the site has an ICM, you don't have to order an ICM to replace it. You can order an ICE to replace it. They're functionally the same. They're dimensionally the same. Really, the only difference is the finishing and the price. So you can interchange between them. The replacement parts, however, if you want to get a replacement part board for ICE, you need to order an ICE replacement board. You can't take an ICM replacement board and put it in an ICE or vice versa. Well, you can, but it's a little bit more involved. The replacement boards are different, but the intercoms themselves are interchangeable. You can get 300 series intercoms from us. What 300 series intercom really is a speaker and a transformer. So a Duquesne intercom, from the point of view of our system, is a 300 series intercom. An A-phone intercom is a 300 series intercom. A QAM intercom is a 300 series intercom. So it's a generic term for a 25-volt intercom with a separate call button. You can buy intercoms from us, so you don't have to buy a QAM intercom if you want to have the 25-volt intercoms. You can buy a 300 series intercom from us. So, and it's this pretty much the same options. In most cases, the 300 series, this actually is a 300 series intercom. This has a push button, it has a transformer and a speaker, and that's all it has. We have versions that don't have a circuit board, they just have a transformer on. So there's different versions of this. And we also have a 1 gang version of that. You need 2 pairs of wires, one going to the speaker and one going to the switch. And we have ICM versions and ICE versions. Again, it's the main thing is the finishing on the intercom. You can order custom sized intercoms. It'll either have a CUS at the part number or a 9 in the part number somewhere, depending upon how special, how custom it is. So you get them with unique sized or shaped faceplates, custom engraving on the buttons, additional buttons more than the 2. You got this weird for the individual here working at Lethbridge. You're going to see these guys, and these are kind of special. Well, they're not special. They're standard intercom, but they were designed that when that system was installed, they didn't have any intercom in the cell. So what they did is they drilled a hole. They did a core drill hole through the cell with a countersink. They put this on the front side of the cell, and secured on the back of the cell. There's a plate on the back, and there's a couple of big threaded nuts that go on the back of the chase that take the back of the cell and secure it. So they don't have any. There's no mounting holes in the concrete. It's actually like just a whole board in the concrete with the intercom sandwiching the concrete. So you got this on the front side, and you have another plate on the back side that holds the intercom in place. So that round one you'll see when you're renovating the Lethbridge site, but it's basically just a standard intercom, Harding intercom with 2 wires on it
with that unique mounting scheme. So this is a custom intercom, what we call a custom intercom. So you can order them with custom switches, engraving, sizes, shapes, add additional connectors in it. So we have some sites that have the cells have the ability to have a TV in them. So they have a TV connector, a TV jack on it. So you can get whatever you want in the custom faceplate, we can do for you. If you need to repair intercom, you get you can buy replacement kits that include the circuit board. So you can either convert a regular intercom into a Harding intercom by adding the circuit board to one. So this is typically done in, say, a vehicle, say an outside pedestal. So you got a Sally port pedestal or a gate pedestal that has a standard 25 volt intercom in it. You can buy one of these intercom boards, ICBs or IEBs. So ICBs using the ICM circuit board. IEB uses the ICE circuit board. So you get a circuit board that converts standard intercom into a Harding intercom. And you get all the benefits of a Harding intercom in that case, even though you physically have some other intercom other than the Harding one. Same capabilities. One wire pair goes all the way to the intercom and handles the button and intercom. You can detect whether or not the wire is disconnected or not. So you can convert an intercom to that. There's two styles of that. One with a little heat shrink on it with Velcro on it. You just kind of slap on the inside of your back box, or you can get just the circuit board itself. And you get various versions of convert, either use an 8 ohm speaker or a 45 ohm speaker or a 25 volt speaker to a 400 series intercom station card port, SCC port. And you can also buy repair kits, station repair kit, SRK, which if you have a intercom that needs repair, so maybe it got water damaged or something happened with it, you can get a repair kit that basically includes everything except for the actual faceplate itself. So it includes a replacement speaker, which might be damaged if your intercom is waterlogged, or a replacement circuit board if it gets damaged by lightning or also by water. So our station repair kit includes one speaker and one circuit board for that type of station. So SRK 401 repairs an ICM intercom, and SRK 402 replaces an ICE intercom, and SRK 400-3 replaces an ICE LED intercom or other specialized intercom. So you'll want to order a few of these for your site for spare kits, for spare parts. So if you got ICE intercoms, order some SRK 400-2s. If you have any ICM intercoms, order some SRK 400-1s for the repair kit. So it includes the speaker and the circuit board. Let's see how much further I got. Okay, so I got about 5 to 10 minutes. All right, we'll power through this. A station port adapter. So I mentioned that in some cases you want to have a line level output from your system. So a line level output will be if you want to say go to an external amplifier, or if you have a analog call recorder, some way to get an analog output into some other system. That's where a station port adapter or SPA comes in place. So there's a few ways to get analog outputs. So I mentioned a MasterCard, which has analog outputs on it. So you can use a MasterCard and not have to have anything else, but most systems don't have that. So a station port adapter is basically a conversion from the 25 volt signal on a station card, station port, to a 1 volt signal for a line level output. So it basically has a connection on it. So a connection where you would normally hook up an intercom station. So you would normally have an intercom's SCC card port going to an intercom station. Instead of hooking it to an intercom station, you hook it to the input on this, the audio plus and minus on this. And then for your line level output, you would hook up to the output on this, the line level output. So now you've got a line level output that you go to an amplifier or a call recorder or something. So it converts a station port into a line level output. That's what these SPAs do. So if you need that, that's what you order. You can order handsets. So we mentioned video visitation, so that's at FDH 420, which is a 2-gang faceplate with a handset on it. So it's typically used for video visitation. It may be used for reception areas where someone walks in the door's locked, they pick up the phone, that rings up reception. Reception will see that call up and then they'll answer it on their phone. They may press the button to unlock the door or whatever. So that's what another use for the FDH in addition to visitation. FDH 440 is a 4-gang version of that has also, in addition to the handset speaker, it has a speaker on the actual faceplate itself. So if you call that, you'll talk out on the speaker. Someone picks up the handset, it now goes to a handset, so it's privacy mode. So a school, for example, if you want to make an intercom announcement to a school room, you might well have one of these in there. So initially the sound says, hey, the teacher, the instructor, please pick up the phone. So they can hear it on that. They pick up the phone, and now it's a private conversation. The speaker audio comes out the handset speaker, and the microphone comes from the handset microphone. So this basically switches between the built-in speaker and the handset speaker, depending on whether it's on or off. So that's an FDH 440 4-gang handset. And lastly are the IP-based devices. They're the same as the analog devices, but they are Ethernet. So the TMM 641 is our Ethernet master station. It has a speaker and a microphone. It has an option for a gooseneck microphone or a flush mount microphone. It's only for VoIP systems, so you have to have a VoIP card installed. Pretty much all modern systems do. Connects through, it has a handset option, it has a headset option. Connects through Ethernet. There's 2 Ethernet ports. One with power Ethernet, so if you're powered with power Ethernet. The second port is normally you would bring one Ethernet cable per Ethernet device, and you'd have your switch in your head in your control room, in your equipment room somewhere. In some cases where you might have a limited function computer or maybe 2 master stations in the same equipment room and you forgot to pull 2 pairs of cable, there is a small network switch built into this. There's a 2-port network switch, so there is a second port on there. So you can chain a second port to another master or a PC. Not really recommended because this is only a 100 megabit device. So if you're connecting to a PC, it's only a 100 megabit connection to your PC. If it's connected to another master, it doesn't include power Ethernet on the second port. So the other master will need to be powered by a cable. But there are 2 ports if an emergency, if you need to use it. Normally they're powered with power Ethernet through the PoE port, but we also have an AC jack and an AC adapter that you can use to power it with a local power. So to save costs on your Ethernet. The TMM 641 and 640 and 641, we only sell the 641 now. It's identical, the connector's identical, unlike what I mentioned with the TMM 440 and 441. They're both Ethernet. The only difference is the 641 has that feedback suppressor jack on it. That's the only difference. No price difference on it. So we only sell the 641 because they're functionally and wiring identical. If you want to have an Ethernet connected console mounted master, we have that too. MEI 625, 6 being voice over IP. So just like the MEI I mentioned previously, it's a amplifier unit, mounts under your console, and it's a separate speaker that mounts in your console. So you can get the MEI, it's Ethernet connected, has 2 Ethernet jacks, just like the IMS MEI TMM masters. Connected, can be powered by PoE, can be powered by the local power. You purchase the speaker microphone separately, they mount on the console. We provide a speaker microphone with a faceplate, SMK 126, or a speaker, just a basic speaker microphone, a push to talk button that you mount behind your own console, and that's a SMK 136. Or you can supply your own if the console has one. Again, make sure you have an electric microphone on your console. We have the line level input and output. We have the headset input and output. We have the handset input and output. and it connects to your Ethernet. Something that's an accessory to the MAI 625 is what we call the switch panel interface. So in some cases you might need a small graphic panel in conjunction with a master, and you don't have a PLC or you don't have a touchscreen or a control interface. We have this SPI or switch panel interface, which hooks up to the MAI 625 and only the MAI 625. So there's a basically two wires, a control, the data and a ground that go between the MAI and this SPI. And that provides you with 16 switch inputs and 16 relay outputs that you can use to drive a graphic panel. So you can basically have some connect switches and LEDs that indicate call request status of stations coming in to a graphic panel controlled by this SPI. So you don't need an additional PLC, you don't need any additional wiring, as long as you have an MAI to provide that provides the Ethernet network and those two wires, and this SPI, you can have additional switches and additional LEDs. Does need a power supply, and it does, as I mentioned, it does require an MAI 625 because it uses the MAI 625 Ethernet. We have IP intercom stations, 600 series. They're all economy, so they all have the same finish as our economy stations. So there are no ICM versions of this. They have up to 2 switches. They have the LED on them. Because they have the processing on them, they automatically have the audio level alarms. So you don't need to order any special head-end equipment because its processing is done on the unit because it's digitized and right on the station. Unlike our master stations, however, they only have one network port on them. So the only one using that port, there's no chain through on it. And they're only powered by power Ethernet. If you get the enhanced option, then you have the additional 12-volt input, and you have up to 2 additional switches. So the standard one can have 2 switches and an LED. The enhanced one can have 4 switches and an LED, and an additional relay output and a line level output. So the enhanced option provides some additional things and if you want more switches or more features. Then we have our IP desktop master stations, or IMS 641s, which are telephone style. They have a built-in speaker and microphone. They have a menu system and display. They have speed dial buttons along the side. They have 2 Ethernet connectors on them, one with PoE, one which is a pass-through, and you can power them with power Ethernet or with a power adapter. There is a switch, there's an input on the back you can hook up to a external foot switch for push to talk. So there's additional switch in addition to these 14 speed dial buttons on the side, so you can have a foot switch for the push to talk. The 641 is a master that we produce. We previously sold something called an IMS 640, which I don't even have on here anymore. Which is the same, it looks the same, it acts the same, but it's one that wasn't manufactured by us directly, so we can't manufacture anymore. So 640 and 641 are almost interchangeable. The only difference is how you set them up initially. Is the 641, I'll get into that when we get to that. So if you have any 640s, you can buy a 641 to put in this place. But we can't sell you any 640s anymore. But functionally, they're identical. The only difference is on initial setup is a little different. You get a IP paging amplifier called a PTA, paging talkback amplifier. This one only has one input, just like a station. It's not really practical to have a local power to these. So normally it's power with power Ethernet. You have a output for your high power paging speaker. So you can order these in sizes up from 1 watt to 5 watts. It could be a 8 ohm speaker, a 25 volt speaker, or a 70 volt speaker. You can talk and listen to it, so a talkback capability. We have 2 switches, so you can actually hook up, like say, for example, call switches to it. So you can have it as kind of operate like an intercom. It has a call switch, use that speaker. It has a line level input and output if you need that. Again, like the intercom, it has the built-in audio level alarm and power Ethernet. or the 24-volt power input, which is not very practical, but you can do it if you want. And then I mentioned the RT10, which is the I/O, which goes through Ethernet. Has up to 18 inputs and outputs on the main module. And each expansion module, which clicks into place, adds additional 24 inputs and outputs. Unlike our other devices, this is kind of based on our oil field equipment, so it's kind of a little bit different design. These can't be powered with power Ethernet. You need to have a 24-volt power input. And then you can get call switches. And yeah, so COD is basically a push button call operating device. So you can get call buttons to go on a wall if you don't need a full intercom. And lastly, all of our cables are mass terminated cables. Most of our connectors are DB connectors. They're a nice, easy way to have multiple connections on a single connector. So you will get when you look at the spec sheet for a card, so for example a DCC, it'll show you the cable numbers for the station card connectors. So we'll have a CBL part number. DXI will have a number describing what it connects to. DXL will have a name describing what it connects to. So CBL SWT is a switch cable going to a 300 series station card. A CBL STN is a station cable going to an SCC card, for example. And then the last digit indicates how long it is. So either you can use the standard lengths, 1 is a 5 foot, 2 is a 10 foot, 3 is a 25 foot, or you could put the length of feet. So a CBL 120-10 is the same as a CBL 120-2. It's a 10-foot cable. And then we have our own connector boards. So you can buy a cable that has our connector on one side and then bare wires on the other side, and you punch it down on your own punch down blocks. You can order those from us, but we also have the option that you can use our quick connect boards or QCBs, which have, so it has your rows of terminals. So for example, a station card will have, can have 16 stations, so there's gonna be 16 rows of terminals with 3 terminals per row, plus and minus and a shield. Then you would order a cable that would go to it that has a DB connector on the connector side and a DB connector on the DCC side or DCE side. And you just plug the cable into the quick connect board, and then you would wire up your stations to this. We have various types of quick connect boards, mostly for stations. So we have for 400 and 300 series stations, we have one that has 3 rows of 16 connections for the audio. And then if you have a 300 series that needs switches, there will be a second connector that has a 2-row connector on it that has 16 pairs for the common and switch for the 16 sets of switches. And then you would order the associated cable that goes with it. So if you have a DXL system with SCC 300s, you need a quick connect board 120-2, which is the speakers, and a quick connect 120-4, which is the switches. All right, sorry, that's the 2 is the switches, and the 1 is the speakers. And then these are the cables that you need for it based on what length you want. And before I send you out, so our system has a 2-year warranty from the time that we ship it. That gives you, typically you're going to give your customer a 1-year warranty once you install it. So that gives you a year to install it and then a year of extra warranty. But it's from when we ship it. So if you install it within 6 months, you got a year and a half of support, of warranty. We have a support division. We'll do, you don't need to have, there's no service fee. You don't have to pay us a continuous fee. We will support our systems for life of the system. So you don't need to buy a support plan from us. You only get support from us on phone or internet or email. We're not going to come down to your site and fix it. So we don't provide on-site support. But for the rest of our support, you call us up, we'll help you out, whether you're the initial installer, whether you're the end user, whether it's transfer ownership, we'll still support the system as long as it's operating.
That also includes our software updates. So we constantly provide enhanced software, both the DXL administrator software as well as the operating software on the units themselves. If you buy the system, you have free license to use our software for as long as you want. You don't need to pay a license for it. You don't need to buy updates for it. You can always download the latest version on our website that I provided earlier on with that link, our download site. So you can always download the latest version of our software on our site. There's no need for a login. There's no need for payment. There's no need for a subscription. Harding Tech, there we go. There's the download link as well. So you can always get our software. You can always get our manuals. There's no login for our manuals. All of our manuals are on our website directly. No login required. So if you need support, you can take a look at on our website. You can give us a call during regular office hours. So we're not going to be available outside on weekends or late nights. So if you need that kind of support, that's where you contact your integrator, and your integrator will hopefully have this training session and know what to do, and be able to help you out after hours, and they can contact us during regular office. In very special cases, if the facility wants to have us do a final inspection or commissioning assistance, we can provide it, but that's on a cost plus basis. Obviously, we're going to need to schedule within our schedule, and we'll need to, we'll need to charge you for the flights, accommodations, tech time on site. So it will be definitely a cost plus. It's not a freebie service. And if you do need to do a support or an install late evenings, then you want to have a Harding person available to answer any calls if there is a problem. We can provide late night support, but again, it's going to be on a cost plus basis. We're going to have to bring someone in. We're going to have to pay them a salary, so we're going to charge you a little bit extra for their time outside their usual hours. So it's possible, but it needs to be scheduled beforehand. All right. Any questions? If not, we will meet again at, what time is it now? 12:40. Yikes. So let's say we will meet at 20 after 1. Should give you guys enough time to grab some lunch. And we will start second half of the day then. Any questions, or you want to change that out for earlier or later? I'm not getting any. Oh, I got a hands up here. Garrett.
Yeah, hey there. My question wasn't about the timing or anything, but it was something earlier in your presentation on the VoIP intercom stations. I was just curious, is there a limit on how many of those can be added to a singular like Exchange or DCC?
So technically there is no technical limit. A practical limit is about 200. Once you get more than 200, the chit chat, what we call the registration, there's basically just the intercom regularly sends a message to the DCC and says, hey, I'm still here. I'm still here. So once you get close to 200, there's a lot of chit chat with those registration messages coming in. So we find that around 200, you have to very much plan. It's starting to get pretty much where that the chit chat is a registration traffic is a big chunk of the traffic that on the system. So more than that, it's not that it's going to stop at a 201, but what you can do is you can change how often those call in. So once you get more than 200, you have to, instead of, normally we recommend that you call in that registration should be about 2 seconds per intercom. So if you have 100 intercoms, you normally want to have set the intercom so that every 200 seconds you want to call in. And that just kind of gives enough overhead. So as you add more intercoms, you have to add that delay longer and longer and longer. And what that means is if the intercom goes down, it has to wait that delay before it declares it's down. So as you add more intercoms, it's going to take longer and longer for it to recognize that those intercoms are no longer working.
And just as there's more traffic. So at about 200 is where we recommend as a nice spot. Above that, you have to be careful. You have to do things like have the quality of service. You have to plan your network a little more once you go beyond 200. It's not going to break at 201, but it's going to be harder to manage when you get more than 200.
Okay. Sounds good. Thanks for asking the question.
So this afternoon, we're going to get into basically the planning, the technical details. We kind of went over an overview of all the cards this morning, all the components this morning. And I'm going to go more into how you wire, how you plan a system with using the DXL equipment. So we're going to kind of build on the experience we had this morning, just going over what you need to do to plan for a system.
Darren, we got a question over here. Jeff Rodriguez.
Is the PTA half or full duplex?
The PTA is half duplex because it's using the same speaker as a, well, it's normally half duplex. There is the ability to have a line level input and line level output to a PTA. So if you're using separate line level input and output, it could be full duplex, but for the most part, you're using the PTA for a speaker. So if you're using it for a speaker, it's going to be half duplex.
He said thank you.
All right, so we'll begin. So the first part I'm going to go over is basically just an overall what you need to do to know what kind of equipment you're going to need for a system. So, and you could basically give these counts to Ken or Albert in our sales department, and they'll give you a list of equipment that you need. But the rest of this we'll kind of go over like how they come up with that list of equipment. But when you are doing a new system, you basically need to know which equipment rooms are you going to locate your equipment in. So these are the rooms that you're going to have some cabinets or racks or whatever it is that you're going to have. Sometimes it's, you can have these mounted on a wall on ears. But you're going to have some location where you're going to pull some wires to for some intercoms and some master stations. So you're going to want to basically know for each control room how many intercoms you're going to wire in it. You need to know the basic type. So if you've got some Harding intercoms with one pair of wires, and you got some Duquesne intercoms or some other intercoms with 25 volt, 2 pairs of wires, you need to know how many Harding intercoms are being wired to this room. How many standard intercoms are being wired to this room? How many paging circuits do you need in this room? How many master stations do you need in this room? What type master stations are they? TMM master stations that are IP based? Are they analog master stations? So you need to basically know a list of, in this equipment room, what are you bringing to this equipment room for wiring? What is connecting to this room? Do that for each room to get a counts list for each room. You can get that to Albert or Ken, and they'll get you an equipment list. So that's the basics of what you need to know. Each DCC or DCE in our system has 1 or 2 station cards. So 1 station card would mean 16 stations, 2 station cards would mean 32 stations. So each DCC or DCE building block has the same stations and masters capabilities on it. So really they're kind of treated one and the same for counts. So once you have the counts of how many 400 series stations you have, how many 300 series stations you have, how many IP stations you have, you would then use that to determine what kind of equipment you need. Each DCC or DCE has up to 32 intercoms. So to find out how many DCCs and DCEs you need,
you take the number of intercoms you have and divide it by 32. That's the number of boxes. I call them boxes. At minimum, you need one DCC. That's the basic building block. So if you have 32 intercoms or less, you're going to need just one DCC. If you have more than 32 intercoms, you're going to need additional expanders. So if you got 48 intercoms, you need 32 on the first DCC and an additional 16 on the second DCE. If you have more than that, then again, you're going to need additional DCE. So if you have 90 intercoms, you're going to need 32 on the first DCC, 32 on the first DCE, and an additional 90, 32, so that's 36, 30, 32, 64, 96. So you need a third one for the additional ones with 6 pairs. So how many boxes you need? If you have analog masters, which is not common nowadays, but if you are using analog masters, each master card, if you have one, can have 2 masters. The masters can be either, I didn't mention this earlier, I think we're going to mention this a little later, but masters can have 2 Harding masters that have the TMM 440, TMM 441 style masters. We have an option on MasterCard, so you hook up an analog telephone, standard touch-tone telephone, that can be part of our system. So a MasterCard can have 2 analog telephones, or a MasterCard can have 1 Harding master and 1 analog telephone master. So if you have any analog telephones, if you have any Harding masters, you add those up. There's a maximum of 2 per DCC or DCE, so you divide that by 2 to find out how many boxes you need to handle that have MasterCards on them. Now, if you have our IP masters, our IMS 641 masters, or the TMM 641 masters with the Ethernet ports on them, then you can have up to 13 of these per DCC. And that's just the amount of processing power that that the voice over IP network card has. You can handle 13 masters. It's actually handling the number of connections it can make, which is 39, which is 13 that can go outside, 13 that can handle the masters, and 13 that can come inside. So that's how we come up with 39, and that's how I come up with 13. It's just the amount of processing power the voice over IP card has enough to handle 39 VoIP streams in, which will break up into that amount. So up to 13 IP master stations per DCC. And since only a DCC has the Ethernet port and the processor card, that is per exchange, per DCC, since you can't have them on DCE. So that's 13 total, not 13 per box. So you can then determine how many DCCs and DCEs you need based on the number of stations and masters you have. Now, if it works out that you need more than 5 boxes, so a DCC and 4 expanders, if you need more than 5 total, then you need to, your 6th one will need to be another DCE, DCC, and then 7, 8, 9, 10 could be DCEs. So if you have more than 5 boxes, you need to add a DCC for each 5 units, including the DCC. So DCC plus 4 expanders is 1 unit, and then you have to add a DCC plus additional expanders.
Quick question, Darren, just to elaborate on that. If you had the 1 DCC and 4 expansions below it, could you still also add the PZEs on the end of those, or is that maxed out?
Yes. So the PZEs, page zone expanders, are basically relays. So they don't need a lot of USB processing power or a lot of USB bandwidth. So the PZEs are extra, but a TBE needs audio on that same USB. So a TBE counts as one of the 4. So if you cannot have 4 DCE expanders and a TBE expander, because that's the 5th. So a TBE is classified as a DCE as a count. So if you find that if you need 4 DCEs and a TBE, then that goes past that. So you'll need to change one of those DCEs out with a DCC. So I'll need a second exchange that handles the additional. Just because it's the USB connectivity, the audio across the USB, that's the limitation on DCEs and TBEs. There's a maximum of 4 of those audio expanders with audio that can go on one USB chain. So find how many TBEs you need. There's 8 channels per TBE, and then you add things up. Find out how many boxes you have total, so how many TBEs and DCEs. Divide that by 5 to find out how many, the DCC plus up to 4 expanders, and then if you have more than that, you need to add additional DCCs and the expanders on that one. And then you go over the data sheets. Once you find out what overall parts you need, you'll find out that, say, for example, you have 40 intercoms. So 40 intercoms is 32 on the DCC, and then you have 8 more that will go on a DCE. Well, that DCE, if you have only 40 intercoms, if you have 40 intercoms, that means you have 8 intercoms on that one. So you don't need to add 2 station cards on it. You only need 1 station card. So you can order that DCE with only 1 station card because you don't need the additional 16 ports. You're only using 8 anyways. So basically, once you find the overall parts list, what I need so many DCCs, so many DCCs. Now you can determine what you need to be inside those. If you have a voice over IP system, you need to make sure that when you order the DCCs, that it has the voice over IP card option. If you don't have if you're using analog masters, again, not often, make sure you have the correct master cards in them, whether it has the 2 Harding masters or the 2 telephone masters, or the combination card that has 1 Harding master and 1 telephone port. Determine what you need on your master cards. Determine if you have audio level alarm monitoring and you're using them on SEC 300 or SEC 400 cards. Make sure that the DCC or the DCE that those stations connect to have the additional digital signal processor. And our ordering option is called the enhanced processor card. Make sure the enhanced processor card is ordered if you need audio level alarms. That's not something that can be added on afterwards. So if you find out later on that you ordered one without the enhanced processor card and you need one, basically what that means that it's not an add-on card, it's not something you can pop onto the board. It's actually the processor card. It's the same board, but the processor is soldered onto the board. So if you find that you need audio level alarm after a system's been ordered, there's 2 ways of going about that. If you haven't used the units yet, you can send the original units back, and you order ones with the enhanced processor card. Depending upon whether they've been used or not, our sales may assess a restocking fee on those. So you can send those back and get ones with the processor card, or alternatively, particularly if it's a really old system and they want to enhance it by adding ALA, instead of having to buy a completely new DCC or a DCE, if you want the stations on a DCE, you can buy just the card and you can change the card out in the field. So that is possible. You can open the unit up. It's not hot swappable, so you have to take the unit out of the rack, open the lid, change the card out, and then pop it back in. So it's not a hot swappable. The system will be down when you do that. But you can do that. But again, then you'll need to purchase just the main board for it, and then the board that you took out, you set aside and use as a spare or whatever. So it is possible, but audio level alarm does need the soldered processor on it. If you have a talkback expander, speakers on a talkback expander, there is enough processing power on that to handle that automatically. You have IP stations, there is enough processing power on an IP station to handle the audio level alarm. It's only when you have stations on a SCC station port that you need to make sure you have the ALA option, the audio enhanced option for audio level alarm. For your station cards, determine what kind of stations you're going to put on it. So we separate things out into 300, which is 25 volt intercoms, 400, which is Harding intercoms, and 401, which is Harding intercoms with LEDs. So you kind of split them out. 401 station cards can have regular 400 series stations on them, so it can have LED stations and stations without LEDs, but it has to still be 400 series. You can't put a 25 volt intercom on a 401 card. So once you've determined what each DCC or DCE will contain, and you can know what the ordering information is for that particular head and equipment that you need. So now going into the wiring and planning, I kind of touched base on the initial wiring requirements this morning. So this is going to go a little bit extra details on that, but the basics, what we had this morning is that there's 3 main networks. The blue network is the Ethernet network connecting all of the exchanges together. So that's a standard Ethernet network with a RJ45 jack, goes to your network switches. So you get a regular Ethernet cable, you plug it into your local network switch on that, and really that's all you need to do. So if you have Ethernet experience for installing Ethernet, it's a standard Ethernet jack. For most systems, that's all you'll need. Well, for the inter-system exchanges that you have capability of. So you have Ethernet on your blue network. For a modern system, that handles both the control information between exchanges. So you get a call request on a station in one building, calling into a master in another building. It's going to use that Ethernet network between the station's DCC and the master's DCC to transfer that information that, hey, this call button is pressed, it goes into the central control master. So that exchange network will be used for data. It'll also be used, if you have a voice over IP system, it'll also be used for the audio. So once the master station sees that call request, the person at that station presses their answer button or they presses their touchscreen to make a call connection. The data network and through Ethernet would send the control messages to make the appropriate connections. And then once the appropriate connections are made, the audio streams will also be sent through that Ethernet network on a VoIP system. So that Ethernet network is used both for data, for inter-system communication, as well as the actual audio connection as well. If you have a touchscreen system or a PLC that's controlling the intercom system through what we call a host port, that can also be going through that same Ethernet network. So your commands from your touchscreen to make a connection will go through that Ethernet network into the DXL system. It'll make the connection. The DXL system will send internal messages to make the connection, and it'll send us the audio data streams through Ethernet. So all of that could be through the same Ethernet port, the same Ethernet cable, your same Ethernet network. You could, if you have an older system, you don't necessarily have to control our system through Ethernet, although that's probably that's by far the most common. We do have serial ports in the back of the DCCs as well. So you could send those commands through a serial port. Not used very often anymore, but it still is a possibility. So that's the blue network. So you're going to need that for sure on any system. If you have an older DXL system, again, you're probably not going to experience that. But if you have an older DXL system that's using the digital audio trunk, the T1 lines instead of the Ethernet, you're going to have the green network connecting all the systems together in a loop. And that's, the data will still transfer across Ethernet, but the audio will go in a digital telephone format across this green loop. So that's what the green loop is on this. And then, so that's the green, that's the blue. And then between the DCC and the DCEs or talkback expanders or page zone expanders, all of the expanders connected to a DCC use a standard USB cable. So with each expander we sell, we'll provide you with a USB cable, about a 10-foot cable. USB is only good for about 15 feet. So you could buy a third-party USB cable, and you can use that if you need something a little bit longer. But the USB network isn't spec'd to go out any further than 15 feet. So we don't, you can, there is something called an active USB extension cable. So it's basically a USB cable with a little hub. So you could have an active extension cable. You can have 3 active extension cables. You have 5 meters on the original cable, 15 feet on the original cable, 15 feet on the first expansion cable, and 15 feet on the third expansion cable. So you can have 45 feet if you got 3 cables chained together. That's the most you can go. So if you do have well, we certainly recommend the DCC. If you stack the DCC and DCEs with it, you're always going to have the cable in wet for it. But in some circumstances, you might have the DCE in one rack, DCC in one rack, and maybe a DCE in another rack in the same equipment room. You can, there's a, with it, if it's within that USB 3 chains of 15 feet, you could do it that way. But stacking them is a better solution. That means you can use any old USB cable, not an active one. We have had calls as there are USB over fiber and USB over Ethernet. There's some ways to extend USB over really long distances. We've tested them. They don't work with our system. The main reason is that the number of simultaneous connections, in technical terms, is isochronous communications links. Due to the number of simultaneous connections we have, all the ones we've tested don't work. So don't use a long-range USB extension. You can't. It probably won't work, and we can't guarantee it'll work. We can't guarantee it's going to. We can guarantee the ones that we've tested don't work. We can't guarantee that other ones work, and we can't support if you use one of those and it doesn't work, or it works fine for a while and it doesn't work. We can't. We know we've tested it. We can't guarantee that those will work. So our recommendation is these DCC and the DCEs have to be in the same equipment room. They have to use standard USB cables, or at best, at worst, a standard one USB active extension cable. But it can't be anything USB to fiber, USB to Ethernet. Doesn't work. All right. So that being said, so it's a standard USB A to USB B, not micro B. It's a standard full-size USB B. So it's a rectangular connection that you see on a PC to a square connection, what you would see on a printer. So it's a standard. Specifically, we use USB 2. So it's a USB 2 connection, an A to B. So you can go to any computer store, you can buy a USB printer cable, and if you need a replacement, that something happens to the cables that we supply, or if you need a shorter cable or you need a longer cable, you can buy a standard USB A to B cable. Going into those networks in more detail. If you have a voice over IP system, you'll have a voice over IP card installed, and you're going to be using the Ethernet port built into the DCC for your communication, for your audio trunking. This is only available on DXL, so DXI does not have a VoIP option. If you are using VoIP, VoIP, all DCCs must have that card, and the system will use that entirely. So if you do a retrofit, you have an existing system that used our old audio trunk system, and you wanted to convert it to using Ethernet, you can, but you have to have, every DCC has to have that card in it. And once you do that, the system will use Ethernet for the audio trunking. So if you do upgrade an existing system with a VoIP card, you can disconnect and abandon all of your existing fiber link or wired link for your audio trunk, because now we'll be using Ethernet. Our network is our DCC provides a regular RJ45 connection. Specifically, we have a 100 megabit controller. Newer ones actually have a gigabit controller, but we're only using that 100 megabit speed. So it's a 100 megabit network port, standard RJ45, Cat5, 5E6. You don't need anything special because it is only 100 megabit, so you don't need to have any Cat7 or 6 or special cable, special network transceivers. It's just standard Cat5 or RJ45. Being a regular Ethernet cable, it does have regular Ethernet cable limitation. So standard Ethernet is technically 100 meters of distance of cable from the network port to your switch port. So typically, if you have a longer distance, you would probably have, you would go to your local switch. You may have some long distance backbone between your switches, but that's part of your network. We don't provide the long distance backbones. We just provide an RJ45 port with a 100 megabit network cable. And if you need longer runs, you need backbones, that's something that's the network equivalent that you provide. Standard Ethernet, so it plugs into your network switch. Your network switches, if you've got multiple, will have some sort of backbone link between them. And however you plan your network, your network switches can be connected, and you can have a redundant backbone links. You can have whatever your network gear can do. Is the system just plugs into a port on your switch, and your switch does however routing you want. Typically, it's more of a star orientation. You have a network switch. There's a kind of a central location. All of the devices in that equipment room will plug into that network switch. You might have a network switch in another location, and they will communicate together through a backbone link. Because the Ethernet networks are point-to-point in general, if a particular DCC is not operating, powered down, faulted, or whatever, what that means is that obviously you're not going to be able to communicate to devices on that DCC, but that doesn't affect the operation of the rest of the system. So even if one DCC or powered equipment room is down, all the communications between any other equipment rooms will still operate and still go through your network switch and to the room, unless that room, the power for that room also has the power for your central network switch, and of course that's not going to work. But in general, one missing device or missing DCC is not going to affect the rest of the system with an Ethernet network. In boldface is only applies to really old systems that haven't had their software updated. Now I know there's I don't think it applies anymore. No, it doesn't apply to any systems you have. The original Blue Cross system, for the people from Blue Cross attending, had really old software that this would have made a difference, but there was an expansion done to it which had newer software. So if you have really old software, then it had a limitation in that the first DCC would be handling all the allocation. And if the first DCC went down, then you couldn't communicate to multiple DCCs. But that doesn't apply anymore to any current or even reasonably old software. So really, it's only really old operating software that the first DCC being down would make an effect. It doesn't affect anything on modern systems. So that's the Ethernet for voice over IP. Some older systems use the LawnWorks network, which is a network mainly for building control. What's very important for DXI, because that was the control network for DXI. So if you got an existing DXI system, you're going to have a control network, a LawnWorks control network between the SAC control computers and the card cages doing the switching. On a DXL system, it only applies for IMS 440 master stations, these big gold clunky ones. or DIO cards. So those would need some kind of network to control them outside of the USB network because those weren't USB devices. The OneWorks network we use is called free topology, so it's a single pair of wires. It's a basically much like if you're familiar with the serial networking RS-485. It's similar in at least electrical characteristics. But if you've got an IMS 440 master or a DIO card, you might be using that. You're not on any modern system, but just for curiosity's sake. I find my experience with DXI is that's the most critical network on a DXI system, and that's the most particular about the cable type it has. So OneWorks is a data network sending data to multiple systems through a chain of cable. It could be a chain cable, so it could not just a single point to point, but it's a chain. It actually could be the name is free topology. It means that it could be daisy chained together. It could be in a star network. So they can be wired up however you want, as long as all points connect to the control unit. But I find that the wire is very specific. If you've got the wrong kind of wire, if it's a short distance, it'll probably work, but you'll see occasional retransmissions. But in an operation standpoint, you probably won't notice anything. As the system gets more complicated and the wiring gets longer, you'll find more and more problems if you don't have the exact correct wiring. So it needs to have the right wiring for it. And it needs to have, due to how the free topology works, it needs to have a termination resistor on it, somewhere on the network. We normally recommend on wherever the control card is, the alarmers card on your, in the case of DXL, will be on the DCC. You'd have a resistor across the wire pair, and that's basically to deaden the signal. So if anything goes to the end of your network and comes back in, once it hits that, it basically deadens that signal. So you don't have a lot of reflections happening that's causing a distorted data signal. So it needs to have a 51 ohm termination resistor. It needs to be the right kind of cable for it to be reliable. And a OneWorks network has two distance limitations: is how much cable you have entirely on the network, and the second limitation is how much cable between any 2 points. What's the longest one cable between two points? And in a modern system, you're not going to need it unless you've got an IMS 440 or a DIO, which is basically only going to happen if you are working on an older system that was installed before voice over IP was popular. So there are particular cable types. So there's a couple of Belden types. They're basically special order. So it's hard to get the right kind of cable for OneWorks. West Penn is another cheaper cable that can do that. And the recommendation is a 22 gauge cable or thicker. That's a OneWorks rated. And that's good for about 1,600 feet of total cable length. Add up all of the cable in one network, about 1,600 feet, or specifically 500 meters. And between any 2 points, the maximum cable length should be 400 meters, or about 1,300 feet. Now, a very common cable that is perfectly acceptable for OneWorks is Cat5 5E6. So that is a data grade cable, good for really high speeds. And that is, as a data grade cable, that's also good for OneWorks. The only problem with the Cat5 5E6 cable is that they're typically a 24 gauge cable. So they're a thinner cable than the 22 gauge, which means that your distance is reduced somewhat. So your distance is about 1,500 feet of total length if you're using a 24 gauge cable. And between any 2 points, you have about 820 feet, or 250 meters. So there is a limitation on, because you're using a thinner cable, you have more losses on that cable. But that's a very common cable used. You'll only be using one pair out of those 4 pairs in that cable. So it's kind of a bit of a waste of cable, and it's a thicker cable, but it's very easy to get. You can get it off the shelf anywhere, as opposed to special ordering for a OneWorks type cable. If you need more than this, if you need more cable length, or you need a longer, particularly if you're using a Cat5 cable and you need more node-to-node length, we have what we call an FTR, free topology repeater, which basically is divides your network into 4 independent networks. And they're connected to anything received on one port will be retransmitted on the other 3 ports. So basically, it makes your network up to 4 times longer. And so you can add those free topology repeaters to the network to increase your distance. So if you need more than the 1,600 feet of distance on a 22 gauge cable, you can add a repeater. You divide it into 4 1,600 feet segments. There's also LonWorks to fiber optic and LonWorks to Ethernet connectors, converters available. So you can use those. So you can use a fiber optic network, particularly if you have a large spread out facility. You can have a fiber optic, a free topology to fiber optic converter in each building. And then between buildings, you have a fiber network. So that's also possible. And there's also LonWorks to Ethernet. So you can use an Ethernet network and transmit LonWorks across Ethernet. However, this is not used very often anymore. Most people use the voice over IP system. Also not used much anymore was the digital audio trunk, which is the telephone style digital telephone networking. So our system was designed in the digital telephone age, or DXI system in particular, in our first DXL systems. We'll use a variation. So you've probably heard of, if you're an old timer, you might have heard of, oh yeah, my Ethernet, my works Ethernet is really great. I got a T1 connection at work, which is actually really slow compared to nowadays. But so that's a digital telephone network that a T1 network can handle up to 24 telephone calls on a single wire pair. So it basically divides up the time, and every telephone call gets a little digital segment of that time. And you have 24 telephone calls on one pair of wires going back to the telephone company. And the network is a digital network, so you get 24 phone calls of data on a single network pair. We actually use the European version of that, which has what's called E1, which has 32 communication paths. It's actually 30 communication paths plus 2 data segments. So up to 30 calls simultaneously on one pair of wires or one fiber. So what we're using is called the E1 standard. So it's based on the European standard. It has 30 call paths rather than the 24 call paths. And particularly in the case of our DXI system, some of our engineering documentation for DXL still refers to that. I tried to revise all our documentation that says this is a digital audio trunk, but some of our old engineering documents kind of got through, and our engineers call this a CEP network, which is not really the correct naming for it. So CEPT is actually the European committee who designed the E1 telephone network. And so if you look on that, it's my French is getting worse and worse, but it's translating this French into English is the European Conference of Postal and Telecommunications Administration. So it's the European body that developed the E1 standard, and we call it, so the organization is called CEPT, and that's what our engineers call this network. And really, we should have called it an E1 network, not a CEPT network, because it's like calling a network an ISO network. Well, ISO is the organization, but they have a whole bunch of standards underneath it. So that's what, whenever we say CEPT, we're talking about the digital audio trunk on an analog or on a non-VoIP system. So if you're using one of those systems, the audio trunk will be organized in a loop going from between all of the DCCs on the system. So going back to this drawing here,
So that's this green line connecting DCC1 to DCC2, DCC2 to DCC3, all the way through until finally you get back to the last DCC, DCC3, back through to DCC1. So it goes in a loop to make sure that the network, the audio can get to every system on that network. The audio trunk network is not nearly as finicky as the Lonworks network. So while there is a specific standard that you should use for that cable, it doesn't matter as much as the Lonworks cable. So if you do have this, there is a dedicated cable for this. So we're based on the, we're a North American. So if you get a North American T1 grade data cable, that's the correct cable to use for an audio trunk network. So those cables are typically a 22 gauge cable. They're good for 8,200 feet or 2,500 meters. So they're normally meant to go between telecommunications offices or at least utility closets or whatever. So they're a long distance network. So they're good for 8,200 feet, and that's between each segment. So I get 8,200 feet between 1 and 2, and 8,200 feet between 2 and 3, because it's a dedicated point to put 8,200 feet between 3 and 1. Our ubiquitous Cat5, 5E, 6A cable can also be used, but that is also a 24 gauge cable as a close to 22. So you do have a reduced length. So it goes down to about 5,700 feet as opposed to 8,200 feet. So that's perfectly usable. The digital networks, both the Lonworks network and the audio trunk network, the plus and minus don't matter. There is the ports have a designated plus and a designated minus, but if you flip them around, it does not matter. We also have a fiber option for this, so you can have a fiber optic connection. We'll have a fiber optic port on the back instead of a DB connector, so you can order it with that. But the system has to be all fiber or all wired. You can't have some parts of it wired and some parts with fiber. So if you need some fiber segments, you'll need to have all fiber segments. If you're using a wired network, we'll normally recommend that you buy a cable from us, which would be a short cable that has a DB connection on one side, and individual wires that you punch down on some kind of punch down block on the other side. That cable is called a cable-ATN or audio trunk network cable. If you use fiber optic, our system uses multimode fiber optic with a 62.5 micron core. And the connectors on our system are ST connectors, but if your terminal blocks or if your patch panels are different, you can get something with an ST connector on one end and whatever your connector is on the other end. But our end is going to be an ST connector. We cannot do single mode fibers, so single mode fibers will not work, or they will not work well. Our system is designed for multi-mode. Our transmitters and receivers are for multi-mode. So if you request you need to do single mode, unfortunately we don't use single mode, and it's not going to work well with single mode. The fiber optic will every time you have a connection, you're going to lose a little bit of light. So fiber optic has the length is based on your fiber and how well your connections are done. Our spec for how long it is based on decibels of loss allowable. So every connection will have a loss, and the length of cable you use is also going to be a loss. So you have to calculate based on the cable you're using and how good your connections are, what kind of tools you're using for connections. So field grade tools for connections are going to have more losses per connection than a lab grade tool. Now, as I mentioned, the audio trunk, if you're using it, again, mostly on older systems, will be a loop between all of the DCCs on your system. DCC1 to DCC2, DCC2 to DCC3, and then the last one back to the first one. A lot of facilities that are kind of more centralized don't necessarily have your cabling or your conduits running that way. So if I have, say, a central building and a bunch of outbuildings, so this is kind of a stylized example. So I got my network going between 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, and 6 back to 1. If you have conduits running between all the buildings, then you're free to use that, that's fine. But a lot of cases, particularly in a centralized location, you don't have conduits running from building 2 to 3 and 3 to 4. You have conduits from 1 to 2 and from 1 to 3 and from 1 to 4. So going to a central location, but you don't necessarily have them going between buildings directly. So to make up a loop, you can still use that kind of mechanism, but now you've got a little more convoluted path to go from 2 to 3. So all your wiring goes through a central closet near 1. If you're going from 1 to 2, okay, well that's fine. 1 goes to 2 directly. When you're going from 2 to 3, well, if your centralized patch panel is in 1, then you got to go from 2 to 1, and then from 1 to 3. From 3 to 4, 3 to 1, and then 1 to 4. So you can still organize the path in a loop, but it's a little more convoluted. Now, in many cases, when you have fiber cables or when you have wire cables, say for example using a Cat5, you're going to have multiple pairs in the same fiber pair or multiple pairs in the same cable pair. So that's fine. You can use 2 pairs in the same Cat5 cable to and from unit 2, to and from unit 3. So you can use multiple pairs in the same cable for that. This is a data cable. This is data going through. But just keep in mind that you have to have a path as a loop through the system. Now, of course, this will double your distance. So if the distance between 1 and 2 is, say, 100 feet, doing it this way is now you have, particularly from 2 to 3, so if it's 100 feet there, and it's 100 feet here, and it's 100 feet here, well, from 2 to 3 is 100 feet plus 100 feet, so that's 200 feet. So you are increasing your length because you got to go to central building and then to the remote building. But the audio trunk network has a very long distance limitation, so you're probably not going to experience that, not in a jail security facility. Even a large spread out jail is not going to have 8,200 feet. So that's the basic networks that you have on a DXL system. Almost always, the only real network you're going to worry about is your Ethernet network. And the rest, the USB network is just basically plugging cables in. And you're typically not going to have a LogWorks network, and you're not going to have an audio trunk network. As I mentioned late in the morning, I mentioned that you can typically our end devices, such as intercom stations, we have some kind of punch down block or screw terminal block to use to connect those up to. If you use our terminal blocks, we call them quick connect boards or QCV boards. That's what you see over here. Sometimes you may have maybe an existing system or maybe a new system that you're using. Maybe you're using reliable 66 terminal blocks or fixed terminal blocks. You can use whatever you want. We can sell you a cable that has a DB connector on one side and bare wires on the other side. You can punch it down on your own blocks. We can sell you a quick connect board, in which case you get a cable that has a DB connector on one side, a DB connector on the other side, and you simply plug it in and you screw your field devices into these. For the pinouts on that individual card and station section. Here's a bigger overview of the networks. Ethernet in blue is most important, connects to your Ethernet network. The orange network is the USB cables, and the green network is the audio trunk network, connecting all the exchanges together. Starting with the USB network. On the back of our DCCs, the control network, controller, there are 2 USB ports on the back of it. Now, I mentioned previously we can have up to 4 expanders plugged in. Well, there's only 2 ports. So how does that work? So the order of ports doesn't matter. So whether you plug into port 1 or port 2 doesn't matter. There's that unique identifier, the serial number of each DCE, that identifies what specific DCE that is. So that's part of the DCE programming that we do at the factory. So where you plug the ports in doesn't matter. The only matter you have is to make sure you don't have too many devices plugged in. So our recommendation is if you have a first expander, so I'm talking about DCE expanders and TBE expanders. From our point of view, they're treated the same. They have an audio component to them. So the recommendation, now again, the order doesn't matter, but the recommendation is your first expander, you plug into the first port of the DCC. That's this guy right here. The second expander, you plug into the second port of the DCC. Now both ports are full. If you need to add a third expander, where do you put it? Well, every expander has a square port, which is coming in from the DCC, and 2 additional ports going out to other DCEs or other expanders. So your third expander will go on the back of the first one. And the fourth expander will go on the back of the second one. Now, why we do this is because there's a limited, each of those USB ports on the DCC has its own separate controller, its own separate USB network. Due to, we're using only USB 2 and not USB 3. Due to using that USB 2, there's only a certain amount of network traffic that can go through each USB controller. And specifically with what the data we're sending, that maximum is, we can have a maximum of 2 expanders controlled by 1 USB port. After that, there's not enough remaining data to power to provide the data for a third DCE. So you can't, if you try to plug into, say, the back of this DCE right here, if you plug the fourth one, instead of plugging it in the back of the second one, where is my cursor? There. Instead of plugging your fourth expander in the back of the second one, if you plugged it into the back of this one, that would mean that there are 1, 2, 3 DCEs on the same USB port. That will be too much traffic that can go across the USB network. So the DCC will shut down the third one in the chain. So the third one in the chain will not be recognized. There's not enough data to send through USB to control that third one. So plugging a third one in, the third one will not work. The other 2 will, because there's still enough data, but the third one will not work. You'll get an error message when you configure it, and I'll talk about that tomorrow. But just as a note, you can't plug a third one in a chain. It won't work. Now, once you configure them, so if you configure them like this, you put the first one on the first port, and the second one on the second port, the third one plugs into the first one, and the fourth one plugs into the second one. So it'll allow you to do that, it'll work, you'll configure that way. Now, say for example, you set this up in your shop, and your service, your installation guys, okay, you set this up in a shop, you tested it, works just fine. Your guys in the shop, your guys at the installation, they take these devices, they take them to the site and they hook them up, but they accidentally plug, instead of plugging this fourth one into the back of the second one, they plug it into the back of the third one. Again, what you'll find is that that fourth one won't work. You'll get an error message on the screen indicating that that DCE is not recognized. And it's going to show a fault for that, and that fourth one won't work until you've reduced it down to 2 expanders with audio on any one DCC port. So this applies to DCEs, naturally, and talkback expanders or TBEs, which have speakers. This does not apply to page zone expanders or PZEs. So PZEs don't use an awful lot of data. So you can plug them in. I can plug a PZE in the back of DCE3. I can plug a PZE in the back of that PZE. So you have a lot less limitations on that.
And really the only limitation on that is you can't go more than 3 steps away from the DCC. So you can have 1 step, 2 steps, you can have an expander plugged in over here, but anything further than that won't work, just because of the amount of steps, and that's a USB limitation. So PBEs, I mean, PZEs can be plugged in willy-nilly. You don't have to, technically, our limitation is 9 per DCC port. And you have up 14 in total within the system, within a computer exchange, a DCC plus among TBEs, PZEs, DCEs. So our recommendation is to split things up logically. First one on the first port, second one on the second port, third one plugged into the first, fourth one plugged into the second. But the order doesn't matter. You could plug the expander number 1 in the back of expander number 3. Instead of expander 3 plugged in the back of expander 1. If you have 2 DCEs, you can plug the first one in the first port, in the top port of the DCC, and the second one on the DCC, on the DCE. So you don't have to plug them in any specific order, as long as you have no more than 2 on one chain. Standard USB cable. So we provide a roughly 10-foot cable with each DCE, TPE, PZE that we supply. It's a standard USB cable, so if something happens with it, if you want a shorter one, you want a longer one, just go to any computer store, any place that sells USB cables, get a USB printer cable, A to B, and that's all you need. USB standard has basically a limit on length, and that's 5 meters, or about 15, 16 feet. If you need to go longer than that, you can get a active USB cable, but like I said previously, a long-range USB extension cable won't work, is not supported, we can't guarantee it'll work. Ones we tested, guarantee not working. So in the back of the DCC, you'll have 2 USB A-type ports, the rectangles. On the back of any expander, you can have a incoming square USB B port, so we plug from the A port on the controller to a B port on the expander. The expander will have.
I have a quick question.
Okay.
On the PZE, you can mute yours. Can you unplug the speaker? On the PZEs, are they 12 PZEs additional to the 4 TBEs?
Yes.
Or
they are additional to the ports on the DCEs and TBEs. So that is in addition to the 4. Because you could have the 9 per port and 14 per system, or is it 12 per system?
Thank you.
It's a lot. I've never seen 12 on a system. But yes, it is in addition to the audio expanders. So it's a matter of just plugging in a cable between the DCC and the expanders. Ethernet for control, host port interfacing, and voice over IP is standard Ethernet. We provide a Cat5 connector. You plug it into your network switch, and you set up your network. If you got a larger network, you do all that. You go through whatever your network provider is, or your network equipment provider, or your IT services to provide you the network you need. You basically need a Ethernet port per DCC. And you need an Ethernet port per IP device. So if you've got a IMS 640 master or a TMM 640 master, you need to provide a network port per master. For master stations, you can use a PoE. So if you have a PoE port, that means it's a simple 1 cable connection. But for master stations, if you want, you can have a standard Ethernet port, and then you can have a wall adapter for the power. So it's up to you. For intercom stations, paging talkback adapters, devices that are normally located in the field, you'll probably need to provide a power over Ethernet switch to provide the power Ethernet to power the IP stations. Our devices, the different types of devices have, when you do a power over Ethernet, the power over Ethernet device will have it has a power limit based on what the power of the units are. So depending upon the devices, most of our intercoms are low power PoE devices. But things like, for example, our 5-watt paging amplifiers can provide 5 watts of output. So they need a higher power PoE. So the PoE devices are based on class as to how much power they'll draw. So our intercoms and masters, I can't recall specifically the class limits themselves, but basically our intercom stations and masters only need a small amount of power, and they can deal with a lower class PoE port. But our paging adapters, if you have a 5-watt paging adapter driving a 5-watt speaker, you're going to need, it's going to allocate itself as a higher class, and it'll use more power from your power Ethernet. So if you need to know what specific classes a particular device type is, so if you tell me what you've got, or I can give you a table as to these devices use class 1, these devices use class 2, and these devices use class 0, which is the highest power draw. At least on the standard, there's an extension to that. So in general, for your Ethernet network, you set up a regular standard Ethernet network, and if you want to power your devices from your Ethernet cable, you need to make sure you have a PoE or power over Ethernet network switch, at least that those devices are connected on. And the wiring is standard. We just basically plug an Ethernet cable into the DCC, your network switch, any Ethernet devices, IP masters, IP stations, you plug them into an available network port on your switch. And if it's a PoE device, make sure that port on your switch or your switch is a PoE, power over Ethernet compatible switch. We don't provide any network switches or network. We don't provide any network equipment other than we provide the port that hooks up the equipment. You need to have a fiber network. You need to make sure you have your appropriate transceivers, your appropriate backbone network within your system. Our IP systems use standardized protocols. So sometimes your IT staff may request additional information. You say I need to have 1 port per master station, 1 port per DCC. So they'll provide the appropriate network equipment, but they may ask you some further questions. I have a app note available on our website that has specific details. Under our app notes or VoIP basics handouts. So if your IT guys need specific details, they can refer to that. But in general, we use standardized protocols with the initial connection query through a protocol called SIP, Session Initiation Protocol. And the actual data streams themselves are going through a protocol called RTP, Real-Time Protocol. So those are standard internet protocols. So your IT staff can, if they don't know about them directly, they can certainly look it up as to what kind of effect it is on their system. As I mentioned previously, it's a very low data rate. So what we use is called it's the technical call. In technical terms, it's called a G711. Maybe also called PCM. So it's a fairly low bit rate. It's a 8 kilobits per second data stream, and then you add on some TCP overhead on it. So it's a very low data rate, and as I mentioned, it's about 80 kilobits a second, including all of the overhead on that. Oh, that's kind of way back. So it's a very low data rate. So you can have a lot of communication channels across the standard, even a 10 gigabit Ethernet, a 100 megabit or a gigabit Ethernet could basically be inconsequential. So we use RTP, real-time protocol, and your IT guys may need to know more information. So
this is a little bit of information, the VoIP handout, the VoIP basics data application kind of goes over in detail. So it's standardized protocol. So normally when you're talking from a master to a station, the master has continuous connection to its DCC. So it can directly control the master's keypad display on the features through that constant network connection. Whenever you connect to a IP, whenever you connect to an intercom, it will then establish a connection from wherever that DCC is to the intercom through your Ethernet network. And this is a little more complicated than it actually should be. It's actually used to be one direct connection between the master's DCC to the station's DCC through Ethernet. And that's going to be a standard network connection, again, using real-time protocol. So your IT guys can see it as a standard protocol going between the DCC and the station's DCC. Where things get complicated, where this drawing takes effect, is when you're making a page announcement. Instead of going to a single point, instead of a single intercom, page announcement can go to multiple speakers, maybe all speakers in the system. And if you got 1,000 speakers in your system, you don't want to open up 1,000 different Ethernet connections. So instead, the system does a connection in one of two ways. One mechanism is called a broadcast mechanism, so it's easy, but it's pretty stupid. So a broadcast connection basically takes that network data stream. So that's going to be the microphone audio from the master. And a broadcast connection sends that, your network switch will send that to every Ethernet device on that network switch. So all of the DCEs will get that, which is good. All of your IP stations will get that, which if they're part of the page, that's good. If they're not part of the page, it's excess traffic. All of your PCs will get that. They don't care about it. All of your PLCs will get that. They don't care about it. All of your network cameras are going to get that. All of your, every device on the network will get that data stream. It'll look at, oh, it's not for me, it's going to throw it away, but it still goes everywhere. So that's where it's dumb. And that, yes, it's simple to set up. You don't need to do anything to set it up. It's automatic. But it means that all those other devices that don't care and could actually slow them down will get this network traffic. They'll get it, they'll throw it away because it's not for it. So that's broadcast networking. Simple to set up, but there's another limitation as well as all the network going to everything. Is this will only go on the same network. So if you've got a structured network, so you have either VLANs or you got multiple subnets. So you got one building is on one subnet and another building is on another subnet, and you have your traffic router between them with your central switch. Broadcast traffic won't go between those different networks. So by definition, it's a local traffic. So broadcast traffic won't cross the network. So you make a page announcement, the other building won't get it if you have different subnets. So that's where the next type of mechanism for sending that traffic for a page announcement happens. This is a if you can set up, so it's in their configuration, you can set up to use either broadcast, which is default, or multicast. So multicast is way better in that when you set it up, is only the devices that are going to need it are going to ask your switch for that data stream. So when the DCCs all come up, part of the multicast is you're going to assign a special unique IP address specifically for this multicast address. It's a special address. It's not a normal IP address. And when your DCEs and your masters and stations and whatever else with an IP data stream, capability of IP data stream, when they start up, they're going to send your network switch a message that says, hey, I want to see any traffic that goes to this particular special multicast address. And so technically it's called a subscription. So you want to subscribe to traffic to that specific address.
Of course, none of your PCs, none of your PLCs, none of your cameras are going to do that. They're not going to subscribe to something they don't even know about. So on startup, everything subscribes to that address. Now, when the DXL system wants to make a page announcement, it makes a page announcement to that specific multicast address. Your router looks at that and says, oh, okay, that's that special multicast address I was told about before. It will only send that traffic to the devices that asked for it. So only the DCCs will get it. Your cameras won't get it, your computers won't get it, your PLCs won't get it. Doesn't bog the network up, only the devices that wanted it will get it. And the other advantage of that is that does cross your networks. So it will go between your subnets and it'll tell your devices on your other networks, it'll send that paging traffic across your networks. So that is good. The only thing is you have to set it up specifically. You have to pick an IP address. You have to make sure your routers support multicast. But that's a better way of doing things to make sure that your paging gets through and only the DCCs get it. So this is kind of some of the topics handled by that extra document. Is for the most part, it's plug and play. You don't normally need to do anything. Although it would be really good if you did assign multicast address and switch to multicast, just to reduce the amount of network traffic. But you can plug and play. But a lot of cases, we're seeing a lot more IT departments getting involved in larger facilities or even smaller facilities. They want to be in control of the network, and rightfully so. So this is the information that they'll need to be confident. This is the type of traffic that you're expecting to see. This is the amount of bandwidth that they're expecting to put on the network. These are the protocols that are used. So you can refer to them to this VoIP Basics app note that's going to be on our website if they have any questions about how to set up their network. The first part is sending a traffic to or calling an analog intercom, and this, if you're calling a IP intercom, is basically directly through the switch. I mentioned quality of service before. It's not really important because in most cases you're going to have a lot of extra bandwidth on your backbone network, and that's really where the only place for quality of service makes an effect. If you have your backbone network between equipment rooms is clogged up, quality of service, what it will do is you can assign the intercom system a higher priority service such that if the network is clogged up and you've got, say, a PC doing a Windows update, or you're updating your PLC software, or you're updating, something's happening, that's not really important. It doesn't matter whether it happens now or 1 second from now. Then the intercom traffic can be set for a higher priority. So if you've got a clogged network, you got an intercom packet coming out, you've got a file transfer packet coming out, it goes, okay, intercom goes first. And that's all quality of service does. And to set that up on our DCC front panels, there is a quality of service setting, QoS setting, which is basically telling your network switch, this is how important that this system's traffic will be. So you set it on our front panel. The most common audio high priority packet would be an expedited packet. So it's higher than a standard network packet, but it's not as high as say a network, an actual network switch configuration packet. So it's a high priority, not the highest priority, but you can set what priority you want. So you could set it to be the highest priority, but expedited generally will make it more important than any other standard network packet. So it'll come in through faster than, say, a file transfer. And really what all this does is it prevents breakup in case the network is clogged and you have a data stream. If you have a network clogged, again, you're probably not going to see it, but if you have a network that's totally full and you have intercom traffic, without quality of service, you might have broken up audio. So you'll have like a second of traffic and you have kind of quarter second of of space, and then the remainder of, like, so all you'll kind of have, quarter second breakups in your audio. So if you get that, that's probably because your network is too busy and it's not able to receive the time that the data packet in time. So you have a bit of space between portions of your audio. Very, very infrequently do you ever see this. That's in that same VoIP basics app note. The next network, again, this is not a network you'll often see. The digital audio trunk communicates the audio between exchanges. More specifically, it's a one-way network. It's a transmit from one exchange to receive on the next one in line, transmit on that exchange to the receive next in line, transmit to the next in line until you get to the end of the line and it goes from transmit there to receive on the first one, completing the loop. So it's a loop going from 1 to 2, 2 to 3, 3 to 4, etc., all the way last one to number 1. They must be formed in a complete loop. If you have a break in this one, unlike the Ethernet or voice over IP, if you've got a break in this network, you can no longer, if I've got a break right over here between 2 and 3, that means if I have a microphone on a master on 2, there is no way to get that to a speaker on intercom on 3. There's absolutely no way if this connection right here is broken. And as such, there's no way if you need to talk to a master on exchange 2 to something on exchange 1, because this link is broken. You can't send audio over here for it to go over here. So that means that basically if you got one break anywhere, that means you can't communicate outside your local area. A master on 2 can still talk to 2, but it can't talk to a station on 1 and can't talk to a station on 3. So a broken audio trunk loop means you have no communication outside your local system. So that's important. Each of these lines represents one strand of fiber to transmit to receive on the next one, or one pair of wired networks. So one pair out of a Cat5, for example, or one T1 pair. So one pair from here or one fiber to fiber. Each of these links provides 30 simultaneous communication paths. So there is technically a limit of 30 calls going between systems on a VoIP system or on a non-VoIP system. But you'll never really see that limitation. You're never going to have 30 communication paths outside your local area. And again, if you're using a voice over IP system, this doesn't apply. You're using Ethernet. You're using your Ethernet network for that. This only applies to older systems. Here's another variation of this. So you have a loop connecting 1 to 2, 2 to 3, 3 to 1, 3 to 4, and 4 back to 1. So that's this blue, dark blue light blue path. You're talking from a master on exchange 2 to a station on exchange 3. Gets switched to the audio trunk, goes through to the next one in line, goes to the next one in line until it gets to where the station is, gets sent to the station, and when you're listening, the reverse path happens. Keeps on going, goes to the next one in line. It's not where the master is, goes to the next one in line. Once it gets there, oops, then it goes to the master station. If this was a fiber network, each of these lines would represent just a single fiber strand between those buildings. If this was an audio trunk, if this was a wired network, each of these actually represents a pair. And what you would see in that case, if it goes fiber, you have an individual connector. There's 2 connectors on this exchange, there's 2 connectors on this exchange, no problem. If you're using a wired network, you would instead get this 9-pin connector that both the incoming receive and the outcoming transmit goes on. So you're going to use one pair for the receive and one pair for the transmit. So out of this 9-pin connectors, you're going to have 4 wires used. The receive pair, pin 1 and pin 6, and the transmit pair, which is pin 2 and pin 7 on that connector. And we use telephone, digital telephone terms for that. So telephone, telephone is a telephone wire pair. It is a tip and a ring. Tip being a plus and a ring being a minus. So This basically means that the transmit pair from say 2 to 3 will be using transmit tip 1, pin 2, and transmit ring 1. So plus and minus on the transmit, or pin 1, 2, and 7, goes to receive on the next one in line, which is 1 and 6. Receive tip, which is the plus, and receive ring, which is the minus. And the cable that we sell, the ATN cable, the transmit is going to be orange pair, and the receive is going to be the blue pair. And blue and white wire. You have a fiber network, you can have individual ST connectors for the fiber, a receive and a transmit. If you have a wired network, you have a single DB connector for that. The wired network has an 8,200 feet, 2,500 meter distance limitation, basically an auto limitation. And the fiber network has a 10 decibel allowable losses. So typical connectors, if you got a field grade connection, you lose about 0.3 decibels per connection you make. And typical cable has a 3.2 decibel per kilometer, so per 3,200 feet. So you add all that up, you want to have a maximum of 10 decibels of losses. So that is like, if you got 2 really good connections, so 0.6, then you can have about 3 kilometers worth of cable length. So generally, it's not a problem. Now, if you have 20 patch panels in between, well, that's going to be 20 times 0.3, so that's going to be 6 decibels out of your budget right there with all your connections. But still, you still have probably plenty even with that. Your LawnWorks network, as I mentioned, is only if you have IMS 440 masters or DIO cards. You're not going to see that. I don't want to spend an awful lot of time on that LawnWorks network, but cabling is important. So make sure you get LawnWorks rated cables. If you have a long distance, more than the 500 meter total length, then you can use a free topology repeater to extend it. Because they both use the same card slot, it's incompatible with a voice over IP system. So you're generally not going to see new systems with a LawnWorks network on it. If you do have one, in the option card slot will be a LawnWorks connector with a little orange connector on it, and that's where your LawnWorks network will connect up to. LawnWorks needs a termination resistor, so put a 51 ohm resistor that would go between these two, and then you have your wires going to your LawnWorks device, your masters, your DIO cards. Cat5 cable is a common cable you can use that's still available. Otherwise, you probably have a special order LawnWorks cable for if you're using a 22 gauge cable. If you're using Cat5, you have a 820 feet between any 2 points and about 1,500 feet system wide. So that's generally not a problem. And if you do have multiple masters using the same LawnWorks network, you would typically have a terminal block. And your masters would connect to a terminal block, and then you would loop through all you have one pair coming from that LawnWorks card to your terminal block. You would loop it through to each of the devices that need it, and it's basically paralleled all through. And then we have the end devices. So that's actually the most complicated part, is all your networking, and really the most complicated of the networking is Ethernet. So that's actually fairly simple. The rest of it is your end devices. So I mentioned we have our Harding intercoms, which are our 400 series, in which case there are 2 card slots in every DCC and every DCE. So they're configured the same as the same cards. You can actually take a card from a DCC and put it in a DCE, and it works just fine. So if you need to repair something, all the cards are the same. Or at least it used to be, but that's a topic for another day. They are all the same, but as components become unavailable, we had to constantly update, you know, what components go in cards that we sell. So very, very new cards need you basically just need new drivers. You need new operating software on a DCC to make sure it can handle all the different types of DCs on it. So if you take a new DCC or a new station card and you put it in an old DCC, it might not work until you update that DCC with the latest software so it understands the drivers for the new cards that we put in there. So that's really the only thing is that as components become unavailable, we have to use different components and different software to drive those components. So for the most part, everything is swappable, but take that in mind. All right, so on Harding intercoms, whether it's SEC 400 or SEC 401, each of the station cards will have one connector. So we'll have one connector which will go to one terminal block, which will connect to your 16 intercoms. So the bottom connector is the first 16 intercoms, and the top connector is the second 16 intercoms. If you have, so that's because our Harding stations or 400 series stations only need one pair of wires per station. So you only need one connector for that one pair of wires per station. If you're using Duquesne intercoms or other 25 volt intercoms that have a separate speaker connection and a separate switch connection, that's where the two connectors come into play. The speakers will connect to the big connector, just like our 400 series. So there'll be some kind of terminal block connected to this connector, and that's where all your speakers will connect to. And your switches will connect to a second terminal block, which in turn connects to this second connector. So 300 series station cards will have two connectors, one for the speakers and one for the switches. So our recommendation, if you're pulling new intercom wires, is for our 400 series intercoms, we recommend a 22 gauge shielded twisted pair intercom cable for each intercom. So the shield prevents interference from nearby wires, whether they're AC wires or other intercoms in the same conduit. The 22 gauge makes it thick enough to go 2,500 feet. You could use a thinner cable, but there's a couple problems with, well, there's a couple problems with thinner and with thicker cables. First problem, I'm going to show on the bottom camera. So our stations have what we call a mass termination amp or MTA cable. So this allows you to easily connect up your field wire without having to use solder or wire strippers, as you basically have a little punch down tool, and I'll probably show that tomorrow, that you basically load the connector into the punch down tool, you put your wire in and you just press the pistol grip and it crimps it down, puts it in there, no stripping, no no soldering required. But these connectors are only rated for 20 to 22 gauge wires. That's the only wires that will reliably fit in these connectors. Now, there is a separate version of this connector for a 24 gauge. So if you do use 24 gauge wire and you need to use it, you do have a distance limitation, as you get about half of this 2,500 feet, which is still probably not a problem, but you need to make sure to get the cable, the connector for a 24 gauge cable. The other reason being is that there's a little knife edge. Now, you're definitely not going to see it on there, but the way that this works is there's a little knife edge on that connector, and it is wide enough for a 22 gauge wire that it will connect the edges of the wire securely and not cut it off entirely. Well, the hole in here isn't wide enough, or is too wide. If you put a 24 gauge cable in there, it's not going to contact the edges securely. So you won't have a very good connection if you have the wrong wire gauge on it. And likewise, anything bigger than the 20 gauge wire is just not going to fit in this connector, and they don't make them any wider than a 20 gauge. So if you have a 16 gauge intercom wire, it won't fit in this connector. So there is a recommendation. If you use our 22 gauge, you're not going to have any problems. But if you use something else, keep that in mind. Particularly if you're using Harding 400 series intercoms, which need to use this connector on. Now, if you're using 300 series intercoms that just use a speaker and a transformer, then if you're using someone else's, they're not going to have this mass termination amp or MTA connector. So that's not an issue. And then basically the only issue is whether or not it'll work in your terminal block. If you're using our quick connect boards, they have a screw terminal, so that's not a problem. If you're using a fixed block, that's not a problem. If you're using a reliable 66 block, that's not a problem. If you're using a fixed block, it has the same kind of limitation as our MTA connectors. The fixed block is designed to punch down a 24 gauge wires. 22 gauge at worst case. So
can we just use like that lead you got there and say we did use a 16 gauge, just wire nut it right to it?
That's right. So that's if you have to have, if your field wiring is a heavy gauge wire and you're using our intercoms, then what you'd have to do is you kind of get a little pigtail that has a 22 gauge wire. You use that to the MTA connector, and then you have a pigtail and you strip it, and then you use a wire nut to go to the field wire. So yes, that is the solution if you have to use existing heavy gauge wire using our MTA termination connectors. But if you use the 22 gauge, then you don't have to worry about that. So if you're pulling new wire, we definitely recommend 22 gauge shielded twisted pair. The shielded prevents interference. If you have a 300 series, so we have a separate speaker and microphone, so you have a separate speaker and a separate switch. You need one pair of, well, we recommend one pair of 22 gauge shielded twisted pair. So that's the same as the 400 series. And you need an additional pair for the switch. So it doesn't need to be shielded, that additional pair, and it doesn't need to be twisted. Now, when you got an existing facility, you're going to have cable as pulled. So the best thing is if the cable as pulled is it has a 22 gauge shielded twisted and a 22 gauge pair, then you have no problem. But some cases you might have a situation where you have a 3-wire cable with a shield. So that will be fine. You would use 2 wires for the audio, 1 wire for the switch, and the shield would be the switch component. So that's doable. If you have a so something like that, like a 3-wire cable will work. If you have an unshielded cable, so for example, you're putting a 400 series station in, and the existing cabling doesn't have a shield on it. The shield is there to protect the wire, to reduce the amount of interference from outside wiring, crosstalk from nearby wiring. If they are not having an audio issue as it is, so they're not replacing it because the audio sounds bad and they've got, they have stuff in the background. So if they're not having existing audio problems, then using the existing pair with no shield is not going to sound any worse than it is. So it'll work, but it might not sound any better than it is either. If the problem is because of the lack of shield, you're not going to improve. You'll improve quality because of the separate microphone pair, microphone amplifier. But we can't guarantee it'll improve it. So lack of a shield in existing wiring isn't going to prevent you from using it, but keep in mind that it might not sound any better than it is right now either. Definitely if you're pulling new wire, pull shielded wire. But if there's no shield as it is, we're not going to say, oh, we can't use it. If it sounded fine before, it'll sound fine after.
the following slide, so normally you're going to use what we call our quick connect boards. And that looks like this. So normally we're going to provide you a cable, plugs the cable, one end will plug into this connector, the other end will plug into the station card, and then you're going to end up with a 16 sets of 3 terminals, a plus, a minus, and a shield, and you simply hook things up. That's all you need to do. If you're not using our cables, if you're not using our terminal blocks, the cables that we provide that will go to an existing terminal block has 16 pairs of wires to it, 16 individual shields. So it's actually, it does, I'm talking with these on. So we'll provide you a cable that has 16 pairs of wires with a shield on it. So you'll basically go, the recommended pin on it would be like for channel 1, plus minus shield, channel 2, plus minus shield, channel 3, all the way to plus minus and shield for channel 16. So normally that's not a problem on there. Now, one of the things is that our standard cable wire colors are not, you don't have, so there's 16 pairs. So there's not really 16 discrete colors that you can see with your eye. You can't have like a red and a black and a green and a black and a blue and a black and an orange and a black and a purple and a black and a slightly lighter purple and a black and a slightly lighter red and a black. It's very hard to discern that. So instead,
Is it just me, or is it everybody? You're coming through a little gargled now, or is it just me?
I think it's everyone. I think the voice is stuttering. Yeah.
All right.
Yep. Yeah, our quality of service is poor on our end too.
Just started.
See, I'm kind of direct wired network connection. Am I still bad?
Yeah, you're coming through gargled.
Yeah, we're still having a hard time.
It's your internet connection.
Okay, I'll try this. I will be disconnecting from the session, but I need to try a different network port. Oh, okay, we'll try it from Wi-Fi. I'll try this.
I'm guessing it's just a mic glitch.
I think it's mic, not network.
Yeah, because the videos and all, everything is fine. It's just your sound.
All right. I will switch microphones to a different camera. I was thinking it'd be Ethernet, but maybe that is the case. Okay, I've switched microphones. Does this sound any better?
Yeah, there we go.
Yep, very good.
Yep, much better.
All right. Oh, I was thinking it was network, so that's good. All right. So if you're using your own terminal box, we're going to have 16 pairs of plus minus shield, plus minus shield, plus minus shield. Because of the standardized wire colors used, black isn't always going to be the minus. And in fact, there'll be cases where black is definitely not the minus. So there's only certain colors that are individually discernible from the eye. So like the first wire pair, the first pair is going to be a black and red pair. And then the second wire pair is going to be a black and white pair. And it's going to go black and green.
and ultimately it's going to run out of colors. It's going to be black and something else, and then it's going to run out of black, and then it's going to be red and black, white, red and green, red and blue. So black isn't necessarily minus, and red isn't necessarily plus. So you have to make note of the color code on the cable document that's going to be part of the DCC DCE installation manual. And in particular case, the first wire pair automatically does opposite of what you expect. It's going to be plus minus shield, plus minus shield. So it's going to be black as the pair 1 plus, red as the pair 1 minus, and then it goes to shield. Black is the pair 2 plus, white is the pair 2 minus, and then the shield. So don't look at black being plus, minus and red being plus. You have to look at the wire pairs. And on a 400 series station, the polarity does matter. So you can't reverse the wires around, and it will not work if they're reversed. So the polarity does matter, at least for 400 series intercoms. For a 25 volt speaker transformer intercom, the polarity doesn't matter, but it's still good to have them in phase. If you've got a couple of speakers in a page zone and one has the plus is connected to one side of the speaker and the other one's connected to plus on the other side of the speaker is going to be out of phase. When you're talking to them, it puts a pressure on the air beneath it to cause the sound. So if you've got two speakers in a hallway that are the same phase, when you are talking, it's pushing both down and pulling both up. So your sound is going to be synchronized between the two. If the speakers are out of phase and you're making a page announcement, one goes down when the other goes up. So you're, instead of compressing the sound below it, you're kind of pushing it around. So it sounds funny. You'll still hear sound, but it'll sound a bit funny. And if you're standing directly between them, you might actually hear no sound at all, because now one side is pushing, the other side's pulling. It just, the air in between isn't really doing anything. So it's good to have them in phase just when you're doing multiple speakers in the same page zone, but it's good to be consistent. So if you can be consistent on 300 series, it's good. The polarity doesn't matter per se, but on 400 series, it definitely does matter. And then on your field side of your terminal blocks, you can have your channel, your speaker 1 plus minus and shield connecting to the 1 plus minus and shield on the head end side. So for terminal blocks, that's if you're using your own terminal blocks, you can do that, no problem. Where it goes a little funny is if you have, again, if you're using our quick connect ports, not a problem. They have all of the wiring is done for you. All you need to do is put your field wiring on. Where it goes into a bit of a problem, so 300 series is the same thing, but polarity doesn't matter. Where things do matter, it's not my usual connection. Is you're going to have two terminal blocks, one for the speakers and one for all of your switches. And what is not shown here is the minuses are all common. So ultimately, they're all going to the system they're all going to the system ground. But to save on the cable, our just double check on that. One second here. All right, just looking it up here now. Yeah, it's not. I wonder if I can show that to you. Nope, not in this model. Change my screen here. All right, so the switch, if this only applies if you're using your own cable. And our engineers, to save cost, made things a little more complicated for you if you are not using our quick connect board. Is our switch cable has 16 pairs of wires. Actually, it doesn't have 16 pairs of wires. It has 16 wires and a handful of grounds. No, actually, I'm also confusing with DXL. Okay, so a switch cable has, actually will have 16 pairs of wires. The first switch will be red and black, white and black, green and black, blue and black, yellow and black, brown and black, ending up with green, white and green, blue and green, yellow and green. So just make sure that you have your pair of wires terminating on your terminal block. I'm confused with DXI, which the do-it-yourself cables on DXI were a little more complicated because we didn't provide you with a separate shield or a ground pin for each switch. We instead provided you with 16 intercom switch pairs, and then we had like 6 commons that you had to go and loop together on your terminal block to connect all the grounds, all the commons together. But you don't have to do that with DXL. So I'm a little confused today, but we should be good.
You're not the only one that's confused.
All right, how do I start this again? There. All right. So yeah, so you'll have 2 terminal blocks. One to have all the switches on and one to have all the audio on. The 300 series, the polarity doesn't matter so much, but keeping them consistent to be in phase is nice, but not required. The switches are a simple switch, so the plus and minus on them also doesn't matter. So the polarity doesn't matter, but it's good to be consistent. If you have any analog masters on our system, they're going to connect to the top part of the back of the case. Will have this section for the master connections. So the station connections will have the right hand, the back, actually the back left hand side will be these 2 station connectors. On the top right hand side, when looking from the front, we'll have this master connection, this master port. Your master stations will connect to this 15-pin connector right here. If you have any line level inputs, they'll connect to these RCA jacks over here. Same thing you hook up to like a stereo or a tape deck or a CD player. And any outputs, go line level outputs on a MasterCard. You have 2 line level outputs, will connect to these 2 connectors right here. And then we have a depluggable terminal block for 4 pairs, so 4 switch inputs. 1 and 2 switch 1, 3 and 4 switch 2, 3 and 4, so 1 pair, 2 pair, 3 pair, 4 pair. And the bottom is for 4 relay outputs. So the inputs can be used for additional switches, such as maybe call switches, a trigger to make a page announcement on a receptionist microphone on a desk. And the bottom 4 are relay outputs that can be used for things like lights, possibly paging or other controls that you need a relay for. What we're talking about here is the master connector, which is a 15-pin connector. You're not going to use all of the pins, but depending upon what kind of masters this MasterCard is, you're going to use some of those for the master connection. So there are 3 options for MasterCard. So you can have a MasterCard that has 2 Harding masters that could hook up TMM 441 masters, for example. You can have 2 telephone masters to hook up to an analog telephone, touch tone telephone. Or you might have a MasterCard that has 1 master station and 1 telephone station. The options labeled Master 1 are going to be for port 1, and the options labeled for Master 2 is going to be for port 2. So if you have 2 masters, a master station needs 2 pairs of wires to it, a speaker pair and a microphone pair. They're treated, and their amplifiers are much like a 400 series station, so the plus and minus do matter. And so when you can hook up a TMM 441 master to a MasterCard, the first TMM master is going to hook up to Master 1 microphone plus, Master 1 microphone minus, pin 1 and pin 9, and Master 1 speaker plus and Master 1 speaker minus, pin 11 and pin 4. You're going to have a ground, so the ground will go to the ground, so the microphone will go to the microphone ground here, and the speaker will go to the speaker ground here. Your Master 2, if you have a Harding master, will go to Master 2 speaker plus and Master 2 speaker minus, Master 2 microphone plus and Master 2 microphone minus, and the shields. So this shield here can be common. So all the shields are connected to the same place, so you don't really, doesn't matter which one you connect to. But there's this handy common one in between the Master 1 and Master 2, which you can use for the speaker pair, but they don't have to.
Darren, on that real quick. So for that DB15 connector, it could go to 2 intercom masters or 2 telephone masters,
Correct.
which would be the 2 DB9s on the other end.
No, just 1 DB9.
Just
So
1 DB9.
Sorry, so there's no. Okay, so the master connection itself is a 50-pin connector. So you have these pins on this side for Master 1 and these pins on that side for Master 2. Now, ultimately, that's going to go to some kind of field wiring. You're going to have 2 pairs of, say, intercom cabling going from the master connector here to your actual master station. And on that will be a DB9. So you will wire the DB9 on that according to the master pinout with the Master 1 speaker plus and minus going to the speaker plus minus on the DB9, and the master microphone minus plus and minus going to the microphone plus and minus on that. So that'll be a DB9 that you would wire per master. So the first master's DB9 will master to DB15 here will wire up to microphone plus, microphone minus on one, speaker plus, speaker minus on one, goes to your 2 pairs of field wiring, and will go to your master station DB9, speaker plus and minus, and microphone plus and minus. So the pinouts for that is actually going to show later in the master section, but this is what you see on the head end side. So yes, it will connect to 2 separate DB9s ultimately with 2 separate field cables to your masters. So that's if you're using TMM masters, you're going to use the speaker plus and minus for that particular master. Master 1 plus, Master 1 mic plus and minus, Master 1 speaker plus and minus is the second pair. Master 2 plus and minus, speaker plus minus, Master 2 mic plus and minus. If you have a 2 telephone master card, you're going to totally disregard the speaker and microphone pairs. Instead, you're going to use the tip and ring pairs. So the first telephone will go to Master 1 tip, which is the plus, and Master 1 ring, which is the minus. Your second telephone will go to Master 2 tip and Master 2 ring. Telephone cables don't normally have a shield, so you don't need to connect them to a shield. The plus and minus, again, they don't matter on a telephone, but it's good to be consistent. So the tip is the plus, the ring is the minus, and you would connect it to the tip on the telephone RJ connector. Now, a little bit complicated, no, not really that complicated, is if you have a master card that has one harding master and one telephone master. How we do that is the IMS master is going to use the 1 set, so it's going to use Master 1 mic plus minus and Master 1 speaker plus minus. That telephone is going to use the telephone 2 pins. So the telephone on that is going to use the Master 2 tip and the Master 2 ring pair. So telephone is always port 2. If on a combo card, master is always port 1. For masters, the polarity matters. Recommendation is 22 gauge shielded twisted pair. So you can use 2 individual intercom runs, or if you can find it and you can order it, it's actually fairly easy to order. You can get 2 intercom pairs in the same overall cable. So it can be 2 individually shielded pairs in one cable, or it could be 2 pairs with an overall shield in one cable. Both of those will work. That makes a nice, neat 1 cable connection to your master station on your desk. Polarity matters. Same distance limitation as intercom wiring, because essentially from our point of view of our system, it is intercom wiring. So that's a 22 gauge cable gets you a 2,500 foot run. If you are wiring up telephones, most telephones use Cat3 cable, although you can use a Cat5 cable if you want. You're only going to need 1 pair out of that cable. It's going to be a tip and ring going to port 1 tip and ring on that telephone port. And as I mentioned, if you have a combo card, the telephone is going to be on port 2. I've already mentioned the line level inputs and outputs. Line level inputs are typically used for microphone inputs or music sources. Microphone output, or sorry, line level inputs would be microphones or music sources. Line level outputs would typically be paging or call recorders. And then we have additional switch inputs that could be used for anything that a switch can be used for, and additional relay outputs that could be used for anything that you would need an output for. So a light, a relay contact for a door, solenoid, that sort of thing. Our recommendation is 22 gauge wiring, which is good for 2,500 feet, both on the switches and on the relays. The relays are normally open. They're normally open, so when the output is on, the connection is between that pair. For our TBE or talkback expanders, let me take a look at the time. Make sure we're not going. Okay, we're 3:30. Okay. So we're doing good time now. So unlike this morning. So all right. So the TBE or talkback expander is a small expander that has 8 channels of amplified outputs that will hook up to a paging speaker. So there's two connectors on it. Now the connectors are, unlike most of our other connectors, they are not a dB connector. The reason being is that paging can have a higher power output, more than what a dB connector is rated to handle. So instead, we use these Weed-Muller connectors that are depluggable terminal block. You can get them in one of two ways. So when you buy the TV, it has the socket, but it doesn't have a connector that plugs into it. You have to order the connectors. You can order one of two different types of connectors. You can order just the depluggable terminal block, and then you can wire up your speakers directly to that terminal block. And you can disconnect it if you need to change it to TV. It is a disconnectable, depluggable terminal block. But ultimately, it has the 10 screw terminals on a depluggable little block. Let's see if I've got one right here to show you. This one has no terminal block installed on it. But I have something right here. This came off of the status input of a DCC. So this is the depluggable terminal block. It has, you plug it in, and it has screw terminal connections. You insert your wires, and you screw in on the top. So it's depluggable, so you would hook up your paging speakers to that. There are two connectors. The leftmost connector is the first 4 channels, and the rightmost connector is the 5 to 8 channels. So how the connectors are wired up is you got the 1 plus and 2 plus, or 1 plus and 1 minus on the first 2 terminals. You got a space for a shield, and then 2 plus, 2 minus, 3 plus, 3 minus, space for a shield, and 4 plus, 4 minus. And you repeat that same thing for 5, 6, 7, 8. So most cases, paging doesn't use shielded wiring. If you have it and you use it, we have the shield so that you can terminate. But typically, you don't normally use shielded cable. But like I said, if you do, the shield is better. But if you don't have it, not really a problem because you're not really using it as a microphone in most cases. You can, but not really. So your first channel would go on 1 plus and 1 minus. Your second channel with 2 plus, 2 minus. And if you do have shielded cable, then channel 1 and channel 2 would both go to this third pin. Channel 3 shield and channel 4 shield would both go to this third last pin. And same thing for 5, 6, 7, and 8. And if you do use a shield, 5 and 6 shields will go together onto this third pin, and 7 and 8 shields will go on this third pin from the end. Plus and minus are not, just like on the 300 series stations, plus and minus aren't vitally important, but it's good to be consistent, and particularly when you're making a page announcement, you want to make sure that they're in phase so you don't get the odd out of phase and reduced volume as having a push and a pull occurring at the same time, as opposed to all push, all pull, that you get the sound pushing out. So while it technically doesn't matter, it's good to be consistent, particularly if, and in particular if you are using bridging. So I mentioned you could take 2 consecutive channels and make them into a, so the channel, each channel is 5 watts. You can take 2 channels and make them into a 10-watt channel. Or you take 3 channels and make them into a 15-watt channel. So how you do that, so if you're taking channel 2 and 3 and making them into a 10-watt channel, you would wire your speakers to channel 2, and then you would put a jumper between 2 plus and 3 plus, and a jumper between 2 minus and 3 minus to bridge the 2 together, and then you would have your 1 pair of wires going to your field side. Or if you're taking 2, 3, and 4, you take 2 plus to 3 plus to 4 plus, 2 minus to 3 minus to 4 minus, and then you have your pair coming off of 2. And you can do that. You have to do that both in hardware by physically bridging them, and you have to tell our software configuration that you are bridging channels 2, 3, and 4, whichever channels you want. The software will only allow you to bridge consecutive channels. So you can combine channel 1, 2, or 1, 2, and 3, but you can't take 1, 2, and 5. It won't let you do that. So the channels that are bridged have to be bridged together. Once you do that, you only need one pair of wires going into your chain of speakers off of any one of those channels that are being bridged, but the other channels have to be bridged to it. When you do that, you do have to make sure that the pluses and minuses are the same. You can't connect, you want to connect 1 plus to 2 plus, 1 minus to 2 minus. Connecting 1 plus to 2 minus and 2 plus to 1 minus is bad. So that's going to basically, you're not going to get any audio out because they're going to cancel each other out. Rather than increasing the output, doubling the output, now you're making the output 0. So a plus and minus basically means you're going to cancel it out, and it's going to be, you're going to put out no signal, but you're going to use just as much power as your 10-watt signal. So you're using 10 watts to put out no sound. So it doesn't do you any good to have the pluses and minuses switched around. So make sure when you're doing bridging, you absolutely need to make sure that the pluses are going to the pluses and the minuses are going to the minuses. The next one that wire up is a PZE, Page Zone Expander. We already went over this morning, and so basically it's as I mentioned. This is kind of a schematic outline. So with the Page Zone Expander, it does not have a built-in amplifier, so you have to provide 2 additional components for a PZE 110. So you have to provide some sort of line level output from our system. So the line level output could be a master line level output port. It could be a station port adapter, or something I didn't even mention is something called, so this is a station port adapter I'm putting in the bottom connection here. And that has a line in, it has a audio pair in the middle, and has a line output pair on the end. So you can provide a line level output on that. You can use a RCA jack on the MasterCard. And I'll just put this in passing mention, is we have something called a quick connect board, QCB. This is a special quick connect board, QCB 120-6. So it looks a lot longer than the usual quick connect board, which normally it would only have this connector and a DB connector on the edge. So that'll be all like in the size of what I have right here. But this is a quick connect QCB 120-6, and it has these special 4 module slots on it. And each of these module slots can convert 1 to 4 station ports into a line level output or a line level input port. So if you have to have a whole bunch of line level outputs for paging or a whole bunch of line level inputs for music, you can get one of these quick connect QCB 120-6 carrier boards and one or more of these QCA 120 daughter boards. Each of these boards will convert up to 4 channels from a station level, from a station card, to a line level. And these switches, these big switches, determine whether you're going to use it as an intercom port or a line level port. And these little switches determine whether this is a line level input on a 300 series, a line level input on a 400 series, or a line level output. So you can determine, you can make a line level input or a line level output on a 300 or 400 series card with this station port adapter, with this QCA 120. And this will allow you, if you put a board in this leftmost position, you'll get, it'll convert the first 4 channels. This converts the second 4 channels, the third 4 channels, and the last set of 4 channels. So you can convert, if you just have one board in this location, this will convert 13, 14, 15, and 16 into line level outputs, or at least 13. And if this switches on, it'll switch on 14. If this switches on, it'll be 15. And if this switches on, it'll convert 16. So you can convert intercom ports into line level outputs with a QCB 120-6 carrier board and a QCA 120 daughter board. So this is another way to get line level inputs or line level outputs into our system. So once that side note is complete, so with a page zone expander, you need to have some sort of line level output from our system. So most typically on a new system, you're going to use a station port adapter. Once it gets out of our system, you take the line level output from our system, however it is, and you're going to take it to an external amplifier, so a Bogan amplifier or MicroComm amplifier or some other high power intercom speaker, 25 volt or 70 volt speaker amplifier. And now you end up with a 100 watt or 50 watt or whatever the amplifier is rated at output that can drive up to that many speakers. Once you've got that output, you have 3 relay banks on the back of a PZE 110. I'll just show you what they look like on the PZE. So you have 3 relay banks, top and bottom, representing those 3 banks of relays. So each bank has an input. It has 6 switched outputs that have relays on them. And it has that additional key switch that we've mentioned previously. That's kind of completely optional, with our engineers intending it to turn on an amplifier or to unmute an amplifier so that you don't have any hissing sound. So each input bank will have your amplifier output at the minimum. Your amplifier output is going to go to the input pair of a relay bank. Now, if you're using only 6 switched outputs, it will go to only one of the inputs. If you are using 12 outputs from that same amplifier, you would take that same output and you would loop it through. You would parallel that plus and minus to the plus and minus on bank 2 as well. And if you want to use all 18 relays of the same amplifier, you would go and loop it through and plus to the plus and minus on the third bank. Each of the outputs you would wire to your speaker circuit. So maybe 1 or more speakers. Speakers in a speaker circuit are all going to be parallel together. So all 1 or more speakers parallel together with 1 pair of wires going to the switch output, the relay output. The key is optional. It can go to an amplifier enable or a unmute input. And because paging is dependent upon, particularly for like you've got a high power paging like 100 watt amplifier, your wire gauge going to your speakers is going to be dependent upon how many speakers you're going to drive with that. So your wire gauge may be 22 gauge, it may be 16 gauge. You'll have to consult with the wiring table to find out, based on the power that you're going to put on that circuit, you're going to determine what gauge of wires that you need for that. Physically, how it looks is you're going to have 3 banks with an upper and a lower. The lower set of terminals, you're going to have your input pair right over here in the bottom left. And you have your outputs 1, 2, 3, 4, 5, and 6. And then that key switch is this status pair right here. And this isn't used very often, but it can be used for anywhere where you need a relay output. So it doesn't have to be related to paging. It doesn't have to be related to this page zone. You can make it a amplifier enable for this page zone, but it can actually be anything you want. There is an additional input connector on there for switches. This connector is exactly the same as what you have on an SCC 300. So it's the same, so you can use a quick connect board to connect up additional switches on that. This is very seldom used, but our engineers put it on there because why not? One other note, that I forgot to mention on the talkback expander, the previous card. Sometimes, so if you look at this connector from the back, this looks pretty logical. 1 is on the left, 2, 3, 4, 5, 6, 7, 8. No problem. This is logical to me, this is logical to you. One gotcha is on our DXI system. We had a card that operates just like a TBE. We call it a, it's called the TAB card, talkback amplifier board, which is the same functionality, the same thing as a TAB card, TBE card. It has 8 channels of amplified speakers on 2 different connectors. The gotcha is that on the DXI system, the cards are oriented vertically. So if you were to, I can't really rotate this, but if you were to rotate this so that this right-hand side was up, that is how the card is organized on a DXI system. So on a DXI system, this right here would be the top. And when you read from top down, you would go, oh, top is 1, 2, 3, 4, 5, 6, 7, 8 as you go down. 1, 2, 3, 4, 5, 6, 7, 8. So the DXI numbers this connector as 1 is right here and 8 is right here. And DXL numbers it, 1 is right here, 8 is right here. It's the same connector, the same signals. What this means is if you are doing a DXI conversion, you're taking a DXI system that has a TAB card with these same connectors and these same speakers, and you are plugging it into a DXL system, so you're converting to DXL system. When you do your configuration, DXI channel 1 is actually DXL channel 8. So when you are doing the configuration, you have to do a little bit of flipping around as to what channels are this, because of just how you look at it. Just when it's installed on it, this would be the top, which would normally be number 1. And on the DXL, this is the left one, this would normally be number 1. So the numbers are funny. So just take that in mind. That means when you make the configuration, you don't need to change the cables, but when you do the configuration, you need to say the station on this, the speaker on this one is actually on channel 8 when it would have been on channel 1 on DXI. This is channel 2 on DXI and 7 on DXL. Remember that right away, but just keep in mind, something's funny if I'm doing a DXL conversion, ask Darren. All right, now we're going to the end devices. So now I'm just going to make sure we're going to got everything covered here. Yes. Good. All right, I'm going to call a 15-minute break. We're going to, after the break, we're going to do the remainder of the day, which is going to be the wiring the actual end devices on a system. So what we've gone up to a point right now is wiring up the networks and the head end part of the system. Now we're going to do the end devices. And I will get an example of this. So I'm going to start the timer. We've got another 15 minutes to do your business, answer any phone calls or emails, and we'll come back and convene in 15 minutes. All right, I'm back. Does anybody have any questions while we're on the break time?
Hi, can you go back to that PZE 110 slide for a quick comment?
Alrighty.
Thank you.
This one or the previous one?
This one.
All right, time's up. All right, so we're on the home stretch for today. So the last part that we're going to go over is the wiring of the actual end devices. Intercom masters are the most complicated, and intercom stations and like devices. So the first thing I'll go over is a lot of our devices use what we call a mass termination amp or MTA connector. So that's this little orange, this little red connector over here. So it's a handy little connector to allow you to, so it's easy to terminate in the field if you have the right tool. So what you see there is the correct tool for the job. And what it allows you to do is, as the name implies, it allows you to do mass termination of connectors so that you can take, in most cases it's going to be our intercom, so this could be 2 wires that you would basically use that tool. You would insert the connector into this little notch of the tool, which will have the, where is my connector here? There's my connector. No, that's not my connector. There's my connector. Let me go and focus on camera number 2. So on the camera, I have these, this is a pre-terminated connector, but what you would do is, so the connector, you can see those little V-shaped knife edges on the right-hand side. And those are 2 unconnected parts of the connector. So basically what you would do is you would slip a wire into the tool. You see, you slip this in the tool with this facing. You would slip a wire into the tool, which would be above this connector, and the tool would push the wire into the knife edge with the trigger action of this of the tool. So that allows you to basically, you plug the connector in, you plug one wire in, you pull the trigger, it pushes it into the knife edge. You don't need to strip it, and then it advances it to the next position, and then you do the same thing. You put the next wire in, you pull the trigger on the tool, it pushes it in, advances to the next position. Once you do that, you can cap that off with this strain relief. You pop it on, and it's now secure on there. The wires won't pop off of your connection. So that's the notch in the tool is to put the connector in, and then you put the wires in from the top, pull the trigger, advances, it pushes in, advances it. So it's handy, but you need the tool, and the tool is fairly expensive. It's on the order of a couple $100 per piece, and it comes in 2 pieces. So this tool can be used for multiple different connector types, but specifically the black and silver part near the right-hand side. So that is the head, which is unique to the MTA mass termination amp connector, and the pistol grip, the blue with trigger on the left, is the generic. So it can be used for many types of heads, but you would need to buy it as 2 parts. Now I provided we can sell you the tool, but it is basically distributed from TE Connectivity, used to be called AMP or F&O. So you can get the tool from wherever your electrical supplier is. You don't have to buy the tool from us. It's an AMP tool or a TE Connectivity tool. But without this, particularly if you're a maintenance shop and you're doing a periodic maintenance, you can take your connector, You take the strain relief off, and you could poke the wire in the top, use a flat blade screwdriver and push it into the knife connection. So you can do 1 or 2 or half a dozen connections on your own. But if you're installing a complete system without the correct tool, it's a royal pain in the butt. So every installer will probably need to get one of these tools. And this connector is used in a lot of different things. But in particular, it's used on our 400 series intercoms, and it's used on some of our master station connectors. So this connector is fairly common. I'll mention it as we go through the end devices. If you need to order the tool yourself, like I said, here's the part number for the tool. We have our part number, CPG for pistol grip, and the CPH for the head, crimper pistol grip, crimper pistol head. And Amphenol or T Connectivity has part number 58074-1 and 58246-1 for the pistol grip and head respectively. Also, the stations don't come with a connector on them. They come with the terminal for it, but they don't come with the connector. So the connector you get from us in batches of 25 or 100. I don't have the part number for the bag of connectors, but the bag of connectors will typically have, if you get a 25 bag, it'll come with 25 of the red connectors and 25 of the white string reliefs. You can buy the connectors and string reliefs from your electrical supplier as well. So they have an amp part number, just like the tool does. I don't actually have the amp part number on here. But if you wanted to, you can buy the parts separately from the an electronics supplier without having to go through us. They typically want you to buy hundreds or thousands in a batch. So we can supply you with a batch of 25, but we have probably thousands and thousands of those because we have to buy them in a big batch from the supplier. So that's kind of the basics. Is a lot of cases you'll see that MTA connector, and that's the kind of tool and that's the kind of connector that you need to connect up to those devices. So I'll start I'll start with our master station. So our current master station, if you have an analog master station, will be a TMM 441. On the back side of the TMM 441, and I have one right here I'm going to put on the little camera. I have one right here. There it is. I'll show all my system up on. So you see in a little camera what you see on the big picture. So it has the business end of it is the DB9 connector. So that is a master station needs 2 pairs of wires coming from the MasterCard or MCC card on the DCC or DCE. The important pairs you need is the speaker pair, 1 and 6 on that DB9 connector. That's going to go to either speaker 1 plus and minus or speaker 2 plus and minus, depending upon whether this is on port 1 or port 2 of the MasterCard. You have a microphone connection on pin 3 and pin 8. Mic plus and minus will go to mic 1 plus and minus on the MasterCard or mic 2 plus and minus on the MasterCard, depending upon whether you're using port 1 or port 2. These do matter for polarity. So because I'm going to be going over this tomorrow as to how this system detects the switches and how it works. But basically, due to some diode logic on the switch detection and fault detection, is the polarity does matter because there's some diodes on there. So diodes polarity does matter. So you have to make sure that the speaker plus goes on the head end goes to speaker plus on the master, and the microphone plus on the head end goes to microphone plus on the master. So those are the 2 pairs that you need. Now, I've told you that you need to have a shield pair We recommend shielded twisted pair wiring. Now, so you're going to connect the shield at the head end side, but because the ground in buildings does vary, it literally is ground. So the ground potential is a little different depending upon the part of the building that you're in. So a ground wire is kind of special in that you don't connect the ground wire in two places. You connect it and ground in one location only. So the ground on the shield is going to go only on the head end side. The ground on your end wires that go to the TMM, you're going to cut that off and tape it off. So the ground gets to the master but doesn't get connected to the master. And the purpose for that is the ground is a path for interference to the interference will go into the ground wire as opposed to the speaker pair or the mic pair. So that basically provides a path for interference to flow into that doesn't flow into the speaker or master or speaker or microphone pairs. So the ground does not, no, actually no, it's not true. The ground doesn't get connected to the master per se, but we do have these earth pins, 5 and 9. So when I said you cut off the ground, that only applies to stations. That doesn't apply to the master. The master's, your grounds will go to these earth grounds, pin 5 and 9. And what that does is the master is a big stainless steel surface. You have a carpeted control room, and you can shuffle your feet on a carpeted control room. You can touch metal, and you're going to feel a zap. And so that's static electricity building up on you that's discharging through the metal. If you wire those ground wires to the earth ground on here, that connects those ground wires to the metal surface on the master. So that provides a safe path for any static buildup you have to discharge without going through the electronics. So connect your ground leads on a master station to the earth pins if you have a ground. If you want to have, so there is a push to talk switch as part of the master. You can, if you want to have an external push to talk, so say for example you have a foot switch that they want to use, there are 2 additional wires. The external push to talk plus and external push to talk minus. These are optional. You don't need to hook anything up to it. But if you do have an external push to talk switch on a foot switch or a switch on the console, you can wire up that switch to the plus and minus push to talk switch. The other connectors are optional. The DB9 connector is required. So we have a line level output right here. And the line level output, you plug in a 3.5 millimeter jack or 1/8 inch jack between the master station and the line level input on a PC, and now the speaker output goes to the PC. On a TMM 441 and only a 441, not 440, there is there's a patching output. Well, actually, you'll see on this TMM 441, I have a slightly different layout than what you have on the picture. So I have my line level on the left hand, and I have a mic patch through in the middle. So you'll see that the drawing here doesn't actually match the station I have on showing at you right now. So look at the labeling on the back of the master station. So there is the mic patching input is for a feedback suppressor. So it can take the microphone output, it can feed it through a feedback suppressor, and then feed it back into the microphone amplifier input and go into our system. The feedback suppressors, in cases where you have a facility that you have a master station out in the middle of a day room, and so the master station, maybe you have the microphone pointing slightly up. can't really show it on here. So you have the master station in the middle of a day room, and you're making a page announcement to paging speakers also in the same day room. So what happens with that is, as we've heard actually here a few times, you hear feedback. So you hear kind of a ringing noise or a squealing noise where you talk out the mic, you talk into the microphone, it comes out the speaker directly above you, it goes back into your microphone, comes out the speaker above you, it goes back into the comes out. So you end up with a repeated ringing noise or a squealing noise or a horrible screeching noise. And that is feedback. So unfortunately, whenever you have your microphone in hearing range of your speaker, that will happen. And a microphone in the middle of a day room talking to speakers in the day room is generally not a great idea. Sometimes the architect or the specifier says you have to do this. There's a few ways around it. I'll go more into it on tomorrow. But in general, if the microphone can hear the speaker, you're going to have a bad time. And it is very, very hard to get rid of that or reduce that. Now, there are specific hardware devices out there called a feedback suppressor or feedback destroyer, whose entire purpose is to monitor the microphone input and the speaker output and to determine if feedback is happening, and basically it will cut out frequencies of sound that's causing that. Our digital signal processors aren't powerful enough to completely get rid of that. So you need a dedicated feedback suppressor or feedback destroyer. So that's what that line level, the patching input is, the line level microphone input output is designed to go to one of these specific third-party devices that's entire intent is to get rid of feedback. And then so it takes the microphone, the raw microphone signal, it goes, patches through that connector. That feedback destroyer does this work, provides a modified microphone signal that goes back into the system and goes into our amplifier and goes into our digital switch. So that's what that connector is for. Unfortunately, like I said, if you've got something in the day room, talking to speakers in the day room, that is going to be very hard to get rid of without actually a specific feedback destroyer. So just keep that in mind. The TMM 441 otherwise, on the backside, it has a handset connector, so you can have a telephone handset connected to it. Not very often that people need it, but if you want it, you can have a dedicated telephone handset for privacy or to eliminate feedback. On the front edge of the master station is a little connector for a telephone headset with an appropriate icon. So if you want to have a headset, you get a headset for a cell phone with a like is a 1/16 inch jack. It's like a 2.5 millimeter jack. So you get a headphone for a 2.5 millimeter jack, and you can use that with a TMM 441. So that's our TMM 441. The next slide I'll show you is the TMM 440. And I've actually already gone over it this morning. A TMM 440 and a TMM 441 have the same essential basic electronics in it, with the only difference being the connector on it. And the reason that we use the connector and the reason that we stopped using the connector is pretty much one and the same. The reason that we wanted to use it is because it's easy to terminate. But the problem with it is that it looks like a Ethernet connector, and it is not an Ethernet connector. So you don't wire it to Ethernet. You don't use the same wiring that you use for Ethernet. So our masters prefer you prefer to have a shielded wire, and a Cat5 or 5E or 6 cable doesn't normally have a shield on it. You can get specific shielded wire for it, but in general, it's hard to get shielded Ethernet cable. So we discontinued the 440 just because the connector on it looks like an Ethernet connector, and it is not an Ethernet connector. The 441 has some additional features. It has the mic patching. It has the It has a headset jack. It has that is not available with the TMM 440. If you have an older facility that has this 440 with the RJ45 connectors, you can get a 441, and you can get a adapter that plugs into this that provides you the RJ45. So you can take an existing facility that has a 440, and you can buy a 441 replacement, buy the adapter, and you can plug it in without having to rewire anything. So you won't normally buy a 440 for a new facility, but for an existing facility, we still have a few in stock, but in the future, we're going to be only stocking the 441 with the adapters. Now, this, instead of a DB connector, will have an RJ45 connector. And so the TMM 440 wiring manual has the wiring instructions. This is probably pretty small to read, but you're just like the connector on the 441, you're going to only need 2 pairs. You need the speaker plus and minus, polarity matters, microphone plus and minus, again with polarity matters. And if you have an external push to talk, you're going to use the push to talk pair. And if you have any shields, you'll wire them to the earth pair. Ah, there we go. This shows them unconnected, but you would wire them to the, actually there is no earth pair on this one. So you have the speaker pair, the microphone pair, and then the rest of them you're probably not going to use. And this node in the middle is why we stopped using the RJ45 connector, is people think that this is either an Ethernet connector, which is not, or that they can use the same wire, Cat5, to wire up the 2 audio pairs, the speaker pair plus, minus, and the microphone pair plus. And while you can, without a shield, what it does mean is if you got any interference in the wiring nearby, your master station audio could pick up some noise from adjacent wiring without that shield connected. So what you normally would do if you have this type of master, again, another reason why we discontinued using it, is our engineers thought that the best way to do this is you would take your field wiring from your head-end equipment. It would go to your punch down block in your head-end equipment room, and it would end up on a RJ45 wall jack or junction box in your control room. And this would typically have screw terminals on it that correspond to the 8 different connectors on it. So you would wire the head end side to the screw terminals on this in the same pinout that the master is set up. And then you would take a standard straight through Ethernet cable and plug it in between the console mounted jack and the master station. Now, even with the right cable, this cable here could be a shielded cable going all the way from head end to the wall jack or the console jack. But that means that this cable between the jack and the master has no shield on it, which for a 5-foot length of cable isn't normally a problem. But other things that you might find on a control room desk might be things like a 2-way radio, which generates a lot of interference. Or other cables such as power cables or whatever. If the power cable is too close to this master cable, you can pick up a hum from the power cable. So with this chunk of cable being unshielded, it can pick up noise on this chunk of cable. It does make it easy to replace. So if someone trips over the master and they knock it on the floor and they rip the cable, well, you can just simply replace it with an Ethernet cable. So there's that. But that's the reason that we discontinued the RJ45 jack TMM 440. Because it just looks and operates like it looks like it's an Ethernet cable, but it's not an Ethernet cable. The next more complicated master is something you're probably never going to see, is what's called an MAI 425. That's the master audio interface. So that's the guts of a TMM. that can hook up to a console mounted speaker and microphone. You're probably not going to see this. This has a 25 pin connector, but again, you're only going to use a few pairs off of that connector. And it has various connections for your speakers or microphones that you're using on the front. So you have a connection for a telephone handset. You have a connection for the hook switch of a handset. You have connections for your speaker and microphone on the console. You have connections for a headset. And those are all on the front. And these are all those MTA mass termination amp connectors. On this 25 pin connector that goes to your master card, you're going to need 3 pairs of wires going to this connector. You're going to need the speaker pair and the mic pair, just like their TMM masters. Same type of wiring, 22 gauge dual twisted pair. This also needs power, so it needs a 24 volt power source. So you can have a 24 volt power source local, so like a little wall mounted adapter, which will go to the power plus or minus on this connector. Or you might have power in your main equipment room, so you need to have an additional pair going from the main equipment room to this master station to power it. So depending on whether you want local power or head-end power. So you're going to use three pairs off of this connector. You're going to have your speaker pair on 5 and 17 on this connector, your microphone pair on 6 and 18, and then your shields, there's going to be an earth ground. You can connect your shields to the earth ground if you want. On this type of master, the shields and earth ground don't matter that much because there's not a touchable part of this master. In addition to those 2 pairs for your speaker and microphone, you need to have a power supply, so 24 volt DC. And we recommend that you have an earth ground. Well, if you need an earth ground, you can use the earth ground pins. So you'll need the 3 main pairs of wires for that. You need to wire the appropriate speakers and microphones that you're using. So most commonly, you're going to have a console mounted speaker microphone on this connector here. As I mentioned previously, if you're using a Harding speaker and microphone, you're going to supply the right microphone and speaker for it. So it could be a 45 ohm speaker and a electret or condenser microphone. If you're using your console, one that's provided with your console, make sure it's electret or condenser and not a dynamic microphone. The speaker and microphone, the polarity does matter. It's not the same as what's on that 25 pin connector. This 25 pin connector is a pre-amplified. What's on here is a raw microphone and a raw speaker, so it's not a pre-amplified. A push to talk is available on a few locations. There's the center pins on this handset. There is a push to talk on the headset connector, and there's a push to talk on the back of the DB25. So if you have an external push to talk, there are multiple places to put it. So that's all the connector location for the 425s right here. The next one is just a little step up from the 425. So sometimes you might have a console mounted master station that you want to have a keypad and display on. So the keypad and display component is called an MEI 130, or sorry, IMS 130. Yeah. So it's the same as the MEI 425, which has no keypad display. It's the same other than it has a keypad display on it. So the only difference that you're going to see is going to have the same speaker and microphone connectors on the front. It's going to have the same DB25 on the back. You're going to be using an additional pair on that. And on the side here, as soon as I find my cursor. So on the side here, there's going to be a ribbon cable coming off of it. And that's going to go to the keypad and display. So you just plug that into the keypad display ribbon cable. But Other than that, it's almost exactly the same as the other master audio interface, the 425, the keypad-less one. The only difference is it needs one more pair of wires that's going to go to your LongWorks connection for the control of the keypad and display. So you still need 2 pairs of wires for the speaker and microphone. You still need 1 pair of wires for the power. And you'll need an additional pair of wires for the LongWorks network. So this would normally go to the orange LongWorks connector on the LongWorks card installed in the DCC for this exchange. So that's the only difference, is these 2 network pins for the data that the keypad and the display use. The earth ground, again, is optional, but because the master audio interface is a stainless steel device attached to your console, if you do connect the shield grounds to this earth ground pins, then that will shield that that metal surface on that. Now, normally your console itself is going to have a shielded surface on it, so this is completely optional. If your console is grounded, then you don't need an earth ground, a separate earth ground for that. It's exactly the same front panel connections on it. The last one that I'm going over for the analog masters is our desktop, our IMS 440 desktop master station. I don't have a picture of that. That's what I have right here. So this big, ugly, industrial-looking master station. So we've already seen the connections for this. This is the same thing. It's actually the same circuit board as the MAI 420 and IMS 130. It's just rather than as 2 pieces, there's 1 integrated unit. So you have a 25-pin connector on the back. All the speakers and microphones are already connected inside. So really all you need is that 25-pin connector that you wire up the same way that you did with the MAI 420. This one does have a nice big stainless steel surface on it. So you want to ground that out by connecting your shield grounds to the earth ground pins. I'm not sure, other than maybe if you're maintaining whoever's maintaining Lethbridge, you might have a few of these over there. And if you don't ground this, what will happen is that you'll build up a charge on a carpeted surface, you go touch it, you zap it, and because there's no direct path, if you don't have a ground hooked up to the earth ground pins on that, there's no direct path to ground, so instead it finds the closest it can, and sometimes it goes through the circuit board, through the electronics to the ground. So initially, maybe the first year or 2, so what? You get a zap when you touch it, nothing happens. After a few years, it actually starts wearing the electronic components down as these zaps go through the electronics. So after a little while, you might see that you build up a charge, you touch the master, it goes, you feel the zap, and then you see the master reset itself, and then it comes back up again. So that's indication of that the master is starting to get damaged. It's weakened such that when that zap happens now, it loses power and it restarts itself. You do this enough for enough years, and ultimately you touch it, it goes zap, and it's dead. Come back to us for repair. We've changed a few components and it's back up again. So without the earth ground on this type of master, it will eventually, or may eventually, cause issues with the master just because it gets damaged when the static charges are applied to it. So just as a note, if there is an earth ground and you have a ground available, use it. All right. And I just moved that camera. There. All right, next is 2 intercom stations. So all of our intercom stations, as we do board designs, the physical layout, possibly even some of the text may change a little bit from time to time. You'll see two variations of our intercoms here. You have one variation of our ICE intercom and one variation of our ICM intercom. So the boards look the same, but the boards may look different, but the connectors are the same. So I'll get one example up on the little camera. Where's my intercom? One. Another one. Oops. There it is. Not oriented the same way. All right, so our intercoms is you're basically going to have one pair of wires going to it. You have a shielded twisted pair. Polarity matters, plus and minus have to match what's on the head end. You're going to have a match termination amp connector that's going to plug on. The outside two pins closest to the edge of the circuit board is where your wires are going to terminate to. So you have a plus on the outside and a minus on the inside. And really that's all you need to do is you terminate your wires to your mass termination amp connector or MTA connector and you plug it into the intercom station. And that covers most of the intercoms. Now you'll notice that there are 4 pins on that connector. So some of our intercoms, like our full duplex handsets or FDH intercoms, do require 2 pairs of wires. So it does require 4 wires to those. So we have our connectors are kind of common that they're all 4 pins. But for most of the stations, you're going to need only two of them. And the reason that we put 4 pins rather than 2 pins is for 2 reasons. Number one, the connector is a friction fit onto the pins. So 4 pins means that there's twice as much friction keeping the connector connected on the pins. So for cases where some cases you got maybe this is installed in a door jamb and the door slams and the frame vibrates a little bit. So with the friction of just 2 connections, it could shake loose a little easier than having friction on 4 connections. And the other reason is the connection on this 4-pin connection is actually on the circuit board. The inside, the inner 2 pins are actually internally connected and the outer 2 pins are internally connected. So if the way you're supposed to connect to it is to take the wires on the outside edge of the circuit board. So that's what the 2 wires should be. But because the inside 2 and the outside 2 are connected, if the installer goes, they change out the circuit board or they change out the station and they flip it around, so now the wires are on the inside 2 pins, they're still connected to the right places. Even though it's flipped around 180 degrees, it still works. So that's kind of a fail-safe in case whoever is replacing the intercom forgot which way it went. It actually will work both ways, as long as the outside pin is the plus and the inside pin is the minus. If they actually crimp this down such that the minus is on the outside, it's not going to work. There are additional connectors depending upon the option. So this covers most cases, but some cases we have an option for an external push button. So you might have a built-in push button and you have a push button that goes to another intercom or to just a call button on the wall. You might have what we call a master-slave intercom. I mentioned that this morning. We had the question, what if I want to have 2 intercoms in the same wire pair? Well, you can do it. You have the first intercom hooked up with this connector as usual, and then you'll have another 2 connection points that will go between this intercom, which is the actual Harding intercom, and a speaker and switch intercom, which is just an additional speaker and additional switch that are off the same wire pair. So in that case, the primary intercom on that pair would have not only this one connector here, but it'll have an additional connector for connection to the other station. So there may be additional connectors to do additional things, but for the most part, you're going to see one connector and you would use the one connector. You can look at the data sheet or the installation manual for the specific intercom you're looking for. If you got a custom intercom with additional switch inputs, or for an input for an external input, or for a primary secondary intercom, you can look at the installation manual for how to wire that additional connector. But one connector is always going to be common. So you have one pair of wires going from the head end to the intercom. You can buy just the intercom board to convert a standard intercom into a Harding intercom, and it'll have the same connector to connect to the head end, and it'll have additional connectors for your switch and additional connector for your speaker that you're using. So it just basically takes the internal connections on this, and that you can basically make an external connection. So look at the labeling on the board will tell you what what each connector does, what each pin on the connector does. So you're always going to need that 4-pin connector for the head end connection, and then you may have the optional connectors for additional switches, additional speakers, your LEDs, or whatever you want. A IEB connects to an 8-ohm speaker, and ICB connects to a 45-ohm speaker. And just like everything else, all of our intercoms can go up to 2,500 feet. And here's that primary secondary that I mentioned. So you have a primary intercom on the left. You hook up that 4-pin connector just like you could hook it up to a regular intercom. And between the primary intercom and the secondary intercom, you have 2 wire pairs, one for the speaker that goes to the secondary speaker, and one for the switch that goes to the secondary switch. You can configure it 2 ways. You can have the switch paralleled exactly with the primary switch. So both switches do the same thing. Or alternatively, you can have it as the other switch. So if the primary is on the switch number 2, you can have the secondary on switch number 1, and then you can uniquely identify whether someone pressed the primary button on the inside of the door or the secondary button on the outside of the door. And then you can show your icons appropriately. When you answer the intercom, it's the same speaker, they're parallel, so it will be always on both speakers, but you can at least identify which button was pressed. Our full duplex intercoms have that 4-pin connector, but now you do need 2 pairs of wires going to it. So there's 1 pair of wires going for the handset speaker and 1 pair of wires going to the handset microphone. That will be on 2 consecutive ports on your station card. So if you have a full duplex handset, say on port 1, it will actually use port 1 will be the speaker pair, and port 2 will be the microphone pair. So it's always the next pair up is what the microphone pair is going to be. So you have the 2 pairs wired up. Your speaker pair is going to be on the outside wires. Your microphone pair is going to be on the inside wires. Or speaker plus, speaker minus, mic plus, mic minus. This one does matter if you flip it around, unfortunately. So this one, you have to make sure you've got the orientation right. And it connects to 2 consecutive ports of a station card. 300 series wiring is even easier. If you're using a third-party intercom, it's going to have a speaker and a transformer on it. You're going to hook up, typically on those, you're going to use a wire nuts. You take your field wire with wire nuts going to the speaker, to the transformer wires. You're going to take your switch wires, and it's either going to be a screw terminals on the switch, or it may be another set of wire nuts that goes to the switch. You have a speaker pair that goes to the transformer, and a microphone pair and a switch pair that goes to the switch. Depending upon the type of, if you buy a 300 series intercom from us, there's a few different types, so you want to look at the installation manual for that particular intercom. But the one I have right here has the switch and speaker internally connected with this one connector already. And there's another one of these familiar mass termination amp connectors that has your switch, your head end, switch, and speaker connector. So in this case, you'd have a 4-pin terminal block, MTA connector. The other 2 pins would be, I believe these are a little confusing, is that the outside 2 pins are the speaker and the inside 2 pins are the microphone. But you need to look at the specific intercom that you have as to find out what pin the switch and the speaker are. But that's what this specific one is. The polarity doesn't matter, but it's good to be consistent. So if your intercoms, if your +1 is on the outside edge, then and the inside and the minus is on the inside edge, if you do it on all of them the same way, then it makes it nice and consistent. You see on this one, 1 is the plus, 4 is the minus, and then 2 and 3 are the switch plus and minus. But look at the installation manual for your specific intercom to make sure that is the case. And okay. So just a brief outline of how our intercoms work. I mentioned that, you know what, I'm going to cover this tomorrow because this is going to be on tomorrow's case too. All right, so the last part is going to be our IP devices, TMM 640s, 641s, IMS 64041s, and intercoms. So start with, all of our IP devices have an Ethernet port on them. So that's where you're going to connect to. It's a standard Ethernet port. You wire your RG45 up to standard Ethernet specs, and you're going to have your field cabling coming from your network switch to your master station. Master stations are going to have 2 connectors on it. One is going to be a power over Ethernet enabled connection. That's going to be on these TMM masters. That's the bottom connection. And you're going to have a pass-through connection that can go to a PC or another master station, but it doesn't provide power over Ethernet. So this second connection was only a 100 megabit connection. So connecting it to a PC, yes, you'll get a network connection to it. No, you'll not get a fast network connection to it. So not entirely useful, except for maybe troubleshooting, diagnostics, etc. If you want to, if there's a facility and the staff goes, oh, hey, I can plug my laptop in here and I can browse the internet. You can prevent them from doing that. We do have an option in the configuration, in the web configuration for the masters, that you can tell it to disable that second port, so that someone plugs something into it, they're not going to get anything off of it. As for the rest of the connectors, it's exactly the same as our TMM 641 or 441. It has a headset connector, it has a patch connector, it has a line level output connector, and it has a power connector. The power connector isn't on a TMM 440, but it's only on this one. So if you don't power it with power over Ethernet, you can use this DC power connector to connect up to a local wall supply. It has the same headset jack on the front, and use a 2.5 millimeter headset jack. So both our TMM 640 and TMM 641 have the same layout, with the only difference being the TMM 640, the older one, does not have the microphone patch through jack. Like our 400 series, we have an MAI, master audio interface, for our IP intercoms. You have your 2 Ethernet jacks, one that has a power over Ethernet and one is a pass-through. You have a headset jack, you have a handset jack. Unlike the 400 series master audio interfaces, we have the MAI 620s have a push in, push out style connector. This isn't the same mesh, this isn't the same thing, but this is the same connector. So these have basically you would insert a strip wire into one of these holes, and it would push this little spring in and clip in the wire. If you need to remove a wire, you just push in this little button here, and that'll pop the wire out. So this is a nice connectorless, toolless way to connect up, rather than using those MTA connectors that need that special MTA tool. So the master audio interface, some of the additional connections are this push in, push out style connector. So we have a line level output, a line level input. We have a relay output, actually 2 relay outputs, that they are triggered by the same output. They're triggered the same way. So it's not 2 separate relays, it's 1 relay that triggers the 2 contacts. We have a switch input. So that could be used for something like a call and end switch. There is a dedicated push to talk input, so you don't need to use this for push to talk. Although you could use an external push to talk on it. And if you don't power it with power Ethernet, there is a power pair on this push in, push out, and there's also a barrel jack power connector. So you can use either or, depending upon what you've got for a power source. The speaker and microphone is a RJ jack. So instead of having a MTA connector, it's got this jack on it. When you buy one of these MEIs, or specifically when you buy the speaker for it, you'll get I don't think I have a picture of it here. No, I don't. When you buy the speaker for a master audio interface, what you'll get is a wall-mounted modular jack that has a jack with 4 screw terminals on it. And basically you're going to wire up your speaker and your microphone to the appropriate pins on this speaker mic connector. You're going to wire up your volume control to the appropriate pins on this, and you're going to wire up the push to talk. So those will wire up to that little jack that you mount in or on your console, and then it also includes a standard RJ cable that connect between the speaker mic connector and that console mounted wall-mounted flush mount, whatever you want to call it, RJ jack. So you'll connect 2 screw terminals on the jack for your speaker pair, your mic pair, your push-to-talk pair, and there's a volume control knob. We have an optional switch panel interface that works along with the MEI 625. And you can do a few things with it. So you can use it to drive a graphic panel that has a bank of LEDs and a bank of switches that you can use as a limited function control station. So this has 16 switch inputs with those push-in, push-out connectors, and 16 LED outputs with the push-in, push-out connectors that you can wire up to your control panel, graphic panel switches, and your graphic panel LEDs. Between the SPI and the master, we have what's called a 1-wire connector, which is actually a 2-wire connector, because there's 1 wire which is the data and another wire which is the ground. And that will go between the status in of the MEI 625 and this 1-wire connector, which is 2 wires, which has a data signal and a ground. And that's how it sends its switch information and sends the LED outputs is through that connection back to the Ethernet connection on this MEI 625. So this allows you to have additional switches and additional LED outputs, mostly for a graphic panel. Another option for this is you can get a telephone style keypad that will hook into the first few outputs and the first few inputs on this that will allow you to dial up intercoms with a console mounted master station. So you can look at the keypad installation instructions for how to wire that up. Our IMS 640 and 641 master stations, they look the same. They have the same component. They have the same outside shell on them, just a little bit different internal electronics. They operate just like our other master stations. They've got 2 Ethernet ports on them. They have a built-in speaker and mic, a built-in telephone handset. In this case, the top port is your power Ethernet port, and your bottom port is the pass-through port. But it works the same. You got a PoE port, you wire it up. You got a pass-through port, and then if you don't use PoE, you have an external power input on the bottom too. Your telephone handset, and if you have a telephone headset, we'll plug into the headset connector on the bottom. And there's an additional connector if you have an external foot switch for push to talk. On the front, there's nothing really to do with these because it's basically a self-contained unit. Last, we're on the home run here. Second last is the PTA or paging talkback adapter. Well, that's what I actually have on this lab here right now. So that is an Ethernet paging amplifier. So like our other Ethernet devices, it has an Ethernet port on it. Only one. There's no pass-through on this. You would normally power this with power Ethernet. But there is a push pin, pin for external power. But it's not very practical to have external power on this because you don't have an outlet. You'll need to bring in a pair of wires from somewhere to do that. And if you're using power Ethernet, you've already got Ethernet to it. You have a push pin set of connectors for your speaker pair. So your 25 volt speaker, up to 5 watts, will go on this connector. If you want, we have a line level output and line level input. So instead of powering, if you need more than 5 watts, you can have an external amplifier. You can take a line level output from this into the amplifier, and then from there into a speaker. If you want to listen to this as a microphone, you can have a microphone mounted as part of on the speaker. Now, normally you use the speaker connection, you can use the speaker as a microphone. But if you're using an external paging amplifier, that doesn't allow you to do listen or talk back on it. So if you're using an external amplifier, you can mount a separate microphone, and you can take the microphone to a line level, So make sure it's either a line level microphone or it has a line level preamp. Take the output of that microphone into this line level input, and now you have two-way talking. So you can talk through your paging amplifier to your speakers, and you can listen through the microphone as a listen back. There are, again, a single relay that has 2 output contacts on it that you can use to turn on a relay. You can switch between up to 2 speakers, so you can kind of, it says it's kind of a very light version of a PZE. It has 2 switch inputs on the status input, so you can have call switches hooked up to this. And then, did I miss out? I must have missed out a slide for our IP intercom. So our IP intercoms are actually even simpler. That's probably why they don't have a slide. So our IP intercoms have an Ethernet jack. Plug that into a PoE Ethernet, and away you go. Now, our more complicated versions, they do have an additional connector on them. So if you buy an enhanced version of this, it can have 2 buttons on the main board, and it can have a connector that can add another 2 buttons. So that if you have an enhanced version, it will have an additional connector that has some additional features. So it has a power connector on it. If you need external power, it'll have 2 additional switch connections. So there will be a connector for that. You can look at the ICE 600 installation manual for what those additional connectors are. But for the most part, you have an Ethernet jack. All right, and then the other part, okay. This again probably can be covered tomorrow, but my engineers tell me that, particularly our quality assurance engineer says that whenever you're handling circuit boards, I don't want to do that with this one. I'll get my dead one here, wherever the dead one is. Whenever you're handling circuit boards, handle it by the edges. Don't handle it by touching the components. And more for our DXI systems, if you have to handle raw circuit boards, so if you are changing out boards on a, say, a DCC, we recommend that you have a static strap on. You have a static strap connected to a local earth ground, and then so that allows you to discharge any static through the static strap rather than through the components. Shielded wiring does help a lot to prevent interference from outside noise. So other wires in the same conduit, AC power run nearby. If you're using 400 series masters and stations, make sure that plus and minuses are correct. And something I haven't mentioned is that when you do have wiring going outside the building, we recommend that you use a surge suppressor or a transient suppressor or whatever you call it in your local area to prevent spikes from going through the wires to damage the equipment. So the surge suppressors are basically, you need to only really use this on wiring and in actual wiring that's going outside the building that has possibility for a lightning strike nearby to hit the ground, get induced into the wire, go through the wire, and then burn out the equipment. So the surge suppressor is supposed to burn out, is supposed to prevent that from happening by causing an immediate short, which will prevent that high voltage to go through the electrical equipment. So we recommend that anything that is going outside the building should have a surge suppressor on it, particularly at the head end side. So if you have an intercom going to a vehicle sally port outside, you put a surge suppressor across the intercom wires coming into the equipment room so that if there is a lightning strike nearby, it's not going to burn out the station card. Our intercoms are a 25 volt intercom with some DC on them, and I'll get into that tomorrow. But that essentially means you want to have a surge suppressor that can have at least 48 volts before kicking in. If it's less than 48 volts, then it could kick in when you have regular operation and you'll have your audio cutting in and out, and you might have incorrect operation. So I have some suggestions. If you need to have any on your own, you can let me know. I have suppliers may be different for different areas. So the ones that we've spec'd out, we've looked at are by Citel, C-I-T-E-L. There are plenty of other manufacturers, but I can give you general specs as to what you're looking for if you need to have a surge suppressor. The next part is all going to be covered tomorrow. So that is what I have for today. I know it's a long day. Unfortunately, I'm sorry for the making it a little too long in the morning. But we're at the point where you can now leave for the day. If you've got any further questions, you can give me a shout. Before I do anything further, I did mention this morning that if you can install the DXL administrator software. So that's available on the download site. The software that you're looking for is the DXL administrator setup software. So I'll start with DXL administrator setup and then the version number. Now, depending upon your network and your IT staff, we have two versions up. We have an exe file that if your administrator isn't too strict, that you can directly click it and install it. If your internet prevents downloading exe files, we have a zip file which has the exe file in it. So you can download a zip file, unarchive that to get the exe file, and then you can double click that. And double clicking the administrator setup, you just install the software. Yeah, I'll do a quick launch shortcut. You can give it a, you can have multiple versions installed on the same computer. So if you're maintaining multiple sites and you want to still keep the software associated, when you install it, you can put a, basically give it the version number that you're going to install, and they can be all installed at the same time. And you just start up the appropriate software when corresponding to what you want on the site. Let's go. There. And the important thing is when you first run the software, you may get a prompt for your firewall settings. So make sure your firewall is permitted to, your DXL administrator is permitted to go through your firewall. So the DXL administrator is going to be installed in the Harding Instruments folder, if I recall. Here, MicroComm DXL administrator. So when you first start running it, if you get a firewall prompt, make sure that you answer it to permit it, the firewall through. That will help a lot when you do, when we're going to do the DXL administrator software tomorrow. So install that. If you get any problems with the firewalls, you can talk to your IT guys in the morning before the session starts to see if you can get it fixed up. That will prevent any. A lot of cases we have people that they can't get it running, and we spend the first few minutes trying to troubleshoot a particular person's problem with that. So if we can get it all installed, that will save us some time tomorrow. All right. So tomorrow morning, we're going to go into how to plan a new facility. So you're going to go through what you need to do to plan a new jail, what you need to do, how what kind of information that you need, and how to use the DXL administrator to create your specific jail's configuration. So that will be the morning, is using the DXL administrator software. So if you've got your own computer or a laptop or your workstation at your office, you can use that with the DXL administrator software, follow through. If you have equipment, that's even better. You can follow through in the afternoon and loading your configuration on your equipment. But that's optional, but having the software to do at least the software is quite helpful. So tomorrow morning is going to be the DXL administrator setup. Tomorrow afternoon is going to be the installation, using the administrator software to load it on the system, to configure your system, to troubleshoot, to look at what you would see in the logs, how you troubleshoot, what the process for finding out the problem and resolving it. So that will be tomorrow afternoon. Tomorrow morning is the DXL administrator. Thursday morning is going to be the host interfacing. So if you're controlling it from a touchscreen, that's going to be Thursday morning. All right, I'll let you go for the day. If you got any questions, feel free to let me know. If not, you can ask them tomorrow during our breaks as well. So